Everyone. Can you guys hear us okay? Can you hear us okay?
Good?
Yes.
Okay.
Okay.
Perfect.
Perfect.
There's a lot of background noise, so.
Welcome to our first Cisco U Theater session. My name is Kareem Iskander. I lead technical advocacy for Learn with Cisco.
And I'm Quinn Snyder. I'm a senior technical advocate. I work with Kareem on the advocacy team within LWC. And so we've put this session together that's, we've talked a lot about individual automation tools and how they can speed up your workflow or do one thing well. But we've noticed as we've gone through both our personal automation journeys, working on our certifications, that there's a gap. And that gap is how do we put all of these seemingly independent things together and tie them into one larger automation tool chest that you can build upon to further your automation studies. And so we put this session together. We're gonna talk a lot about here. We probably won't get to the bottom, but we'll talk about Git and how some of the advanced tools there can help your workflow. We'll talk about my favorite tool, Bash. It's still relevant even 40 years later. We'll talk about HashiCorp Vault, infrastructure as code, and containerization. We probably won't get to the bottom around Kubernetes, but it will be included in the slides, so you can review that in a little bit. But that's kind of what we're going to talk about, those 5 tools and how they all come together at the very end.
So this is a real conversation that Quinn and I had. We've been talking about network automation for a while now, and we've always wondered how is it actually used in the real world. And Quinn mentioned the different tools that we've been talking to you about and how you should incorporate it. So we decided to say, well, why don't we just level up and build on those skills to show you what you're actually going to be using and needing in your companies as you're automating. And this is where we get started with some of our tools here. So if you look at Git, if you followed our journey from an automation perspective, you know, we talked to you about Git. Who's here familiar with Git by now? How to use it? A little bit? Okay, it's no problem. So if you are automating, Git is one of those tools that you need to start with and you need to know, right? This workflow should be something that you know like the back of your hand. So you start up, we talked to you about starting up from GitHub. There's somebody has a code somewhere, there's a repo, you want to clone it, so you bring it down. There's what the concept of branches. It comes down as a main branch. From there, it goes out and you essentially start coding, and you live in this triangle where you make changes to your source code, you git add, and then from there you git commit, and then you just continue doing. Now, this is, in concept, is the foundation of Git, but when you start building production-ready code and you start developing as a team, you're going to need a little bit more than that, and this is where you upskill. So we've talked to you about, you know, pull requests, merge conflicts, commits, logs, push, head, branches. All of these are terminologies that you're aware of. Now, when we're automating, there are a couple of things that I really think that are super important as you're working and collaborating with a development team. First of all, interactive rebase. This should be a new concept for you if you haven't seen this before, but interactive rebase is kind of the Swiss Army knife of all the Git commands. It allows you to do things like change commit message, delete commits, reorder commits, consolidate and split commits and branch out. And so it's really, really powerful, and it allows you to manage those commits that you have, so you don't have to start from scratch if you mess up. And the way that you do this is as follows. So before we get into the nitty-gritty of how to use it, let's talk a little bit about this use case, okay? So you're working on a feature branch to expand your Meraki automation. You need to be making commits every function, and you've been making commits every function, and you're ready to merge into main. Now, your manager told you that you have to basically keep your commit concise. Now, you realize you've overcommitted, and as we know from Git, when you make a commit in the main in your branch, and as soon as you merge it into main, all these commits get copied over. So now your main is overloaded with commits. And then also you've realized that you haven't been making good commit messages. Now, sure, you could go back and take out the changes from your code, move it to your desktop, delete the entire working directory, and reclone and move your files and make one commit. But that's really not clean, right? And this is where interactive rebase comes in handy. This is how you do it. So first of all, you need to understand the head concept. Who's here familiar with how head works? So head pointers are basically where Git knows where your commits are, right? The latest commit that you've done, the latest snapshot that you've taken is always at head 0, and then it goes 1, 2, and 3. So in order to access those commits that you're after, whether you're trying to change a message or delete it, what you're going to need to know is you're going to need to understand which head pointer to move your pointer to. So you go in and you say git rebase -I, which is for interactive, and that's gonna, and then you tell Git, I want to be able to access the first commit all the way to the third, or all the way to the second. And so if you say head 2, for instance, you're gonna have access to 0, 1, and 2, these last 3 commits. And then you get to decide which of the 3 ones that you've provided you access to do something with, right? And then you go in and you determine the action. Git is going to show you, and I'm going to show you in a demo here how the action, the different actions that you can take on top of your commit. And then you want to see those changes. One of the things that I really encourage everybody to use as you're adopting some of these new skills, new commands in Git, is to understand git log --1 line is going to print out things nicely in your terminal, and you're going to be able to see what you've changed or not. Okay, so let's try it real quick here. So you go in and you go git checkout feature, git log --1 line, and this is going to pull all my logs, my commits so far on that repo. And I've noticed a couple of things. I have so many commits that are unnecessary. Also, I have a typo. So I want to be able to fix the typo first in my commit message. So I can go say git rebase -I head 1, because it's the first one that I need access to. And notice how Git gave me access to the commit message and that commit hash itself. Now I can use a couple of verbs. I have pick, reward, edit, squash, fix. I have so many of them, and it tells me what I could do. For me, I need to reward. I need to reward my commit message. And in this case, I could go in and say, okay, now I have access to my commit message. I can fix it. I can save it. And at this point, my commit message has been cleaned up. And if I do git log --1 line here again, you can see that my commit has been updated. So that's a clean way to do it. Now, let's say we want to get rid of some of the commits that we have there, and we want to delete them so we can keep our commits clean before we merge into main. This is where we can do git rebase. We can use squash, the verb squash, and we can do the same steps. So git rebase -I head, at least I could go to head 3 or head 2. And I really need to take some typing lessons.
You do.
Super slow. But if I go here and I look at this commit, I need to basically squash that. And what Git is going to do, if I edit the verb and squash it, it's going to literally squash. It's going to take this commit and the one below it, and then put them together and squashes it. So now I've cleaned up my commits. What happens then is the next window that Git asks you is, because there are 2 different commit messages, you need to decide which commit message you want to keep and attach to the squashed commit. And so you're basically clearing out the one you don't care for, saving that commit, and then if you do git log --1 line again, we've gotten rid of the unnecessary commit, and now we have a clean git log that we can start essentially moving into main. Make sense? It's a really, really useful tool. Another one that I want you to learn, and you're going to be using a lot in production, is cherry picking. So anybody familiar here with the cherry picking concept? Okay, it exactly sounds like what it means is you're literally cherry picking the commit that you want, and you're moving it somewhere. So you have 10 commits. I care about commit 5. You're going to cherry pick that one and move it, and that's how we do it. So let's look at this use case. You're working on a feature branch. You have made commit on the feature branch, but you realize that you've been working this entire time in the main branch. And it's a big no-no when you're working in production to commit everything to main. You have to branch out, do your work, and then merge, right? Especially your integration manager is going to probably put that rule on you as you're developing. So now if we go next, this is how cherry picking, cherry picking essentially works. It allows you to basically select individual commits, and it allows you to integrate the commits to different branches. So let's see how this works. Again, your best friend git log -- one line. You need to pull that log to see which commit you want to cherry pick, so you can grab the hash. You go on the branch that you need to be on. So I've committed in main. I want to move from main to feature, or the other branch. I need to be on that branch first. And once I'm in that branch, I can say git cherry pick, and then it'll move it inside that branch. Okay? So let's see it live real quick here. Git log -- one line, it's going to show me all of these commits that I have. I'm going to go create, touch a new Python file. I'm going to create something. So some new feature.py. My branch changed, so I git add and git commit. I've realized that this entire time, if you notice, I'm working in my main branch here, and this is not supposed to happen. So if I go git log -- one line, my latest commit is there, but oops, I'm in main branch. So that needs to be in my feature branch, not in my main branch. So I can go ahead and go git checkout.
Slowly.
I could go slowly. Git checkout feature. And now I'm on my feature branch. I can say git cherry pick, and I know the hash for this latest commit. I can copy paste that in, enter it. So now at this point, the commit is in my feature branch, and also the same commit is in my main branch. Now, what I need to do is I've already moved it, so I'm safe. I can go back to my main branch and just kill it, right? And there are different ways for you to kill it. You can reset the head, or you can use our interactive rebase to squash or delete. So you can use either, whatever you're comfortable with. In this case, I just go git reset, and I basically reset that latest commit, and I've cleaned out my, basically cleaned up my main branch, and now I can continue working on my feature branch and continue building on top of that. Okay, does that make sense? Cool. So these are really, really powerful tools that Quinn and I have used in production as we're developing and writing automation code that I think you should start practicing and get to know.
All right, so now it's my turn. Now that we've had Kareem talk for a bit. So I got started, before I was in networking, I was into Linux and Unix system administration. And I have this love for the bash shell. And so what we've been talking to you about, so we have all these new concepts out there in terms of our network automation, or maybe our application deployment. We have things like Docker files. We may use GNU Make. We may have some kind of CI/CD pipeline. Each of those things is somewhat different, but they all have something in common. All of those commands, so yes, there are different, like for a Docker file, we have these Docker verbs: copy, env, run, change, workdir, or command. From our CI/CD, we may have to wrap these things in bash or in YAML, like this over here. We have this install tutorial conversion tool. But at the end of the day, those commands that they're running are being invoked by the overall application to run bash commands. It's the power of the internet. It always has been. It always will be. We've just put it into different areas. So it's all been bash. And when people say that we need to learn Linux as network engineers, what they really mean is we have to be familiar and comfortable with the bash shell. So what's old is new again. It's always been bash. It always will be bash. And this book I have used more often than any other book I've saved from my college education. They're on like 5th edition now, but I had the 3rd. It was a really good, no endorsements, I'm not paid, but it's a really good primer to how to automate and do scripting in the shell. So sed, awk, passing one-liners, variable interpolation. All of that's covered. It's a great book that I still use today, and it's thumbed on, and Kareem makes fun of me for it. So at 36, probably 37 years now, Bash is still going strong. So everything that we've entered in the Linux CLI can become part of a shell script or a CI/CD command. So when we do like a CD command at the Linux shell, or if we invoke a Python script or an Ansible playbook or Terraform, even though we're typing those commands to run that program, we still have to know how to operate those things in Bash. Because, like I said, our Docker files, our CI/CD pipeline declarations, they are all running Bash. Because our CI/CD, it sounds really fancy, it's just a container. It's a Linux container that runs a process. And because it's Linux, we need to know Bash. So from a practical application standpoint, we can use Bash to build locally. So this is that Docker file example I was talking about earlier. In this case, I'm doing a Docker build. So I'm taking that image or the Docker file, and it's going to build a Docker image. And you can see if you've run like an apt-get from a shell, or you've run echoes, you can see that those commands look really familiar. I'm reaching out to the Alpine repositories. I'm updating my files. I'm installing OpenSSH and wget. All of those things are happening because I called it from the Linux shell. I'm installing some tools for Python using pip. Again, invoke from the Linux shell. So we need to understand that and understand it well. Bash can also build in the cloud, and this is a fancy front end. So when Kareem talks about the integration manager for Get, how many folks have used Cisco U at all? U.cisco.com? So they have free tutorials. And those tutorials that we write, Kareem, myself, and others, we write them all in Markdown, but we have to publish them to our Cisco U. We do that all through a GitOps-driven process. We write in Markdown, and we push it to GitHub, and that connects to Cisco U to publish. So this is a fancy front end that we use to build all of our tutorials. Now, it may look like we're doing things in GitHub here, and we are, but at the end of the day, if you follow in after I click on that, you can see after the job starts, it's invoking a Linux container. That Linux container is running commands to download some files that we use. It's doing an update. It's performing some linting and translations from Markdown to XML. And then it's saving those things to artifacts, and all of that has been written in Bash. We may have to write it in YAML, but we're invoking Bash scripts via YAML. And when I die, I don't care about you clearing my Claude chats to figure out how to do things, Kareem. Just clear out my dev folder to make sure that people can't see the really bad things I did with Bash.
I got you, Quinn. I got you. All right. So one of the things that you're going to encounter as you're automating and you're building scripts out there, you're never going to use just one service. Most likely, you're going to be pulling from different API endpoints. You're going to pushing to another service. Maybe you have some type of file directory that you want to pull in SSH to and pull in some files from. And all of that, you need either username passwords, you need tokens, you need API keys, and as you're operating and you're building at scale, it's going to get really hard to keep track of all the tokens. And the last thing that you want to do is essentially save your tokens to a file, or save your password to a file, or maybe create a sys file, hidden .conf file that you have. It's not really a clean way of doing it. Also, it's a security risk if you accidentally share that repository outside in GitHub or whatever. This is what happens when most sites get hacked, is somebody pushed code to GitHub with username and passwords. And so don't be like Quinn and save your passwords on a piece of napkin.
It's actually a notebook. It's the notebook you got me for Christmas.
Just don't be like Quinn. But this is where Vault comes in play. Vault is by HashiCorp, and it's something that's really, I don't know if anybody has used Vault. Okay, it's a really useful tool to incorporate in your automation pipeline, because what Vault allows you to do is it allows you to fix that the secret sprawl that we have. So Vault, think of it as a massive giant database, secure database that allows you to save your tokens, your API tokens, your API keys, your SSH keys, your username and password in a centralized place. And also because it's a production-ready tool, whether you can deploy it locally or you can instantiate it in AWS or in the cloud somewhere. It also has an API itself, which means if I have my code stored, my passwords and tokens stored in Vault, as I'm writing my script, I can invoke an API call to Vault, pull whatever information I need from it, and then continue proceeding by making those API calls and automating. So it basically creates this this isolated space for you to put your secrets. But what's really, really cool about Vault itself is it allows you to save. It allows you to apply ACLs to your passwords, which means I can put an ACL on amount, which is, think of it as a directory where your key value pair stored of your username and password. I have access to amount. Quinn has access to amount. I can work on an application that's separate from Quinn's, and I don't have access to his, and he doesn't have access to mine. Which means if we have 10 applications running against that Vault server and one application gets compromised, I don't have to go in and change all the services, username and passwords or tokens. I can simply isolate that application and its access from Vault, deny everything, deny all ACL to Vault, but the other applications can still be intact and they can still run. So decoupling that from your script and your code actually saves you a lot of headache in the long term, and it allows for better manageability. So this is how easy it is to get started with Vault. So if you go in, I'm using here's the example I'm showing you here is Catalyst Center. I'm sure you guys have played with Catalyst Center or Catalyst Center APIs. Catalyst Center allows you, if you've played with the APIs, it's username, it's basic auth, which means you have a username and password. You do a, hey, I want a token. Here are my username and passwords. You come back with a Cat Center comes back with a token. That's your API token that you need to use for the subsequent API calls after that. That's how that kind of authentication works with DNAC, with Catalyst Center. So Vault itself has an SDK, which allows you to basically say, okay, I'm going to instantiate a new instance of Vault. I'm going to create a client, and I have a server. The integration manager or the server admin for Vault has provided me with a mount. That mount is essentially where I find my key value pair. So this is my access to the mount. In that access of that mount has the username and password that I to authenticate against DNAC. And I can simply say, okay, if the vault is not sealed, basically think of it as a physical vault that you have at home. Before you get into your items, you have to unseal it to pull in the items from there. That's essentially what we're doing with Vault as a software. We're checking if it's sealed or unsealed. If it's sealed, unseal it with your token that was provided to you, and then pull in the key value pair at JSON, essentially with the information that you need to authenticate against that API service. And then here is a very simple DNAC or Catalyst Center call that I'm basically saying I'm going to authenticate with the username and password that I pulled out, and now I can just pull in a list of devices from my Catalyst Center. So if you look at that demo here, if you look at real quick, here is the JSON that I got back from the Vault service. It has key value pair in data of password, URL, and username. These are something that I've put into Vault. So now I have programmatic access to them. And then from there, I can just simply do what I've been doing this whole time, which is call an API service, Catalyst Center in this case. And now I was able to retrieve access to all the devices managed by Catalyst Center. Don't worry, those username and passwords are the DevNet sandbox, so I'm not breaking any rules. You guys can use them and test against them. So it's really, really cool. If you haven't adopted it and you're working on some type of operation in production with automation, I highly recommend to bring that into the fold.
All right. Next up, I want to talk to something that I find also very interesting is infrastructure as code. And I've talked a lot about infrastructure as code within a single domain or context. So I've talked about Ansible. I do some workshops and sessions at Cisco Lives where I talk about using Ansible for network compliance or how to study for the EN Auto or other exams using Ansible. I also talk a lot about Terraform. Terraform is probably my favorite infrastructure as code tool out there. So I've gone all the way from a basic getting started with Terraform to how to use Terraform in CI/CD, advanced Terraform with modules. I've talked about all of that, again, as a single context. But when we talk about a network automation journey, we generally think of it like this. We start with our APIs that Kareem was talking about. We move into some sort of infrastructure as code tool, usually Ansible because it's really easy to read. Then we may say, well, I'm doing cloud, or I'm doing a lot of stuff with our DevOps team, and they're a Terraform shop. So we may move into Terraform, or you may realize that actual languages, whether it be Python or Go or Node or Rust nowadays, everyone's writing everything in Rust, that they may be better. Using those development tools, those Git tools that Kareem was talking about, we're pushing all of that to a version control system, a VCS. In this case, GitHub. And then we say, okay, we have all of this code, we have our VCS, let's build a CI/CD pipeline. Now those CI/CD pipelines are very non-trivial. Who's built a CI/CD pipeline? It works really well for application developers because application developers have code, they compile it, they test, and they deploy. Application developers don't need to worry about state. Our networks are composed of state, our routing tables, our ARP tables, our CAM tables. All of those things can make or break our automation because we have to care about them. And the problem when we start writing our own scripts with code, like Python or Go, is now we have to figure out how to handle that state and handle the state transition and what happens when the state breaks. Who's had a routing table go completely haywire during a change, right? We have to account for that when we do automation. So when we build these pipelines that are without infrastructure as code, we realize it's really tough. We don't want to have to worry about that. So then we regress a little bit and we say, we're going to do infrastructure as code because now we can focus on our outcome and not all of the nitty-gritty underneath the code. And we can use the infrastructure as code tools to handle that state for us and build our pipeline. So applying that in practice, infrastructure as code is great for the cloud. And so this is an example of a presentation I've done for our enterprise cloud connectivity certification, where we have to build VPN tunnels to cloud services, so on-prem to cloud. In this case, I'm using Azure, but I'm building IPsec VPNs with Terraform for my certification testing, because you have to know, we've all done VPNs, we know that they can break in IKE phase 1, IKE phase 2, mismatch keys. If we're doing route exchanges, if we're doing GRE over IPsec, maybe we've got some routing protocols that don't come up, BGP and things like that. So in order to test that, we build those VPNs using Terraform because it's very quick to change. I can change my key parameters, destroy my old tunnel and create a new one, walk away, get a cup of coffee, and now I have a new gateway up. So I'm not having to do that 50 or 60 different clicks within Azure to build that VPN tunnel. We can take our ClickOps and convert it back into infrastructure as code. So there's a couple of tools there. There's a tool called Terraformer or Azure Expert for Terraform. What those do is it takes our existing information within our clouds, and we can convert that to Terraform. So it extracts the configuration, says, here's the Terraform code that would build that. So we don't need to necessarily study all of our resources. We can do it. We can have the tool do it for us. And we say, oh, this is where that happened. This is how that was named. Here's what I need to do to make that repeatable using infrastructure as code. We can enable easier pipelines using infrastructure as code. So in this case, a presentation I've done has been around using a tool called Atlantis that lists GitHub webhooks to build infrastructure. So I use my Git process. I write a Terraform plan. I commit to GitHub. GitHub sends it to GitHub sends it to a webhook to the build server, and Atlantis will build the infrastructure for me. So it's handling the state, it's handling the deployment, it's handling the plans. All I have to do is connect it to GitHub and write my Terraform code. We can also do pipelines that don't use version control systems at all with infrastructure as code. So using Terraform, we can do Terraform's console Terraform sync, where if something happens, we spin up a new application. We use console for service mesh and application liveliness. That once that application comes live, it calls Terraform sync and performs a Terraform run. And I have a demo of that in the next one here. So in this case, I have ACI, and I have these ESGs, which allow us to do security groups in ACI. I have a console instance. I then spin up an application. In this case, it's just a web server running Nginx. That Nginx server registers with console. It says we have this application that's now alive. It's supposed to be there. We start the Nginx service. As soon as that Nginx service starts, you can see there, we see a bunch of stuff happening in the lower right-hand corner there. That's saying that the service has come alive, and we've now deployed a new, we've moved that application into the security group automatically. So my application developers have access to control the network in a safe way. Applications spin up, it scales that security group. Those applications die or they're spun down, it scales it down so there's no crust. We've built a pipeline using infrastructure as code. And the final thing, I know I'm going to make this really quickly, talk about Docker and containers. So we know that containers are unique. We have this container runtime and we have applications on top of that. It's access to the shared kernel space. Different than a VM where we have that isolation between the operating system and our baseband hypervisors. Normally when we talk about containers, we talk about package everything up into a container and running it. So I can build a Python tool set. I can build Ansible. I can use those as my dev environment. Instead of having to set it up on my laptop, I can do it in a container. However, containers can do both. So we talk about them as dev environments, but we can also use them as functions. So AWS Lambda, Azure containers, Google Cloud Run, OpenFaaS, all of those are function runtimes. So I build some code, I package it in a container, and then I tie that container to something else. All that container does is meant to execute that code and then stop. It's not running like a VM. It just does one function and is removed. So practically speaking, we can have this container that runs in AWS Lambda that's gathering device status for Meraki devices. We can have that tied, and it sends that report to a WebEx messaging service. We can have that tied to EventBridge, which says every day at 9:30 and 4:30, drop the status of our networks into our WebEx operations room. And that can be scheduled. But say we have an outage and your director or your VP says, I want to know the status of the network. We can also tie that to an API gateway that we can invoke with PagerDuty. So they detect an outage. That PagerDuty fires off a call to the API gateway. And then it delivers that report to our ops room so we know exactly what happens and the status of that network as soon as those changes happen. But again, that function container is only there to gather the Meraki status, send a WebEx message, and then stop. And we're going to skip this. We're not going to get to Kubernetes. This will be in the slides talking about some practical Kubernetes stuff. But wrapping it all up.
So, I mean, you see how everything comes in play together, from infrastructure to as code, to bringing in Vault into the mix, to using some type of VCS to manage all your code, and having it all together to building CI/CD pipeline. If you look at every single tool that we talked to you about today, they're essentially the culmination of an entire production-ready automation. And if you're after the automation or the DevNet expert or automation expert certification, all these tools that we talked to you about today are part of that blueprint, because at a CCIE level, chances are you're going to be using that in production. So there's a real value to starting to adopt all of these into what you're doing.
And we've been talking about these things for a while. So this is a link to the Cisco Live On Demand. And here's all the sessions that talk in some way, shape, or form about the concepts that we discussed today. I'll give a second so people can snap pictures because I know it's there. Just a couple. Okay. We also have Cisco U tutorials. And those Cisco U tutorials, like I said earlier, will talk to you about, we have things around Vault, reverse engineering the cloud with ClickOps, and deploying Kubernetes using Terraform and scaling those things. So all of those QR codes will take you to Cisco U. They're tutorials. They're perpetually free. So u.cisco.com, you can find access to these and about 150 other tutorials.
Yeah.
Our rev-ups, our free content is all available there.
They're all hands-on. We'll walk you through step by step. Everything that we talked to you about today is there to get you started with all of this.
And with that, obviously we have we have our Cisco Youth or Learning with Cisco booth. We have Capture the Flag for CE credits. Visit Cisco U, and thank you for your attendance.
Hopefully you found this really useful. Thank you all for your time. Appreciate it. Thank you. Information perspective. So for this session, I'm going to give you a quick introduction into what we know so far from what we've been talking to you about from a NetDevOps pipeline in general. And then I'm going to talk to you about, and we're going to deep dive into MCP, and I'm going to give you all the information you need to get started. We're going to look at a very relevant use case that we all encounter as network engineers. And then I'm going to actually show you a pretty cool interaction for a build of that use case and a demo. And then I'm happy to answer any questions. But before we get started here, who here is familiar with MCP? Great. Have you heard of MCP? A little bit. Okay, this is great because it's very timely. It's one of the hottest protocols that are out there today that I really, really need you to understand, and I'd highly recommend you starting to adopt it. But before we get started, if you were with us since our first, DevNet zone or automation in general, this pipeline is something, and this is a slide that I presented back in 2015. So it's pretty old, but this is where we were trying to work towards from an automation perspective. You have Carl here, working as part of a development team. He essentially is working on managing the network configuration as a pipeline. So he's creating a branch on Git. Perhaps, he's using Ansible to update some configuration, and then maybe using Vagrant, which is something that we don't use anymore, to basically test that configuration. He pushes that configuration into the change configuration into that same repo, and then he goes out and tests that configuration changes with what we used to call viral. Today is CML. So, and then maybe deploys those changes out to the network with Ansible and a playbook, and then finally, if you're familiar with the old school logo of WebEx, some notification gets sent out. So this is what we've been working towards from an automation perspective. This is what we told you should adopt, and this is what a pipeline looks like in production. Now, tech changes fast. And so we talked to you about going from, hey, network engineer, you need to adopt automation. CLI is dead. So we're going from CLI to automation. Today, we're telling you, hey, you don't need to automate everything. Adopt AI in networking. And this is where we are here to learn. And I'm going to talk to you about that because AI is super relevant to what we do. And don't get me wrong, there's a lot of marketing AI architectural out there that's just for the sake of selling. What I'm going to talk to you about today is actually what's real for us. So when we look at that pipeline that we talked about today, that pipeline changes. So Carl here doesn't have to build all these pieces together and piecemeal them into a pipeline. What Carl needs to know is Carl needs to understand how to leverage MCP to basically connect a model or AI to that pipeline and let the AI manage things like pushing code to GitHub, deploying Ansible playbooks, building that CML topology for testing, and sending notification to WebEx. What Carl needs to do is either find and pull in an MCP server, and I'm going to talk to you about what MCP is, or Carl can build his own MCP server as a wrapper on top of all these APIs, and then let the model itself connect the different pieces together without having to build everything end to end. And this is where it becomes super real for us. Now, before we get into the use case of what configuration management, let's talk a little bit about MCP. So what is MCP? MCP stands for Model Context Protocol. It's a protocol. It's a client-server protocol that it's open standard developed by Anthropic, the same people that brought you Claude, that's Claude model or Claude AI, and it basically MCP allows you to connect AI agents with external data source. So think of MCP as that USB that you plug into your laptop to bring in data. So that USB for AI models. It defines a simple host protocol server architecture, which means there's a client, you build a server, you communicate to that server via that client, and the server does something and exposes primitives. So there are three different primitives that are exposed via MCP. Tools, which think of it as the action that you're going to be taking. Resources, which is data that you're essentially exposing to the model. And then prompts, which is templates that you are essentially allowing the model to have access to. For the sake of our conversation, we're going to be exposing tools, actions. Because our network has APIs, we can wrap those APIs into MCP tools and expose those API endpoints to the models. And then allow the model to basically take action against those APIs based on our prompt. Okay? So that's what MCP is. What I want you to know also is MCP is not an AI agent. MCP is a protocol. It allows you to build AI agents. MCP is not an AI assistant, and MCP is not an LLM. From a networking world perspective, think of MCP as similar to TCP, IP. They are there as protocols to allow you to do something, right? So it's a protocol just like a TCP, just like UDP. Now, this is the architectural of MCP that you should be familiar with. Client server. So the client lives inside of a host. So it's a one-to-one relationship. You have a client communicates to one server, and the server exposes tools. Now, if you have multiple MCP server, you need something to manage all of these different clients together. Luckily, Claude Desktop itself is a host. So you can connect multiple clients, it acts as your client. You can connect multiple servers to Claude itself, and it's going to make those connections between the different MCP servers for you. So a host basically manages a set of clients and allows that model to have access to the different server that communicates with that client. Does this make sense? From a server perspective, it acts as the bridge between AI agents and real-world services, and this is what we talked about. AI tools or MCP tools are essentially APIs that are available for that model, API services that are available for that model. The server itself receives the prompt from the client. It takes it, natural language, it processes it, and it executes requests from the MCP client, and it gives you back some type of response, okay? In MCP architectural in general, there are different layers that you should know of. There's the data layer and there's the transport layer. So the data layer itself is the messaging protocol. It uses JSON RPC 2.0 messaging, and it sends JSON back and forth between the client and the server. And then it also handles that life cycle of your MCP client. So it initiates, it negotiates the client with the server, and also terminate that connection. And then it exposes those primitives that we talked about, which is the tools, resources, and prompts. If we're looking at the transport layer for MCP, that's how the data is sent over from the client to server. And it's basically, it manages that connection, and it supports two different transports. So if you're running an MCP server locally, you're going to run it. The transport standard is going to be STDIO, standard input output. Or if you're hosting an MCP server, which means you build an MCP server and you're going to host it somewhere, then basically it uses the same protocols as we use for API endpoints, which is HTTP. And so you have to handle authentication or OAuth for your application to be able to access that MCP server. So these are kind of the intricacies of what MCP is. Why is it relevant for us now? So first of all, there are a couple of things that you need to know and you need to start with. You don't ever have to build a client from scratch. So for what we're trying to do from a network automation perspective, you can simply leverage Claude Desktop. It supports MCP, the protocol itself, and it allows you to basically connect multiple clients in if you identify those server for it. So it acts as your client, it acts as your host, as well as it allows you to connect to the different MCP servers that you have. You need to understand the MCP architectural. We just talked about this. So you're covered here in those slides, and I'll make sure that these slides are available to you after my session. Also, if you want to rewatch this session, we're live streaming it on our YouTube channel, which means when you go home, it's on our YouTube channel. You can review everything that we talked about here today. There are a couple of things, right? A lot of people out there today, it's pretty much the Wild West of MCP today. When you go out there, there's MCP for everything. So you can go and browse some of the MCPs that are out there. You can bring them in, you can incorporate them. A lot of the big companies like Microsoft, GitHub, and all of that, they have their MCP servers that you can incorporate in that pipeline. Or for our sake, you can go and build, and it's super easy to build a simple MCP server based on the use case that you need. So you can essentially get started with MCP. There's a really cool library out there called FastMCP, a Python library that allows you to basically bootstrap MCP in like 5 minutes. So this is MCP in a nutshell. It really matters to us, and if we go back to that configuration management use case, and I'll leave you with a bit of statistics here. 45% of all network-related outages are basically due to configuration drift. How many times have you had to go in to where you had an outage and you had to figure out why there's an outage, and likely somebody made a change to configuration on a switch or a router somewhere that they weren't supposed to, right? That's the core of the majority of outages out there. So with adopting to mitigate that from an automation before AI, we told you automate your deployment. We told you use a single source of truth like Netbox to basically document your network and pull from that source of truth in order to deploy your network, and then add some type of observability to see what's happening with all your log server and your log systems, right? So you can take actionable item on the configuration changes that happen. Now, let's look at this use case. So let's say you or your customer is managing 10,000 devices of multi-site of Meraki network. You're maintaining a single source of truth, and I apologize for the background noise. I'm not sure if you're hearing that or not. Hopefully you guys can hear me in the back just fine. But you're maintaining a single source of truth for your network with NetBox. you're automating your configuration changes and preventing configuration drift using event-driven automation, webhooks. Maybe you have a middleware somewhere receiving any of the changes and you're taking some action on that. Maybe you have an Ansible playbook that's applying all those changes. And then you're basically connecting to Splunk for audit and audit log. Now, in a perfect world, and we don't live in a perfect world, all configuration changes starts in NetBox. You go in, you say, I'm reconfiguring my network here. NetBox fires off some type of webhook to a middleware somewhere. You receive that webhook, and then you go out and you push those changes based on the changes to keep your network to NetBox one-to-one, right? And then whenever a change happens to the network, hopefully you have some alerting mechanism in your Meraki dashboard or whatever you're managing your devices with that allows you to push those logs out to Splunk. That's a perfect world. This is what we talked about, and we said, let's do that in automation to solve the issue of configuration drift. But sometimes you have a Quinn in your organization. So enter Quinns, and we all know a Quinn. Quinn does not follow the rules. And so Quinn goes out, and it's a Friday night, and he says, okay, I'm too cool for NetBox. I'm just going to log into the Meraki dashboard, and I'm going to make the changes there. I changed some BGP changes or whatever, and before you know it, he saves the changes, he leaves for the weekend. Before you know it, your BGP down, you lost an entire site. So don't be Quinn. And this is where MCP comes in super handy. So a couple of things. If we look at our use case that we just talked about here, in building that automation pipeline, what we had to do is we had to handle the CRUD, which means if you're familiar with Meraki, you had to go in order to automate that, you had to go in and pull a list of organizations. You had to figure out which networks to update. And from there, you got to pull a list of devices in that network in order for you to figure out what changed on those devices so you can basically apply the configuration change. But we're not there yet. You actually have to go again to either Splunk or go to the syslog in Meraki to figure out what actually changed, compare it with your NetBox instance, and then revert those changes. And if we look at after the Quinn incident, you could actually go traverse Splunk logs, massive amount of logs, to actually, if you don't have view into NetBox, to see how can you get back that site that you lost. It's doable. We've been doing it. But with the power of MCP, we can just simply let the AI do all of that for us, because we can simply do this. We can architect it this way. We simply have an MCP host, which is Claude, managing 3 servers. We have a Meraki MCP server. We have a NetBox MCP server, and we have a Splunk MCP server. And using natural language, we can prompt Claude to say, without having to be so specific, hey, I want to know why I lost the site. Can you check out my Meraki configuration, check out what is supposed to be in NetBox, and look at the logs in Splunk and come back with a report for me with what changed. Now, what the AI is great about is it can cross-examine all these data points for you without you having to worry about that. On top of this, all we had to do is we had to expose the different tools in the MCP server. So if I look at the Meraki MCP server, I didn't have to tell the AI to go in order to find out which device has changed. I did not have to tell the AI that, hey, go get first the Meraki networks, pull back get the organization, pull the networks, and pull the devices from that network. All I told it is there are some changes, and it changed based on this serial number. It's going to inference based on its knowledge from the API documentation itself that's been trained on. It's going to inference that, and it's going to go and figure all of that out for us. So we have about 10 minutes. I want to show you all of these MCP servers and how I wrote them and how easy it is. But before we get there, any questions on any of this? Okay, so if I'm looking at at the use case that we talked about, here's my Claude. This is my Claude desktop, and I have three MCP servers that I built. They're all out there on my GitHub. You can go get started with them. So that's a really good question is, how was I able to incorporate and bring in these MCP servers into Claude? Now, part of the Claude itself is I go Claude here, if I go to settings, and I go to developer, edit config here. Basically, I'm not gonna pull it because it has all my username and passwords in my configuration. So I like you guys, but I don't like you that much. So what I'm gonna do is, what you essentially do is you go out to, it's a JSON file that's located in Claude. Before Claude launches, it checks that config file, and in there you define, you say, I have an MCP server here. This is how you execute it, and these are the credentials that are required for the MCP server, and so forth. And you just build a massive JSON file with all the server configuration in there. Claude picks that up, and it spins up, and it connects to the servers that way. Okay. In my example, if you go out, I have about 3 different repos with this use case. It has how to build out that configuration files for your Claude. So if I go here, and let me see if I have an example I can show you. This is my Meraki MCP server. I'm not going to drill in too much on the code for you. You can play with it, but I want to show you something that's really cool. So I built this MCP server using fast MCP, and all I did was I used the open API config that Meraki has. It's where is it? It's pretty much free. Not free. It's pretty much out there for you to be able to download. It's basically a giant schema of all the API endpoints for Meraki. So if I go here and I show you where is it? Here it is. This Open API spec file has the schema for the API endpoints that Meraki supports. There are about 852 endpoints that Meraki has. Now, when you're building a custom MCP server, you can't just expose everything. The context window is too big for the model to support. And so what you end up doing is you end up building based on your use case itself. So what I do is I use a primitive in my Meraki server itself. I use route map, and basically think of it as an ACL for those API endpoints. I say, for my use case, I want you to only expose organizations /network/devices, and these are the endpoints that are going to be available for Claude to access. These are the tools that are going to be available for Claude. So I'm only limiting to what my use case is. And if I go to Claude here, for instance, and I show you, if we go to the Meraki endpoint, these are the tools that are available for Claude to access in Meraki, which is, if you look here, they're matching to what I built in the server itself. So now I can go and say, I want to know what changed in my network. Check out my Cisco U organization, org in Meraki, and match the devices that are in my netbox instance. Show me config drift. Also show me the alerts in Splunk, because I have Splunk, NetBox, Meraki. Splunk allows me to query my MCP server itself, allows me to basically, search Splunk, which is a tool that basically will send Splunk query. It saves you from having to learn how to query Splunk itself in Splunk dashboard. The AI will do that for you. And then it also, in NetBox, it basically allows me to get objects. So the NetBox MCP server is a read-only server. So I'm not going to be able to write any changes to NetBox itself. Does this make sense? Okay, so if I execute this, and let's see if hopefully it executes properly. If not, we'll piecemeal it. So you'll see first thing first is I'll help you get that information. So it accessed on its own the tools under the Meraki MCP server. It pulled that Cisco U information, and then it knew, I didn't tell it that the next step is Meraki, get the Meraki networks. It knew that the next step is Meraki networks and the Meraki devices. So now it has access to the devices in Cisco U, and you can see here, that's the JSON payload that came back from the API endpoint. These are the devices I'm managing. And then it went to NetBox, and it's gonna now pull the device serial number from the Meraki tools that we pulled, and it's gonna check, are they available in my NetBox? And it pulled it with the change logs here. Maybe, yes. It pulled the devices here, and then it went out to Splunk, and now it's searching Splunk for all the logs that traverse, that happened, that was pushed from my Meraki when Quinn made those changes to my network. And now, hopefully, it's gonna successfully build out an entire report for me and tell me exactly what has changed and when and by whom. Okay, so it went, are you guys familiar with how Splunk works? So Splunk has indexes, and Splunk has indices and these, I'm not sure what's going on. Oh, okay. So Splunk has indices that, think of it as a giant database that all the alerts are saved in a specific indice. So that's how it's gonna search. It pulled the list of indices that are available in Splunk. I didn't have to specify. It actually went and said, oh, hey, look, I found a Meraki index that has all the data. And then from this point on, it's searching, and it's gonna keep trying. So it's gonna try to pull data, it failed. There's no data that came back. It's gonna go again and says, okay, I'm still searching with this query. Let me check the main index. It didn't find anything in Meraki. I'm not sure, maybe it lost connection, but hopefully it can still build a report if it doesn't find any Splunk changes. It's gonna come back and says, okay, based on your analysis for Cisco U org in Meraki and NetBox, here's what I found. So these are the devices in Meraki. These are the devices that match in NetBox. And it did a mismatch. So for this device, the name of it is main switch. It was relabeled to switch 1. The Meraki name for this also has changed, and the access point is a match. So these are mismatched between NetBox and Meraki. And now it's also going to tell you IP configuration changed. So in switch 1 in NetBox is this. The IP that's in there is .1 as opposed to, that should have been a mismatch. I don't see it. But there is a mismatch here in the IP address, and then it didn't find any recent alert in Splunk, but it gave you basically a key finding of what happened. And because it has access to, as part of the MCP server itself, because it has access to update network information. It's not a read-only from a Meraki server perspective. I could actually tell the AI to say, okay, go from Netbox back to Meraki and updates those changes. So I'm back to one, my configuration is back one-to-one. So you can see how really useful it is. The key here is define your use case, expose those tools to the MCP in the MCP server, and give Claude access to these tools and let it do everything. Now I can take this a little bit further. I don't have to prompt Claude to do this. I could simply build my own host that connects to the 3 clients. I could use something like n8n.com to basically drag and drop. And this could be a fully agentic workflow that I don't have to manage. So anytime there is a drift between Netbox and my network, the agent is going to detect that and it's going to go back and reverse it. And you just sit back and get reports, and you could put that on a timer, right? So you can see how useful it is in our world when we integrate MCP in network automation. Now, a couple of resources for you. Everything that I talked to you about today, including getting started with the MCP, Cisco U has tutorials that we wrote free. If you don't have subscription, it's all right. You can just log in and do these tutorials. Also, if you go out to my blogs, I wrote 4 different blogs around the use case that we talked about. In those blogs, there are the GitHub links to my repo with all the MCP servers that were connected. I show you how to connect them and how to get started with it. And then we're available if you reach out to me if you have any questions on Cisco at cisco.com. But I think this is the time to really incorporate AI into your automation workflows, and it's here. So I hope you found this session useful and you learned something new. I'm happy to answer any of your questions, but if you don't have any, thank you for your time and enjoy your week. Thank you so much.
Aló, sí, ahora sí creo que se escucha mejor, ¿sí? ¿Me escuchan todos? Aló, aló, ¿ahí? ¿Ya? Ah, bueno, ya. Bueno, muy buenos días a todos. Bienvenidos a mi charla llamada Redes Modernas para Ingenieros Clásicos, Cilium y Hubble Rescate. Mi nombre es Jorge Gómez, yo soy arquitecto de software en CX. Llevo en Cisco trabajando más de 6 años. Los últimos 4 he trabajado mucho en la parte de automatización, sobre todo en la parte de data center. Y en esas tareas que he tenido ha estado mucho la parte de integración de... ¿No me escuchan bien? ¿Cómo que no me escuchan bien? ¿Aló? ¿Aló, aló? Bueno. Y en esa tarea que he estado, en la parte de data center, he estado mucho en la integración con Kubernetes. Y en eso va a ser la tarea de hoy. Entonces quería empezar con esta slide, con esta estadística de la Cloud Native Foundation, que me dice que el 99% de las compañías hoy o ya tienen desplegado Kubernetes, o lo tienen de testeo, o lo están implementando. Acá quiero hacer una pregunta. ¿Quiénes de ustedes ya tienen Kubernetes en su data center? ¿O lo piensan? O, bueno, veo poquitas caras por ahí. O sea, ¿el resto no han escuchado de Kubernetes o es completamente nuevo para ustedes? ¿Han escuchado? Bueno, entonces la idea es como mirar la parte de networking, los retos de networking en un sistema o en un entorno de Kubernetes. Esta va a ser la agenda. Primero los desafíos de red de Kubernetes, la parte, bueno, les voy a presentar qué es Cilium y eso la ven, la parte de networking, la parte de observabilidad y la parte de seguridad. Y el último va a ser un pequeño demo de cómo funciona Cilium en Kubernetes. Entonces, desafíos de Kubernetes. ¿Qué es Kubernetes? El nombre, de hecho, es un poco raro, si se han preguntado alguna vez. En el más básico griego, diría mi amigo, es una palabra griega. Nosotros en IT lo llamamos K8S y en griego significa un capitán. Y esa es la idea de Kubernetes, de ser un barco, el capitán de un barco que lleva mis contenedores. Kubernetes es un sistema de orquestación de contenedores. De hecho, el logo que ven ahí, el de arriba, es un timonel de un barco, de ahí es donde sale la idea de Kubernetes, de yo poder orquestar, de yo poder llevar muchos contenedores. Fue un proyecto que fue creado en Google en 2014, lo donó a la CNCF en el 2016, y la CNCF es como la organización, una organización sin ánimo de lucro, que tiene muchos proyectos open source. Fue un proyecto que tuvo mucha adopción y hoy en día muchas compañías tienen su propia versión, su propia distribución de Kubernetes. La más famosa OpenShift, el rojito de ahí, creo que es la distribución de Red Hat, que creo que la han escuchado, muy famosa en la parte de Enterprise. Y también cada proveedor de nube tiene su propia versión de Kubernetes. Amazon tiene EKS, Google tiene EKI, Azure tiene su propia versión de Kubernetes. Lo que uno puede hacer en el Kubernetes open source, lo puede hacer en cualquier versión de Kubernetes. Entonces, una plataforma que tiene mucha adopción hoy en día porque muchas de las aplicaciones que hoy despegamos corren en Kubernetes. ¿Cómo es la arquitectura de Kubernetes? Entonces, es un sistema distribuido donde yo tengo varios nodos, varias máquinas, las conecto por red. Acá ahí puse una nube porque esa red puede ser mi data center o puede ser una nube pública. Tengo diferentes tipos de nodo. Un nodo lo llamo el nodo de control, donde yo tengo la parte de administración, tengo la API, tengo el scheduler, tengo la base de datos y tengo lo que llamamos nodos worker, que es donde yo realmente corro mis aplicaciones. Interesante Kubernetes y que puede ser un poco confuso al principio. Kubernetes como tal, él no administra o maneja contenedores, sino él administra pods. Ese es el nombre que uno tiene, o la terminología que uno tiene en Kubernetes, se llama pods. Dentro de un pod, normalmente yo solo tengo un contenedor, pero uno no habla en Kubernetes de contenedores, sino uno habla de pods. Es una arquitectura demasiado flexible. La parte más irónica de Kubernetes es que Kubernetes no sabe cómo crear un pod o un contenedor. Él sabe cómo orquestarlo, pero no sabe cómo crearlo. Para eso, él utiliza un plugin. Entonces, existe un plugin que me permite cómo yo creo el contenedor. Los plugins más comunes hoy en día son los que ven en pantalla. Containerd, CRIO. En el pasado, Docker era un plugin muy famoso, que es muy conocido. Pero, bueno, hoy por hoy son los más famosos. Y otro plugin es la parte de networking, que es lo que vamos a ver hoy. El Container Network Interface, que es el plugin, es el componente que me permite que esos pods en mi clúster se puedan comunicar entre ellos. Eso es lo que hace la CNI. Esa CNI o esa comunicación tiene unos retos que normalmente no vemos en redes legacy o las redes que tenemos normalmente que hemos manejado. ¿Cuáles son los retos que yo tengo con esa red entre los pods? La primera, que es una red completamente distribuida. Es una red que me debe permitir la comunicación de pods, ya sean dentro del mismo nodo o en diferentes nodos, que es un reto ya porque como yo tengo esa comunicación durante, digamos, una red ruteada. Segunda, es una red aislada. Normalmente el segmento de red que yo utilizo para los pods solo vive dentro de los pods. Hay veces es difícil o por defecto, como yo desde afuera, como un cliente puede consumir una aplicación que corre en uno de esos pods. La tercera, que es la que vamos a mencionar durante toda la charla, es una red efímera. Si bien tienen IPs, esas IPs pueden cambiar. Cuando yo actualizo un pod, cuando yo muevo un pod de uno a otro nodo, esa IP va a cambiar. Entonces, ¿cómo yo manejo ese cambio de IPs en un clúster de Kubernetes? Y la última, que no le gusta a nuestros amigos de seguridad, que es una red permisiva. Por defecto, todos los pods se pueden comunicar entre ellos. Así yo tenga segmentación lógica, todo se puede comunicar. Entonces, esos son los retos que yo tengo desde la CNI. Como es un sistema flexible, yo cuando instalo un clúster de Kubernetes, yo como administrador tengo la opción de decir qué CNI yo quiero utilizar. Entonces existe un buen abanico, open source o CNIs propietarios de cuál yo quiero utilizar. El enfoque de hoy va a ser Cilium, que era el título de la presentación. No sé aquí quién ha escuchado de Cilium o ha utilizado Cilium, okay. Al menos una persona. Es una CNI, pero existen otras CNIs. Está Calico, que es otra CNI open source, y digamos la mayoría de nubes privadas, de nubes públicas, tienen su propia CNI. Lo interesante de Cilium es que yo puedo utilizar Cilium ya sea en el Kubernetes local, en el open source, o ya sea en el de la nube, en el de Amazon, en el de Azure o en el de Google. Ya tiene ese tipo de compatibilidad. Entonces, ya que les presenté los retos de Kubernetes, les voy a presentar la solución que tengo para ustedes el día de hoy. Y se llama Cilium, que como en el título lo llamamos más que una CNI, porque aparte de proveerme esa parte de networking, me provee seguridad y me provee observabilidad. Y acá ven todo el abanico de opciones que yo tengo con Cilium. Está desde lo más básico de networking con BGP, con overlay, a la parte de balanceo de carga, network policies, manejo de tráfico y observabilidad. Entonces tiene una buena cantidad de features que son muy importantes, sobre todo para uno como ingeniero de red. Empezó como un proyecto open source, también manejado por la CNCF. Es una CNI que fue creada y hoy por hoy es liderada por una compañía llamada Isobelen, que fue una compañía que Cisco adquirió a principios del año pasado. Es una compañía que utiliza mucho una nueva tecnología llamada eBPF, que es una tecnología que me permite programar el kernel y a partir de eso tener muchas soluciones. Muchos de los productos de Cisco desde la adquisición de Isobelen tienen eBPF. Hypershield tiene eBPF. Cilium tiene eBPF. En el último release de NextOS, corre eBPF por abajo. Entonces, ha cambiado mucho desde la adquisición de Isolabin cómo hacemos networking en Cisco. Si bien es una CNI open source, tiene su distribución enterprise con soporte empresarial, como digamos la parte de OpenShift, el mismo modelo de operación. ¿Cómo es la arquitectura de Cilium? Tenemos dos componentes principales. El primero, el Cilium Agent, que es este pod que tenemos corriendo en cada uno de los nodos. ¿Qué va a hacer ese pod? Él se da cuenta que yo creo un pod dentro del clúster y le va a dar conectividad de red. ¿Cómo le da conectividad de red? Instalando un programa eBPF. ¿Qué significa eBPF? Lo que ven acá, Extended Berkeley Packet Filter, que simplemente lo que hace es crear programitas en el kernel para que esos contenedores, esos pods se puedan comunicar. Para nosotros y para ustedes probablemente, si son administradores de Cilium, no les importa qué programas de eBPF corren por ahí. Ustedes solo les importa saber que por debajo corre eBPF y que tenemos ciertos beneficios, pero ustedes no van a administrar los programas como tal. Y los beneficios de correr eBPF se los voy a mostrar para que vean el diferencial que tiene Cilium con otras CNIs porque corre eBPF por debajo. El otro componente que tengo en mi arquitectura es un proxy que corre también en cada uno de los nodos que se va a encargar de tareas de capa 7. La tarea más común de crearme políticas de capa 7 y lo vamos a ver durante la presentación. Dime. También entrante, pero hoy lo vamos a ver entre pods, entre los mismos pods. Entonces veamos la parte de networking, veamos cómo Cilium resuelve esos problemas que tenemos que mencioné al principio por la arquitectura de Kubernetes. Comunicación entre los pods. Tiene dos modos de operación. El modo de operación más común es mediante overlay. ¿Qué significa overlay? Si yo tengo la parte más sencilla, comunicación de dos pods en el mismo nodo, es sencillo. Instala un programa de PF, él hace el switcheo o el ruteo ahí mismo. El reto más grande es cuando yo lo hago mediante la red, porque es una red ruteada que tiene otro espacio de red. Lo que hace Cilium en este caso, él coge ese paquete y lo encapsula. Le pone otra IP, otro header. Utiliza un protocolo de encapsulamiento, tal de que esta red simplemente tenga que rutear paquetes que pertenecen a la IP de los nodos. El protocolo de encapsulamiento soporta varios, VXLAN o GNIF. VXLAN es un protocolo de encapsulamiento muy famoso, se utiliza mucho en data center y es el protocolo que se utiliza por defecto. Como ven, es bastante sencillo, no hay nada que configurar, simplemente mi red tiene que rutear IPs que pertenecen a los nodos y ya yo hago ese encapsulamiento y yo puedo tener comunicación completamente distribuida. Lo segundo, cómo yo lidio o cómo yo manejo la característica efímera de la IP de los pods. Entonces tenemos aquí un ejemplo, tengo dos microservicios, microaplicaciones, el de reviews y el de ratings. El reto que tenemos con Kubernetes es que yo no puedo utilizar estas IPs para poder comunicarme con la aplicación que tengo acá, porque como les dije, esa IP puede que vaya a cambiar. Si actualizo ese pod, si muevo ese pod, esa IP va a cambiar. Entonces necesitamos otro tipo de método de poder comunicarme con esos microservicios. Y lo que tiene Kubernetes como tal es un componente llamado servicios. ¿Qué hacen los servicios? Ellos me agrupan pods. Me los agrupan normalmente con metadata, llamado labels, que lo vamos a ver más adelante cómo se configura. Y me dice, voy a agrupar todos los pods que tengan esa metadata y cuando yo creo ese servicio, tengo como resultado dos cosas. Primero, tengo una nueva IP que va a ser siempre la misma. Si estas IPs cambian, si yo tengo más pods, si tengo menos pods, esta IP siempre va a ser la misma. Entonces yo desde el cliente me puedo comunicar con esta IP. Y mejor aún, tengo un nombre DNS, que es lo que yo utilizo para la comunicación, que va a ser determinístico, y es lo que yo utilizo para la comunicación de microservicios dentro de mi clase de Kubernetes. Este tipo de servicios, servicios donde el cliente está dentro del mismo clúster, se llaman servicios cluster IP. ¿Cómo los configuramos? Así es como se configura Kubernetes, por si no lo habían visto. Los configuramos con archivos .yaml y esto lo mandamos a la IP. Esto es un modelo de configuración un poco más declarativa. Y lo que ven ahí es como yo configuro los pods. Normalmente en Kubernetes yo no configuro los pods directamente, sino yo utilizo un recurso llamado deployment, que me permite crear varias réplicas. En este caso voy a crear 3 réplicas de un pod con esta imagen del contenedor. Acá, ¿qué es lo importante? Cuando yo creé estos pods, los creé con este label, app igual a ratings. Entonces ya esos pods están corriendo ahí con esa metadata. Lo siguiente que yo hago es crear el servicio y en el servicio, cuando yo quiero agrupar los pods, le digo, por favor, seleccione todos los pods que tienen app igual a ratings y los voy a exponer esos pods en este puerto. Entonces, eso es lo que tiene que hacer Mesh. Como yo creo los pods, a cómo los estoy agrupando. Y así es como yo creo servicios y por defecto Kubernetes me va a crear esa IP que es la misma y ese registro DNS. Esa fue la parte de la configuración. Ahora, ¿cómo está implementado eso? Que acá es donde empieza a jugar eBPF. Cuando yo corro Cilium, él corre eso o esa implementación que al final es un balanceo de carga porque yo me comunico con esta IP, pero al final tiene que balancear a la IP de los pods. Ese balanceo de carga lo hace eBPF. La ventaja de utilizar eBPF es que buscar ese mapeo de IP de servicio a IP de los pods es utilizar lo que llamamos un algoritmo hash. Él simplemente busca un key, encuentra el valor y punto. Y eso escala demasiado bien. Entre más servicios, más pods, se va a demorar menos. Una pregunta.
Una pregunta, no sé si el diagrama de la computadora, pero la IP 1096 y 100, ¿esa IP la va a tener el nodo de Kubernetes como tal o va a ser interna de la red?
Okay. La pregunta es, ¿esta IP acá 1096.010 si es interna o es del nodo? ¿Sí?
Ajá.
Es interna. Cuando yo creo el servicio, esa IP vive dentro del cluster de Kubernetes. Hay 2 segmentos de red, la IP de los pods y la IP de los servicios. ¿Sí? Okay. Volviendo al tema, entonces, acá el reto es cómo yo hago ese mapeo de IP del servicio a IP del pod. Entonces, cuando yo utilizo BPF, utilizo un algoritmo hash que es mucho más escalable, diferente a lo que hacen otras CNIs o lo que se hacía tradicionalmente, que utilizamos algo llamado IP tables, que es un feature muy famoso de Linux. El problema con los IP tables es que eso es como una lista de acceso. Tengo una lista grandísima y tengo que encontrar un hash. Entre más servicios y más pods, se va a demorar mucho más. Y esto es algo que tenemos acá muy claro en una gráfica que hicieron los compañeros de Isobalen, de cómo escala ambas implementaciones. Entre más pods y más servicios, cuando utilizo BPF o Cilium, es lo mismo, porque el algoritmo es completamente constante, mientras que con kube-proxy es lineal, va incrementando y tengo problemas de escalabilidad. Esa era la parte de servicios internos, donde el cliente está dentro del mismo cluster de Kubernetes. Ahora, el segundo reto que teníamos con los clusters de Kubernetes, ¿cómo yo expongo esas aplicaciones para que me lo consuma alguien fuera del cluster de Kubernetes? Y para eso tengo otro tipo de servicios. Tengo 2. El primero llamado Nodeport, que como su nombre dice, me da un puerto. ¿Y qué es lo que pasa con esto? Cuando yo creo mi servicio, aparte de internamente tener esa IP y ese registro DNS, tengo un puerto en este rango. Y si yo me quisiera comunicar con esa aplicación, un servidor web o una base de datos, lo que yo hago simplemente, cojo una IP de cualquier nodo del cluster de Kubernetes y le pongo ese puerto e internamente la CNI me va a rutear a esa aplicación. Es una forma bastante sencilla que normalmente uno utiliza en desarrollo. ¿Por qué en desarrollo? ¿Qué problemas tenemos con ese tipo de implementación? El primero, este tipo de puertos normalmente los bloquean los firewalls, ¿no? Puertos muy altos normalmente en la red no nos permiten de mucho. Segundo, siempre yo voy a tener que apuntar a un mismo nodo, entonces yo voy a cargar al mismo nodo. Esa es la gran desventaja de este approach. Por eso es que existe otro tipo de servicio. Espera. Otro tipo de servicio llamado balanceador de carga, que me expone una IP externa, normalmente en el mismo segmento de red de los nodos, y se va a encargar de balancear entre los nodos. Ahí el reto es quién configura y quién maneja ese balanceador de carga. Cuando yo tengo Kubernetes en la nube, en Amazon, en Google, normalmente yo creo este servicio, Google, Amazon o Azure me crean ese balanceador de carga. Cuando yo tengo Kubernetes en mi propio data center, tengo que buscar una integración con un balanceador de carga, ya sea F5 o lo que sea, pero existe, pero es como el reto mayor de esa automatización o ese manejo del balanceador de carga. Pero ya tengo una IP y me hace el balanceo entre todos los clusters de Kubernetes y así yo puedo consumir mi aplicación. Eso en la parte de networking. En la parte de seguridad, tenemos el mismo reto de la naturaleza efímera de los nodos. ¿Cuál es el problema? Yo realmente, si yo quiero crear una regla que me diga que tal pod se tiene que comunicar con este otro pod, yo no puedo... Yo no puedo utilizar las IPs, yo no puedo crear reglas a partir de IPs. ¿Por qué? La naturaleza de Kubernetes me dice que esas aplicaciones yo las voy a escalar muy constantemente. Entonces, si yo tengo un modelo así y escalo mi aplicación, tengo que volver yo a actualizar todas las reglas si lo tengo a base de IPs. Por eso es que en Kubernetes lo hago a partir de identidades. Y yo creo las identidades basados en los labels que yo le puse a esos pods. Todos estos pods de este grupo, a pesar de que tienen IPs distintas, tienen la misma identidad. Se crearon con los mismos labels. Y eso es lo que hace BPF por abajo. Él calcula un label a partir él calcula un ID a partir de esos labels y en eBPF, en el kernel, él crea las reglas a partir de esos IDs. Y dice, por ejemplo, lo que tenemos acá, todos los IDs de ratings se pueden comunicar con todos los IDs de reviews. No le importa las IPs pueden cambiar. A mí lo que me importa es la identidad de cada uno de esos pods. Ese es el approach que tenemos en Kubernetes y cómo lo implementa Cilium. En eBPF podemos crear lo que yo llamaría reglas de capa 3 o reglas de capa 4. O sea, simplemente dejo que esos pods se puedan comunicar entre ellos. Si yo quisiera tener reglas más granulares, irme un poco más en el modelo OSI, lo puedo hacer con Cilium. Puedo crear reglas de capa 7. En ese caso, eBPF hoy por hoy no puede enforzar este tipo de políticas. En ese caso, lo que hace Cilium es redireccionar ese paquete a ese proxy que yo tengo corriendo en cada uno de los nodos y ese proxy va a enforzar esas políticas de capa 7. ¿Qué son políticas de capa 7? Políticas en los protocolos que normalmente yo tengo una aplicación de microservicios. HTTP, gRPC, Kafka, DNS. Él puede crear políticas de decir, solo me comunico con esta URL, solo utilizo este método, solo utilizo este URL de DNS. Eso yo lo puedo hacer con Cilium, simplemente que lo enforzo en la parte del Envoy Proxy. Entonces acá, ¿cómo se configura eso? Otra vez tenemos un manifiesto YAML, que es como se llama. Yo empiezo diciendo en dónde o a qué pods yo quiero aplicarle esta política. Y yo le digo que se lo aplico a los pods que tienen el label app igual a ratings. Y ahora creo una política, puede ser de ingress, quién se puede comunicar con él, o egress, ese pod con quién se puede comunicar. En este caso es de ingress, y estoy diciendo que solo los pods que tienen app igual a reviews se pueden comunicar con los pods que tienen app igual a ratings. Así es como yo lo configuro. Es como una política de capa 3, de que estos pods se pueden comunicar con esos y ya, no digo nada más. Si yo quisiera extenderlo, es lo que me permite este recurso Cilium Network Policy. yo simplemente extiendo eso y les digo que aparte de que eso se pueden comunicar, solo se pueden comunicar en este puerto, por este protocolo, en capa 7, en HTTP, se puede comunicar con este método y esa URL. Ese es el nivel de detalle que me permite configurar Cilium cuando yo creo políticas de capa 7. De yo decir, mis microservicios, quiénes se comunican y con qué protocolos. Y bueno, porque URL es porque la mayoría de microservicios se comunican por HTTP. Y eso es lo que yo puedo hacer con Cilium. Y esa es la parte de seguridad. Por último, la parte de observabilidad de Hubble. ¿Qué es Hubble? Yo les he dicho que era un componente del ecosistema de Kubernetes. Y de hecho, al principio les dije una pequeña mentira en la arquitectura. Les dije que teníamos un Cilium Agent, donde solo tenía un contenedor, que era el que creaba los programas eBPF. En realidad, en ese pod yo tengo varios contenedores. Uno es el Cilium Agent, que crea los programas de eBPF, pero aparte tengo otro componente llamado el Hubble Server. ¿Qué es lo que va a hacer el Hubble Server en cada uno de los nodos? Él va a tomar información de telemetría de los programas de eBPF, también del Envoy Proxy, y va a correlacionar esa información con metadata de Kubernetes. ¿Por qué va a hacer eso? En Kubernetes a mí no me importa mucho qué IP se comunica con tal IP, porque las IPs pueden cambiar. La IP que yo utilizo hoy puede que cambie mañana. Para eso me importa más es qué pod se comunica con qué pod, en qué namespace, qué deployment, qué servicio. Y de eso se encarga Hubble, de realmente correlacionar esa información y mostrarme mi información de pods, no de IPs. El otro componente que tenemos, él simplemente se llama Hubble Relay, él simplemente va a agregar esa información de telemetría de todos los Hubble Server, porque a mí no me importa este pod con que se comunica en este nodo, sino me importa a nivel de clúster, me importa un flujo global. Yo quiero saber, me conecta a mi clúster de Kubernetes de muchos nodos y quiero saber con qué pod o información de tráfico de este pod, punto. No me importa en qué nodo, me importa de forma global. Y eso es lo que hace Hubble Relay, agregar y mostrarme eso en una API. Y los componentes que utilizan esa API son dos. El primero se llama Hubble CLI, que nosotros lo llamamos como el TCP-DAM para Kubernetes, donde mediante CLI yo tengo información de tráfico, muy parecido a lo que hacemos en TCP-DAM. Acá en vez de decir una IP o decir un puerto, yo digo, por favor, de mi información de tráfico de este pod. Y él empieza a mostrarme esa información. Ese pod se está comunicando con este pod, información de capa 3. Me dice en qué puerto, información de capa 4. Me dice qué identidad tiene cada uno de esos pods, que es lo que vemos acá. Acuérdense que las reglas se hacen a partir de identidades. Y por último, si hay información de capa 7, si digamos en este caso hay comunicación HTTP, me va a mostrar qué es lo que está consumiendo. Entonces me da un nivel de observabilidad demasiado grande de las aplicaciones que yo tengo en mi clase de Kubernetes. El otro componente que consume esa API de Hubble Relay se llama el Service Map, que simplemente en su versión open source me da un mapeo de mi aplicación, me dice qué microservicio se comunica con qué microservicio, que es una información muy valiosa, tanto para el arquitecto de la aplicación como el arquitecto de red. Él sabe si los microservicios se están comunicando de la forma que se deben comunicar, cómo pasa esa comunicación, qué protocolos y qué puerto. Entonces, es un componente bastante poderoso. Y en la parte de Enterprise tenemos este llamado Timescape, que me muestra ese mismo mapeo, me muestra los flujos y me muestra un histórico de todos los flujos. Y creo que también tiene la opción de crear mesas políticas mediante una UI. Eso es lo que podemos hacer con Hubble. Eso era todo lo que les tenía. Les tengo un demo que no va a tomar más de 3 minutos. Simplemente cómo va a correr. Acá tengo un clúster de Kubernetes. Kubernetes tiene, sobre todo en la parte de Enterprise, como OpenShift, como IKS, se puede manejar por una interfaz gráfica. Pues acá es la open source, lo manejo por CLI. Lo manejo con un cliente llamado kubectl. No sé si alguien lo ha utilizado, pero es un comando CLI. Primero quiero que vean la cantidad de nodos que tengo. Tengo 3 nodos. Entonces tengo Tengo 3 nodos, un master y 2 workers. Quiero que vean los pods que tengo en todas las segmentaciones lógicas. Entonces acá lo importante es que en esta segmentación lógica, que es la parte de management, tengo Cilium corriendo y tengo Hubble corriendo. Corren como pods dentro de mi clase de Kubernetes. Pero ahora vámonos a la aplicación en el namespace default. Entonces, es una aplicación de microservicios. Tengo varios microservicios, details, product page, ratings y reviews. Entonces vamos a acceder a esa aplicación. Entonces, acá ya la tengo en mi navegador. Es esta de acá. Es una aplicación de demos, una tienda de libros, en una arquitectura de microservicios por detrás. ¿Qué quiero que hagamos ahora? Vamos, aparte de ver la que ya está funcionando, vamos a utilizar Hubble CLI para ver cómo podemos monitorear ese tráfico. Entonces acá me devuelvo, voy a correr este comando y me dice, perdí conexión acá. Entonces ahí está, él está esperando que yo mande ese tráfico, él está ahí esperando que haya tráfico para el pod de defaults. Si yo acá refresco la página, ahí refrescó. Si me devuelvo, ahí vio que ese tráfico pasó. Él vio que el pod de reviews se comunicó con el pod de ratings y fue una comunicación HTTP. Tengo ese nivel de observabilidad. Yo también podría no solo el pod de defaults, de ratings, sino todos los pods. Me interesa todo el protocolo HTTP, voy a observar, refresco mi aplicación. Y ahí está, tengo todo eso. Ahí todos los microservicios están comunicando. Y ese es el nivel de observabilidad que yo tengo en el cluster de Kubernetes. También tengo ese UI que os puedo mostrar acá, donde veo esa representación gráfica de mi aplicación. Entonces, quién se comunica con quién, los flujos acá, si es solo TCP o si tengo algo de HTTP. Y esto es lo que les quería mostrar bastante rápido. Ya para terminar la presentación, bueno, como reflexión, la parte de Cilium, que nos simplifica la parte de networking, todo hecho por eBPF, programación a nivel de kernel. Tengo seguridad, networking y observabilidad. Si quieren seguir aprendiendo, si les llamó la atención, sí les recomiendo esta página. Es de Isobel, en donde tienen laboratorios que ustedes pueden utilizar y pueden mirar cada uno de estos features que yo les mostré hoy. La parte de observabilidad, la parte de ruteo, exponer servicios. Es una página muy buena, laboratorios on demand, que ustedes pueden utilizar. Y ya, eso fue todo por mi lado. Si les recomiendo si pueden llenar la encuesta de qué les gustó, qué no les gustó, qué les gustaría ver en otro evento. Y bueno, eso fue todo por mi lado. Muchas gracias por venir acá y que sigan pasando bueno.
Hola, ¿se escucha? ¿Sí? ¿Todo bien? ¿Sí? Más o menos o bien. Déjame, pongo de este lado porque no voy a viciar. ¿Ahora sí? No, Ah, lo que pasa es que si hablo para acá no se escucha, si hablo para acá sí se escucha, ¿verdad? Ok. Lo voy a poner aquí. Ahora creo que mejor, ¿no? O peor. ¿Sí? ¿Bien? Vale, perfecto. Creo que vamos a esperar un minutito más y nos arrancamos. No tenemos mucho tiempo, gracias por estar aquí en vez de estar en la keynote, ¿no? Se les agradece no dejarme solo. Una vez sí nos tocó estar por acá y que no llegara nadie. Pero bueno, era un workshop, no era una charla. No llegó nadie. Venían unos gringos también a dar nada más esa y no hubo nadie. Entonces estaban enojados los gringos. Eso sí, era miércoles 10 de la mañana, entonces después de la fiesta, entonces. Sí, no. Quórum no había, pero para nada. Listo, muchísimas gracias por venir. Vamos a estar platicando muy rápido porque tenemos solamente 30 minutos, 35 según los muchachos, 40, ¿no? ¿50? ¿Una hora? ¿2 horas? 2 horas. Gracias, sí, claro, 30 minutos. Tenemos 30 minutos acá con ustedes, entonces va a ser muy rápido. Me gustaría preguntarles, ¿alguno de ustedes tiene Nexus en sus ambientes? Sí. ¡Oh, todos! Bueno, la mayoría. Genial. ¿Sí? Nexus. ¿Sí? ¿NXOS o ACI? ACI, los dos. ¿Quién da más? ¿No? ¿De quién lo tiene de pisapapeles? ¿Nadie? Okay. No hay pisapapeles, no. Sí, en producción. ¿Todos en producción? Perfecto. Nexus Dashboard es una plataforma que nos ha estado acompañando ya varias versiones, varios años, de hecho, donde ha tenido una serie de transformaciones. ¿Sí? Primero salió de productos aislados, luego por ahí lo convertimos en una plataforma que era plataforma de plataformas, por decirlo de alguna manera, ¿no? Alguno de por acá recordará a Data Center Fabric Controller, maybe, ¿no? Eso se convirtió en Nexus Dashboard Fabric Controller. Luego teníamos por ahí Sites, teníamos Assurance, teníamos Orchestrator, etcétera, ¿no? Teníamos como una serie de productos que administraban o nos ayudaban a orquestar y administrar Nexus, ¿sí? Lo fuimos tratando de más o menos poner en una plataforma, ¿no? Eso fue hasta las versiones, bueno, antes el disclaimer, no todas las cosas que están aquí van a salir, ¿no? Porque 4.1 ya está fuera, pero lo de 4.2 todavía no. Entonces vamos a platicar sobre la versión 4.1. Sí. ¿Mejor? Ah, sí, mejor. Entonces, como comentábamos, pues, antes en la versión 3.1 y 4 y 3.2 teníamos diferentes productos en Nexus Dashboard. Entonces, para los que no hayan escuchado hablar nada de Nexus Dashboard, muy rapidito, Nexus Dashboard es nuestra plataforma para administrar, orquestar y tener visibilidad sobre nuestra plataforma de Nexus, ya sea en ACI, ya sea en NXOS o ya sea los MDS o los equipos de SAN. ¿Alguien tiene MDS por acá? ¿No? Bueno, también hacemos temas de SAN Insights y todo este tipo de cosas dentro de la plataforma. ¿Ok? Entonces, lo que teníamos pues son estos 4 proyectos o estos 4 productos, ¿no? Todo el tema de Insights que nos permite tener una visibilidad de los nexus como tal. Tenemos Orchestrator, que es mucho más para orquestar multisitios basados en ACI. ¿Sí? Tenemos por ahí Fabric Controller, tanto de LAN como de SAN, como decía hace un momento. ¿Sí? Y por último, la plataforma o la administración de la plataforma de LAN y de SAN como tal, ¿no? Es decir, tener administración o control de este ambiente y tener la plataforma como tal. Sin embargo, nosotros veíamos que eso era medio complicado para nuestros clientes entenderlo. Entonces, lo que hicimos fue, en esta nueva versión, la 4.1,
hacer esta unificación como tal, ¿no? Entonces queda la plataforma, pero ya todos los nombres que teníamos los vamos a, al final de cuentas, compactar y lo que va a quedar es estos servicios: automatización, telemetría y orquestación. ¿Ok? Todo dentro de... Déjame quitar eso, perdóname, soy yo. Yo tengo la culpa. No, ahora se sientan. Perdón. Muchísimas gracias. Qué amable. Ok, entonces la idea es tener una experiencia unificada en Nexus Dashboard en donde sea mucho más sencillo tener automatización, tener telemetría y tener orquestación de todo mi ambiente Nexus. ¿Okay? Cuando hablo de todo mi ambiente Nexus es independientemente si es ACI, si es NXOS, si ese NXOS lo tengo en una LAN tradicional, ¿no? Es decir, mi core, mi agregación, etcétera, lo que nos enseñaron en el CNA, ¿no? O si lo tengo también ya implementado en VXLAN y VPN. ¿Okay? Entonces, la idea es que podamos tener esa administración en un solo punto con una experiencia unificada. Y para todo el tema de ACI, poder tener esa integración de dos vías entre la plataforma, el clúster de API. Entonces, al tener este ambiente unificado, la idea es que tengamos Nexus Dashboard para poder hacer básicamente tres grandes casos de uso. Tener el management de todo mi ambiente, ¿sí? Tener todo el tema de automatización, ¿sí?, de todo mi ambiente, y tener todo el tema de análisis y troubleshooting. ¿Okay? Entonces, esto nos va a permitir tener un troubleshooting unificado de todo mi ambiente. Independientemente, como les decía, si tenemos SAN, los MDS, ¿sí? Si tenemos Nexus puro y duro, ya sea en Ethernet clásico, en VXLAN y VPN, en ACI. Si tenemos, por ejemplo, ¿hay alguien por acá de Media? ¿Alguien? Pero no lo usas como IP Media Fabric, ¿verdad? Tenemos clientes en México y en Latinoamérica que tenemos nosotros una arquitectura de referencia para todo el tema de las cámaras, total, ¿no? Las cámaras de transmisión, todo el streaming, etcétera, de 4K, de 8K, etcétera, con los Nexus directamente, ¿no? En vez de estos paneles ahí que tenían una matriz y se conectaban todos los equipos ahí, ahora tenemos este ambiente, ¿no? Todo el tema de data broker, es decir, poder analizar toda la información que cae en el data broker y también las fábricas orientadas a inteligencia artificial y machine learning. Es decir, lo que ustedes ven allá al fondo, ¿no? De nuestras máquinas muy grandes, obviamente esas máquinas grandes necesitan una red muy grande, ¿no? Ok, entonces, bueno, esa es la idea y lo que estamos haciendo es, desde el 3.1, es crear que a final de cuentas, antes teníamos un tema. Nexus Insights, que es realmente como el corazón de Nexus Dashboard, ¿sí? Nexus Dashboard Insights, solamente funcionaba para nuestros clientes que tuvieran Premier. ¿Quién de ustedes tiene Premier en sus Nexus? Licenciamiento Premier. La gente de lana, ¿no? ¿No? Sí, la gente de lana. Bueno, lana, plata, lo que quiera, ¿no? Bueno, si ustedes ven, la adopción de Premier, ya lo acaban de ver, es bastante reducida. Y esto, aparte sí del precio, lo sabemos, ¿no? Es un tema de que son muchísimas las características que tiene Premier, ¿sí? Sin embargo, los clientes de Advanced y de Essential, ¿no? Que seguramente Advanced es la mayoría de ustedes, ¿no? ¿Quién tiene Advanced? Advanced, Essential, por ahí, ¿no? ¿Tienen por ahí alguna mezcla? ¿Sí? Entonces, lo que nos decían los clientes, ok, está bien, pero pues dame una probadita de esto, ¿no? O sea, ¿qué hacemos para ahí para que yo también pueda tener insights y no tenga que pagar Premier a fuerza para tener insights? Entonces, Cisco lo que hizo fue cambiar ese esquema de licenciamiento. ¿Okay? Entonces, ustedes van a tener todo el ambiente de Nexus Dashboard, ¿sí? Pero en tiers de capacidades, aún con el Essential. ¿Qué quiere decir esto? Si ustedes tienen un Nexus, tienen Nexus Dashboard. ¿Okay? Obviamente, dependiendo el nivel de licenciamiento, es el tipo de características que va a tener. ¿Okay? O sea, no piensen tener no, el Premier con el Essential. Tampoco, ¿no? Pero la idea es esa, ¿no? Entonces, durante el 3.2 incrementamos la visibilidad de la customización. En el 4.1, que es la versión que está ahorita afuera, tenemos todo el tema de la unificación de productos y servicios. Y por último, en el 4.2 vamos a estar manejando mucho más cosas basadas en lenguajes o LLM o lenguaje natural. Entonces, muy rápido, Nexus Dashboard, ahorita estamos, como les decía, en la 4.1, aquí es donde estamos ahorita, ¿sí? Y la idea es que por ahí en el primer cuarto de Calendar Year 26 tengamos 4.2, ¿ok? La siguiente slide es una slide que no me gusta presentar porque es horrible, ¿no? O sea, no la voy a leer, obviamente, ¿no? Pero la idea es que la tengan ustedes para que cuando la bajen, ¿no? Que ustedes puedan tener acceso, puedan ver el tipo de características que hay, ¿no? O sea, la idea no es ponernos a leer aquí como locos cada cosa, ¿no? Entonces, en 4.2 vamos a tener todas estas características también y eso es lo que viene, ¿no? Como les digo, yo sé que es muy cargada la slide, no es la idea que la leamos ni nada, pero con las fotos está perfecto y luego cuando la bajan, pues ya, listo, ¿no? Algunos de los cambios de 4.1, ¿sí? Uno de los primeros grandes cambios, como le dije, es el tema de la unificación de los productos, ¿no? Es decir, en nuestras versiones anteriores nosotros teníamos que decir, mira, voy a estar en Insights, en Orchestrator o en todo el tema de Fabric Controller. Ahora eso lo cambiamos, todo es unificado. ¿Sí? Es decir, todo lo vamos a tener como un solo ambiente, ¿sí? En donde vamos a poder ver todo mi ambiente de Nexus, ¿sí? Automáticamente me va a dar la topología de los Nexus, ¿no? Porque cuéntenme cuál es nuestra principal herramienta nosotros como administradores de redes. ¿Alguien sabe cuál es nuestra principal herramienta? Lo que usamos todos los días como administradores de redes. Nuestra principal herramienta en tu escritorio, lo primero que abres, ¿qué es? TSH, esa es la segunda. El Excel, ¿no? El Excel. Entonces, tenemos todo el port mapping ahí en el Excel y que se conecta con aquel, bla, bla. Dejamos esa cosita ahí y es como si dejáramos una fruta dentro del refrigerador, ¿no? Le sale vida a esa cosa ahí solita. Cuando lo vemos, esto ya no tiene ningún sentido, ¿no? A los 6 meses que regresamos a ver ese port mapping ya no tiene ningún sentido, ¿cierto? ¿Por qué? Porque ya le cambiamos, porque ya, por mientras, ¿no? A ver, levanta ese puerto por mientras, ¿no? Y ya valió, ¿no? Ya ese port mapping ya no sirve de absolutamente nada, ¿no? Entonces, la idea que con Nexus Dashboard vamos a tener la topología al día en el momento que lo necesiten. Es decir, automáticamente se va a tener toda esa topología para ustedes en el momento, ¿ok? ¿Cómo lo hacemos? Obviamente por medio del LDP, por medio del CDP, pero también por medio de la integración con el Virtual Management que tengamos. ¿Qué quieres? Cuando digo Virtual Management, estoy tratando de abstraer y no decir vCenter, ¿no? ¿Por qué? Porque la mayoría sé que tenemos vCenter, pero muchos tenemos KVM, tenemos OpenShift, tenemos Nutanix, etcétera, etcétera. ¿Sí? Entonces, la idea es que podamos ver la topología hasta abajo, vaya la redundancia. ¿Sí? ¿Cuál es el gran problema que tenemos cuando hay, vaya la redundancia, cuando tenemos un problema y nos dice nuestro amiguito de virtualización, oye, esta máquina virtual funcionaba y ahora no funciona? Y tú lo único que ves de esa máquina virtual dentro de tu ambiente es una MAC address. Y es todo lo que ves. Una MAC address y viene de un puerto y se acabó el tema. ¿Cómo se llama esa máquina virtual? No sé. ¿En dónde está? No sé. ¿En qué SX está? No sé. ¿No? ¿Hicieron un vMotion y en ese vMotion no está puesta la VLAN? No sé. Cuando tenemos esta integración con vCenter, OpenShift, Nutanix Central, etcétera, etcétera, vamos a poder tener ese entramado de la información y entonces yo voy a poder ver la máquina virtual, dónde está conectado, en qué servidor, en qué puerto viene, en qué VLAN está, en qué por grupo está, etcétera, etcétera, hasta dónde se está comunicando del otro lado. ¿No? Y puedo tener entonces información como qué está pasando en ese cable, en esa comunicación, por dónde lo estoy comunicando, etcétera, etcétera, ¿no? Entonces, esa es la idea, que podamos tener una visibilidad completa. Entonces, cuando te digan, oye, ¿cuál es la topología de tu red? Papi, espérame. Ahí está, padre. Ya. No, oye, actualízame. Está actualizada. No te creo. ¿Cómo no? Si quieres ver el centro de datos, pues sí, chécale, ¿no? Entonces, esa es la idea que podamos tener. Entonces, una de las otras cosas es lo que decía hace un momento, el tema de la de licenciamiento. Nosotros vamos a poder tener también mezclado licenciamiento. ¿Qué quiere decir esto? Va a haber muchas veces o algunos clientes que, por ejemplo, dicen, oye, ¿sabes qué? Es que yo tengo 2 fábricas. Tengo una fábrica que es más para desarrollo o es más para IT, bla, 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 el cual la tengo con Essential. Pero para el core del negocio, ese sí lo tengo con Advanced porque tengo multisite, multipod o algo más, más elevado desde el punto de vista de características. Entonces, yo puedo tener dentro de mi propio ambiente, voy a poder tener Premier, voy a poder tener Essential y voy a poder tener Advanced, ¿no? Entonces, mezclado y entonces, obviamente, esa fábrica que estoy creando va a tener relacionada ese nivel de licenciamiento. ¿Okay? Lo cual, pues, es obviamente muy bueno para poder ser mucho más sencillo el tema de licenciamiento y de mantener ese licenciamiento. Esto nos va a permitir también, al tener nosotros el licenciamiento, toda la topología, todo el acceso a los ambientes, vamos a poder hacer entonces temas de compliance. ¿Okay? Es decir, vamos a saber cuáles equipos tengo, qué versionamiento tengo, si ese versionamiento ya está en offline y ese servidor ya está, o ese switch está en of life, etcétera, etcétera. ¿Okay? Y no solamente el tema de compliance, sino también el tema de advisory. Es decir, si hay algún problema de seguridad, ¿sí? Yo voy a poder ver ese problema de seguridad, voy a ver qué equipos están afectados, ¿sí? Y qué servicios estoy afectando. ¿Eso lo voy a poder hacer automáticamente? No, voy a tener que decir qué servicios son, o más o menos modelar el servicio, ¿no? Para yo entender el servicio al que le estoy impactando, ¿no? Pero al tener esa visibilidad voy a poder ver muy sencillo cuál es el problema, cuál es la versión que le estoy pegando el bug o el problema de seguridad y también todos los CVs relacionados, ¿sí? Es decir, voy a poder ver, oye, estás impactado por una vulnerabilidad. Estos son los CVs relacionados para que puedas hacer un análisis más profundo, ¿sí? Y puedas hacer un análisis de riesgo. Y también te voy a decir cuáles son los que están impactados y a qué versión ya se arregla, ¿sí? ¿Quieres actualizarlo? Clic derecho, actualízalo. Esa es la idea. ¿Okay? Vale. Entonces, final de cuentas, lo que vamos a ver desde el punto de vista de licenciamiento es, vamos a tener ese nivel de feature diferente, ¿sí? En donde vamos a depender de lo que tengamos desde el punto de vista de licenciamiento, lo que vamos a tener o no vamos a tener. No lo pongo acá, pero van a tener ese link en donde van a poder ver exactamente qué características hay en Advanced, al revés, ¿verdad? En Essential, Advanced y Premier. ¿Okay? Ahora bien, desde el punto de vista de los equipos que son necesarios, ¿sí? Esto antes o versiones anteriores, nosotros necesitamos a fuerza 3 nodos, un clúster de 3 nodos para poder hacer esto. Sin embargo, hay muchos clientes que nos decían, oye, espérate, pero yo tengo 8 switches, estás pidiendo 3 nodos, ¿no? Con unos servidorzotes, bla, 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 para esto, que no checa, ¿no? Entonces, lo que hicimos en esta nueva versión es que vamos a poder tener soportado en producción, porque antes era soportado en laboratorios nada más, ahora ya soportados en producción, el clúster de un solo nodo. ¿Okay? Entonces, esos clústeres de un solo nodo nos va a permitir mucho más orientado a SMB, a Edge, ¿no? Luego los clústeres más grandes y hasta llegar a clúster de hasta 6 nodos. ¿Cuál es lo que yo necesito? Dependiendo de la escalabilidad que yo estoy ocupando. ¿Okay? Esto estoy hablando desde el punto de vista de la plataforma como tal, ¿no? Los equipos que necesito yo para poder desplegar esto. ¿Por qué necesito tanto poder de cómputo? No es tanto el poder de cómputo, bueno, ¿sí? El tema es que, acuérdense, en Insights lo que estamos haciendo es analizar todo el tráfico de mi fábrica. Absolutamente todo el tráfico. Entonces, esto lo que me va a llevar es que es una gran cantidad de telemetría la que tengo que tener en mi ambiente y poderla analizar de una manera muy rápida, ¿no? Es por eso que necesitábamos, antes que hiciéramos esta optimización, necesitábamos muchísimo poder de cómputo y muchísimo storage. Lo que estamos haciendo ahora mismo es para clientes más pequeños y para clientes más grandes. Es decir, estamos haciendo scale in y scale out de la plataforma como tal. ¿Okay? Entonces, otro tema también es que vamos a poder tener, de hecho, con un cliente en México estamos viendo el tema del soporte multicluster, la idea es que ustedes tienen un ambiente grande o un ambiente distribuido en donde necesiten tener diferentes clusters, van a tener una sola visibilidad de todos los clusters. Es decir, yo le voy a tirar una IP y desde esa IP voy a poder ver todos los clusters. No es de que para norte tengo que estar esta IP, para centro esta IP, para sur esta IP. No, la idea es que podamos tener toda esa visibilidad completa. Entonces, esto lo que nos va a permitir es tener los diferentes ambientes en donde yo voy a poder ver los clusters federados desde un solo punto y también esto también lo soportamos tanto en nodos físicos como en nodos virtuales. ¿Okay? Es decir, Nexus Dashboard también puede correr en nodos virtuales. Sin embargo, estos nodos virtuales, la única requerimiento formal es que el storage no sea spin drives, ¿no? Por lo que les digo, hay que analizar mucha data en poco tiempo y necesitamos acceso rápido al disco. ¿Okay? Entonces, esto nos va a permitir tener este ambiente, ¿sí? Y vamos a, perdón, me pasé. Y vamos a poder tener una autenticación solamente de un solo ambiente y de ahí voy a poder brincar a lo demás. ¿Okay? Ahora, en las nuevas versiones, también podemos desplegar Nexus Dashboard en AWS. ¿Okay? Entonces, también esto nos va a permitir que si hay un cliente que tenga distribuido y no quiera tener esto en local, también lo puede implementar en AWS. Obviamente, esto baja la escalabilidad de esto porque toda la telemetría la tenemos que subir a AWS. ¿Okay? Entonces, obviamente, ustedes saben que eso cuesta, ¿no? Y también les va a gastar el túnel con el que están quedándose hacia arriba, ¿no? Entonces, esta nueva también hubo cambios, ¿sí? Desde el punto de vista del ambiente físico, ¿no? Como les decía, ahora soportamos un solo nodo, el cual me va a soportar hasta tener un análisis, una administración y una configuración y una orquestación de 50 switches. Lo cual para Latinoamérica, el 80% de los clientes están aquí, ¿no? Sin embargo, claro que tenemos clientes grandotes en Latinoamérica, ¿no? En donde vas a poder tener un clúster grande, ¿sí? En donde vas a poder soportar en ese clúster hasta 500. ¿Ok? Esto está basado en nuestros servidores T225. ¿Quién tiene servidores de nosotros por acá? Los UCS. Por acá, nada más. Por acá también. ¿Quién da más? ¿Quién da más? ¿Sí? Ustedes han visto que normalmente servidores terminan en 0. Todos los modelos. T220, T240, 20, bla, bla. Ahora, cuando estamos teniendo plataformas con AMD, cambiamos el 0 por el 5. Entonces, si termina en 5, es un AMD. Si termina en 0, es un Intel. Se acabó el tema, ¿ok? Entonces, no, estos muchachos de marketing. Yo digo que ocultamente dentro de Cisco hay una BU que nomás se dedica a poner nombres. Nomás a eso. Y la idea es cómo friego a los muchachos de ventas para que tengan que aprenderse todo esto, para que vayan clientes y los clientes digan, bueno, no me importa el modelo, tú dámelo, ¿no? Pero nosotros sí no lo tenemos que aprender, ¿no? Bueno, entonces, ahora está mucho más orientado, obviamente, al futuro, ¿no? Son máquinas mucho más rápidas, más grandes, y con esta nueva integración, ahora ya tenemos soporte para tener esa visibilidad y esa orquestación end-to-end con OpenStack, ¿sí? Y con OpenShift. ¿Okay? Esto es nuevo. Antes solamente teníamos firmware, ¿sí? Y teníamos Red Hat, pero no legacy de Red Hat, ¿no? Ahora bien, ya casi estamos, ¿no? En 4.2, la versión más nueva que va a salir el próximo año, ¿sí? Vamos a tener escalabilidad mucho más grande. Ya estábamos platicando de los 50 switches, 500 switches. Vamos a poder tener un clúster el cual tiene mucho más memoria, ¿sí? Y más poder de procesamiento, lo cual este clúster de 3 nodos va a tener soporte de hasta 1000 switches. ¿Okay? ¿Lo vamos a ocupar aquí en Latinoamérica? No lo sé. Pero, sí, ojalá sí, ¿no? Ojalá tengamos clientes con más de, que esto sea un problema, ¿no? Es que es algo que también platico mucho con las VUs, ¿no? No, ahora en la nueva versión vamos a soportar trillones de nodos. Pero no podemos soportar chiquitos, sí, algo pequeñito. Entonces, aquí es más difícil, ¿no? En Latinoamérica es, yo quiero que me soporten más cosas más pequeñas, ¿no? Pero bueno, la idea es de que vamos a poder tener esta configuración large, en la cual nos va a permitir en un solo clúster de 3 nodos tener hasta 1000 switches, analizarlos, configurarlos, etcétera, etcétera. Y también algo que vamos a tener aquí, como les decía, desde el punto de vista de despliegue, lo podemos desplegar en VMware, en KVM, en AWS, es lo que tenemos ahorita. En la 4.2 ya lo vamos a poder soportar directamente el despliegue en Nutanix como tal, ¿no? Y va a tener más o menos la misma escalabilidad que con VMware. ¿Okay? Entonces, bueno, esa es desde el punto de vista de capacidad, vamos a poder tener hasta 6 nodos, el cual nos va a permitir tener todo este ambiente, y la idea es en 4.2 hacerlo un poquito más alta la capacidad. Sé que hablé muy rápido, hablé tan rápido que acabé. Y me sobraron 3 minutos, ¿no? Sí, 3, 4 minutos. Ok. Bueno, entonces para redondear un poquito y aprovechando estos 3 minutos, la gran ventaja es, si ustedes tienen Nexus, ya tienen Nexus Dashboard. ¿Okay? Obviamente, implementarlo, tenemos esas dos formas de implementarlo. O lo implementamos físico o lo implementamos virtual. ¿Okay? Ahora bien, sí es bueno checar por ahí las capacidades, etcétera, etcétera, para poderlo implementar. Esta charla era mucho más orientada a las diferencias entre 3.1, 3.2 y 4.1. Si les queda duda sobre el tema de cómo funciona Nexus Dashboard Insights, cuáles son las capacidades, etcétera, etcétera, no duden en buscarnos aquí en la expo. Ahí tenemos una demo completa de Nexus Dashboard, donde ustedes la pueden ver, pueden tocar, pueden moverle un poquito, para que vean el nivel de detalle que puedes llegar desde el punto de vista de troubleshooting. Yo creo que Nexus Dashboard es una gran herramienta para nosotros como administradores de la red del data center, ¿sí? Para tener esa visibilidad, esa observabilidad que es requerido, ¿no? Evitar esos finger pointing, ¿no? Siempre me acuerdo el meme del hombre araña, ¿no? Diciéndole así, ¿no? Pues sabemos que los war room, eso es lo que hacemos, ¿no? En el war room, entramos al war room y ya saben cuál es el que gana en un war room, es el que primero cierra la laptop y dice, no es mi perro, yo no lo baño, y se sale, ¿no? Ese es el que ganó, ¿no? Y los que nos quedamos ahí, a ver, reinicia de nuevo. Entonces, bueno, es una gran herramienta, ya la tienen ustedes, la idea es dan ayuda para verlo, para tocarlo, para ver qué onda, acérquense a su vendedor o a su partner, ellos nos buscan a nosotros y podemos hacer una demo ya más personalizada para ustedes. ¿Ok? Ok, otra cosa, nada más. Ahí están todas las demos, no nada más está esta demo, está por ahí, si ven, algo interesante es que trajimos equipo físico, ¿no? De todos los switches, ahí están también los smart switches que hacen también inspección, que también están muy padres, ese es mi demo, por eso les comento. Mañana voy a platicar de los Nexus Dashboard, de los Nexus Smart Switch. Y también échenle un ojo a todos los equipos que traemos para las siguientes versiones o la siguiente ola de redes basada ya en inteligencia, ¿no? Y ya orientado a nuestros equipos de 400 y 800 gigas. Acabo de cambiar de 1 giga a 10 giga y tú me estás hablando de 800 gigas, canigo, ¿no? Pero bueno, ahí está, es la revolución que viene. Espero que les sea de utilidad. Muchísimas gracias. Y pues si hay alguna pregunta, aquí estoy. Gracias.
Hola, ¿qué tal? Hola, ¿qué tal? Buenas tardes a todos. Gracias por asistir a esta sesión. En esta sesión vamos a hablar de inteligencia artificial para todos, pero cómo hacerlo de una manera sencilla, utilizando todo lo que hemos estado viendo. Hemos estado hablando de hiperconvergencia, de la red, los servidores, etcétera, ¿no? Pertenezco a la empresa. ¿Puedes ver más el volumen? ¿Está mejor? No lo escuchan. Ahora, poco. Ahora. Ah, bueno, ahí está. Ahora sí. Ahora sí ya se escucha, ¿no? Perfecto. Entonces, mi nombre es Miguel Ángel Correa, pertenezco a la empresa Mila Telecomunicaciones, que es un Cisco Learning Partner. Principalmente estamos con sede en España y también tenemos sede en México. Bueno, hemos escuchado mucho acerca de la inteligencia artificial relevante en todas nuestras actividades hoy en día. 40% incremento en productividad. Si nosotros vamos a contratar a alguien, por ejemplo, dentro de nuestras empresas, queremos que sepa utilizar las herramientas de inteligencia artificial que lo van a hacer más eficiente. ¿Okay? Si esta persona tiene que competir con otra que no sabe utilizar las herramientas de inteligencia artificial, lo va a volver menos eficiente que una que sí lo sabe. Y si este concepto lo aplicamos a nuestras empresas, vamos a lograr un 40% de incremento en la productividad y un 60% en la reducción de errores operativos. Si nosotros mapeamos todo eso en lo que hemos escuchado en tecnología de Cisco, por ejemplo, en redes, hemos escuchado el año pasado, un poquito antes, de la evolución de las redes definidas por software, donde nosotros evitamos los errores humanos porque se hace una configuración y se baja. ¿Okay? Pero esa configuración inicial tenemos que seguirla haciendo nosotros. ¿Por qué no empieza a hacerla la inteligencia artificial por nosotros y se va mejorando con los diferentes flujos de tráfico que va pasando por ahí? Entonces, actualmente ya todos los circuitos de los equipos que proporciona Cisco ya vienen equipados con inteligencia artificial. Ahora depende del software nosotros que le saquemos este provecho para poder lograr este impacto real de una adopción acelerada y de una prioridad estratégica. La inteligencia artificial ya no es cosa del pasado, ya es una necesidad hoy en día que tenemos, que está transformando las industrias completas, desde la atención al cliente hasta la investigación y desarrollo. Ustedes van ahora a la demo de colaboración, se van a encontrar justamente la integración de inteligencia artificial para abrir un ticket de soporte con la voz. Ya hay esa integración con inteligencia artificial. Ahora, ¿qué necesitamos dentro de esas empresas para poder lograr esto? Necesitamos una infraestructura robusta. Ahí tenemos los servidores de la serie X, cómputo de alto rendimiento, tenemos los Nexus 9000 para redes inteligentes, los pods de inteligencia artificial preconfigurados para acelerar esas implementaciones. Nosotros, cuando usamos ahora ChatGPT, usamos información pública, pero si nosotros concentramos información en nuestras empresas específica y a partir de ahí queremos generar documentación específica, voy a poner un caso. Aquí tenemos, por ejemplo, a alguien de Hacienda. En Hacienda sacamos o suelen haber licitaciones. ¿Qué trabajo lleva a generar un anexo técnico? O toda la documentación que conlleva una licitación, hablando de gobierno. Pues si yo tengo la información de hace 3 años y sé la información nueva de lo que yo necesito, tan fácil sería decirle, oye, genérame toda la documentación, el Focón 4, el Focón 2, etcétera, 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 toda la documentación que hace falta para una licitación. Y el trabajo de a lo mejor 2 meses que tardamos en promedio en sacar una licitación, preparamos la documentación, la prueban y todo, puede pasar mucho tiempo. Entonces, si nosotros logramos tener esa infraestructura con la información adecuada nuestra y la instrucción adecuada, podemos hacer más eficiente el trabajo que tenemos dentro de las empresas. Otro ejemplo, si yo me dedico al catastro, en algún estado, por ejemplo, en algún municipio, y yo tengo la imagen satelital de hace 15 años con la imagen satelital de ayer, hago una comparativa mediante inteligencia artificial y saco en 4 horas todas las diferencias de lo que yo tengo que cobrar, toda la construcción que se ha hecho, cuántos metros cuadrados extra. Yo ya puedo empezar a cobrar directamente en el catastro. Ya no necesito usar los drones, necesito utilizar equipo especializado para saber cuántos metros cuadrados de construcción ha habido. Una comparativa rápida de inteligencia artificial me permite empezar a cobrar acerca del catastro en un municipio en cuestión de 1 día, 2 días, comparado al trabajo que necesita hacer para actualizar esa base de datos catastral a lo mejor en 4 o 5 meses. Con todo eso debemos tomarlo en cuenta para hacerlo más eficiente. En cuanto a seguridad, la seguridad no puede quedar integrada, por separado, perdón. El XDR vamos a utilizarlo para detección avanzada de amenazas, el Hypershield para protección de red y arquitectura Zero Trust que protege desde el diseño, y un ecosistema robusto con alianzas estratégicas con NVIDIA, Nutanix, hablaremos también de Nutanix, Intel, Red Hat, entre otros. Participamos en esta integración. ¿Qué beneficios va a traer para la empresa esta implementación? Un aumento de la productividad, mejora de la eficiencia operativa, impulso a la innovación y competitividad. Principalmente vamos a poder reducir significativamente los recursos humanos. Nosotros hacemos nuestro mejor esfuerzo, aprendemos, tratamos de invertir el tiempo necesario, pero a lo mejor lo hace más rápido una máquina, seguramente, sin cometer tantos errores como los cometeríamos nosotros. Nosotros estamos para decirle qué es lo que queremos y que lo haga la máquina. Tenemos que decirle exactamente cómo lo queremos. Entonces, todo lo que es la información, los datos, es un factor muy importante que vamos a tener en cuenta dentro de las implementaciones. En cuanto a salud, retail, manufactura, finanzas, gobierno, tenemos muchos usos para la inteligencia artificial. Tomamos en cuenta salud, un diagnóstico asistido. Imagínense que yo tomo toda la literatura de todos los libros. Porque ¿cuántos de nosotros no hemos usado el ChatGPT cuando nos duele la cabeza o nos duele algo, a ver qué tengo? Pero el ChatGPT no es médico, el ChatGPT se equivoca también. Pero si metemos toda la base de datos de literatura médica, con todos los casos que ha habido, cómo se han resuelto, etcétera, a lo mejor el doctor House se queda corto. Comparado con la inteligencia artificial, con toda esa base de datos que tiene, donde la va a analizar rápidamente una gran cantidad de información para tratar de darnos un diagnóstico, una serie de diagnósticos estimados con sus posibles tratamientos, pues estaría genial. En retail, yo tengo que estar manteniendo una persona a lo mejor para mantener los inventarios. Yo no sé cuánto compran, tengo que estar ahí tomando nota, etcétera. Una simple camarita de video, la misma que sirve para seguridad, puede estar monitorizando la existencia o el consumo de los diferentes insumos que se van comprando en las tiendas departamentales y automáticamente ir haciendo los pedidos. En las farmacias estas del bienestar, farmacia para el bienestar, que tanto habla la presidenta, ¿cómo podemos tener la cantidad de medicinas correctas? No es que no haya medicinas, nos han dicho muchos médicos que no es que haya medicinas, es que tienen diferentes nombres, y cuando los solicitan por el nombre comercial, pues resulta que el nombre técnico sí estaba, pero por el comercial no, entonces ya no se pudo surtir. Si se manejara un solo nombre, algo de manera digital, a la hora de hacer la contratación y consumo de medicamento, pues tendríamos la manera de hacer referencia a esa medicina, tanto por el nombre comercial como por el nombre técnico, y ya no habría ese supuesto desabasto que sí que hay, ¿no? En finanzas, prevención avanzada de fraude, scoring crediticio, automatizado y análisis de riesgo, tiempo real para decisiones financieras inteligentes. En gobierno, análisis inteligente de datos ciudadanos, desarrollo de Smart Cities, sistemas de respuesta rápida para emergencias y servicios públicos. Todo esto, nosotros tratamos de hacer nuestro mejor esfuerzo el día a día para poder cumplir con todo, pero no somos máquinas, somos personas. Y las personas tenemos ahora la oportunidad de mandar a las máquinas y que las máquinas hagan el trabajo pesado, disminuyendo los errores. Ahora, yo puedo tener esta infraestructura dentro de mi empresa. Sí, esa es la idea. Por eso están los pods de inteligencia artificial. Por eso tanta información. Ustedes vean cualquier persona de Cisco va a decir inteligencia artificial en todas las camisetas que vean por ahí. Y la inteligencia artificial es lo que se está manejando hoy en día. Entonces, ¿qué vamos a lograr? Asistentes virtuales inteligentes. Lo pueden ver en la sala de colaboración. Pues, acabando, pueden irse a dar una vueltecita y les van a enseñar el asistente virtual inteligente con un chat box en una pantalla. Respuestas automáticas precisas, nuevos modelos de negocio. La inteligencia artificial tiene que ser un motor de innovación para crear servicios basados en datos, productos inteligentes y experiencias completamente personalizadas. Dentro de la empresa, como va asociada a la capacitación, a la formación, nosotros estamos haciendo una herramienta de inteligencia artificial que va a correr sobre esta infraestructura, donde ustedes como usuarios o ingenieros van a poderse presentar, decir, oye, estos son mis skills, yo sé todo esto, ¿ok? Quiero tener acceso a estas ofertas de trabajo. Entonces va a ser match con alguna oferta de trabajo que cumpla con los skills, o en todo caso les va a decir qué es lo que les falta para cumplir esos skills y poder cubrir esa oferta de trabajo. Tanto útil para las empresas que contratan gente, útil para los ingenieros que quieren contratarse dentro de las empresas y saber cómo andamos o qué nos falta. Pero esa inteligencia artificial la estamos poniendo al uso de lo que nosotros necesitamos al día de hoy. Con Cisco simplificamos esa complejidad técnica. Existen los Cisco Validated Designs con arquitecturas completamente probadas y certificadas. ¿Okay? Ustedes quieren abordar una tecnología rápidamente que cumpla con ciertos requisitos, váyanse al Cisco Validated Design. Sabemos que es una arquitectura aprobada, hay una compatibilidad garantizada, integración nativa con Intel, NVIDIA, Red Hat, Nutanix y un despliegue acelerado principalmente. Ya no tenemos que esperar tanto tiempo para el despliegue de nuestros proyectos. Estos tres son los pods de inteligencia artificial que se tienen hoy en día. Nosotros, dentro de Mira, estamos comprando este. ¿Para qué? No existen cursos de inteligencia artificial. Al día de hoy tanto se habla de inteligencia artificial que no existe un solo curso certificado por Cisco de cómo implementar todo esto y llevar a cabo ese desarrollo en las empresas. Nosotros a final de año vamos a lanzar 3 cursos que los hablaré de ellos al final, con infraestructura propia. Nosotros no usamos simuladores. Es más, la inteligencia artificial no podemos usarla con simuladores. ¿Okay? Tiene que ser procesamiento, tiene que ser una tarjeta en NVIDIA. Vamos a ser el único learning partner que va a contar con esta tecnología a nivel mundial, porque ahora no hay ninguno a nivel mundial que lo tenga y que tenga estos 3 cursos. A nivel de seguridad integrada, tenemos el Cisco Hypershield, XDR y el cumplimiento y trazabilidad por diseño, donde entra toda la parte que han escuchado de Todos, Intersite, etc. Entonces, Hypershield, protección avanzada de red específicamente diseñada para cargas de trabajo de inteligencia artificial. XDR, respuesta extendida ante amenazas con capacidades de detección y respuesta proactiva para entornos de IA. Todo va enfocado a este tipo de entornos. Bueno. Escalabilidad sin riesgo. Podemos crecer poco a poco, podemos ir a través de esos modelos, estos pods de inteligencia artificial, empezando con el pequeño, que incluye un servidor. El pod grande incluye 4 servidores, cada servidor con 2 tarjetas NVIDIA. ¿Okay? Como esta charla no es una charla técnica, no nos metemos exactamente a los modelos, pero ya lo hablaremos más adelante. Es una charla de negocio para poder enfocar la inteligencia artificial exactamente en un uso dentro de nuestras empresas. Bueno, hay una metodología para poder implementar inteligencia artificial propuesta. Esta metodología incluye la parte de exploración, que es identificar oportunidades de alto valor, evaluar los datos disponibles. Fíjense que los datos forman parte fundamental, ¿ok? No vamos a usar información pública, o no se trata de usar información pública, se trata de utilizar la base de datos nuestra propia información. Formar equipos multidisciplinarios para el éxito del proyecto. Luego viene la parte de diseño, seleccionar la arquitectura Cisco ideal, incluyendo los pods de inteligencia artificial, la parte de UCS-X, los Nexus, la parte de hiperfábrica, todos los componentes que van a formar parte de nuestra data center, porque esto también va parte de ese equipo que va a formar parte del centro de datos. Luego viene la parte del despliegue. que es esa implementación rápida utilizando los Cisco Validated Designs. A partir de ahí, con Cisco Intersight podemos hacer la gestión centralizada y automatizada de toda la solución. Ya por último es escalar. Oye, ¿cómo vamos? Necesito más, menos. Pasamos, añadimos otro pod, nos pasamos al siguiente nivel. Eso va a depender de las necesidades que nosotros tengamos. Estamos hablando finalmente de poder de cómputo, CPU, memoria, almacenamiento, GPUs que vamos a utilizar mediante software, generalmente con el uso de contenedores, para poderlos empezar a trabajar, ponerlos a chambear, para que genere la información que le estamos pidiendo. La interfaz del usuario va a ser muy simple. Ellos piden, los usuarios piden. Y la solución trabaja. Dicho de otra manera, vamos a hacer un chat GPT in a box, que es una de las soluciones que Cisco y Nutanix han estado trabajando. Entonces, en la parte de exploración viene el paso 1, que es la identificación estratégica de casos de uso claros con impacto medible en KPIs del negocio. Todo lo que no se puede medir no puede crecer. ¿Ok? Entonces, la evaluación de datos es realizar el análisis exhaustivo de la disponibilidad, calidad y estructura de los datos. Si mis datos son basura, voy a obtener basura. Tienen que ser datos fiables. La formación del equipo interdisciplinario. En este caso, tiene que ver las redes, tiene que ver el cómputo, tiene que ver el software. Hay varias partes. La fase 2 es juntar el paso 2 y 3 en utilizar una arquitectura recomendada. No se quiebran la cabeza, ya existen los pods de inteligencia artificial. Ya tienen un par number, tienen un descuento. ¿Ok? Podemos empezar por algún pod pequeño, dependiendo del caso de uso. Si ya tienen ACI, pues cambiaremos un par de Nexus. Trataremos de ir hacia la red de llamada hiperfábrica ahora, con velocidades de 400 megabits por segundo. Y los Cisco Validated Design nos van a ayudar a crear esa solución y ponerla en producción lo más rápido que se pueda. Luego, en la parte del paso 4, escalar. Mediante el monitoreo inteligente, realizaremos un escalamiento por fases para nunca perder de vista la gobernanza de la inteligencia artificial. En cuanto a casos, en una empresa de retail internacional hubo una transformación digital donde se mejoró la eficiencia logística en un 30%. Si yo me dedico a mover camiones, al transporte, puedo hacer una red logística más eficiente. Oye, el uso de la gasolina, las carreteras, si hay peaje, si no hay peaje, los transportistas, los conductores, todo tiene que ver y todo lo tengo que tomar en cuenta, los costos. Y si yo tengo una persona que se quiebra la cabeza pensando en este trabajo logístico, en vez de decirle, oye, analizando esta información, esta y esta, genérame las mejores rutas, los mejores horarios para salir. Entonces, existe esa eficiencia logística con un análisis continuo 24/7. ¿Ok? Si hubo un derrumbe en una carretera, pues tómalo en cuenta. Si hubo una información de tráfico que se dio, pues tómalo en cuenta para que siempre tomes el mejor camino y seas lo más eficiente posible. Gobierno local. Tenemos muchísimas soluciones para gobierno. El ejemplo que les ponía hace rato. Si yo me dedico al catastro y necesito recaudar dinero para el gobierno, tengo o 6 meses para hacerlo o un mes para lograrlo. ¿Qué prefieren? Pues lograr, si somos gobierno, pues recaudar dinero más rápido en un mes. ¿Cómo? Bueno, puedo comparar la imagen satelital de hace 10 años con la imagen satelital de ayer. Mediante inteligencia artificial, analizar esos patrones, tenemos que desarrollar LLMs para verificar esos patrones y cuáles son las diferencias. Oye, pero es que la imagen de Google Maps me da solamente una fotografía en horizontal. No estamos hablando de Google, estamos hablando de empresas satelitales como Max, como Eagle Earth, más empresas diferentes que no sean el Google. Esas empresas realizan tomas en inclinación y la realizan hasta con una frecuencia de cada hora, información en tiempo. Y si yo comparo eso, puedo saber una construcción, cuántos metros cuadrados tuvo, si hizo alberca, si no hizo alberca, si tiene luz, si tiene pavimento. Y el señor que había comprado su terreno hace un año, que pagaba 1,000 pesos por su terreno, después de haber construido esta casa, le vamos a decir cuando llegue a pagar, ya no son 1,000 pesos, ahora serán 2,000 o 3,000 o los que sean, pero ya podemos recaudar ese dinero. Otro ejemplo, hablamos del huachicol. A ver, si yo sé por dónde pasa el ducto de Pemex, ¿qué tienen que hacer? 3, 4 pipas o camionetas a cierta hora del día cada X días a la semana. Entonces, hacemos este trabajo de inteligencia. Oye, pero es que las cámaras llegan hasta donde hay cámaras, pero desde allá arriba con los satélites nadie se esconde. Yo puedo saber de dónde salió esa pipa que está ahí esperando. Puedo saber de qué casa salió y a quién pertenece y ver las placas con imágenes. Y tener toda la información logística y de seguridad para poder hacer la captura. Otra cosa es que no lo queramos hacer, pero la información que tenemos, la tenemos. Ahora, ¿cómo juntamos toda esa información? Para poder actuar rápido con inteligencia artificial. ¿Y dónde vamos a procesar eso? Le vamos a decir al ChatGPT, oye, ChatGPT, en base a esto, dime cierta información. No, ChatGPT es público. ChatGPT lo usan hasta para jugar. Necesitamos infraestructura propia para hacernos nuestro propio ChatGPT con nuestra propia información si queremos destacar como empresas. Y a partir de ahí entra todas estas soluciones. Bueno, industria farmacéutica. Existe investigación clínica inteligente, inteligencia artificial aplicada para analizar literatura médica, lo que les comentaba también. Análisis históricos. ¿Okay? ¿Qué es lo que síntomas de gente? Les digo, con todo esto, con toda la información, agarramos 20 libros de medicina, los metemos ahí y el doctor House se nos queda cortos. ¿Ok? Entonces, ahí viene una clasificación automática, un sistema de procesamiento del lenguaje natural para clasificar y organizar esa documentación regulatoria, estudios clínicos, reportes de seguridad, etcétera. Y luego viene la validación acelerada, que es la automatización de procesos, validación médica con trazabilidad completa y cumplimiento de normativas internacionales como FDA y la parte de COFEPRIS. Podría tener un impacto organizacional con un 40% de reducción en tiempos de validación, mejora del 60% precisión de clasificación y una aceleración de 3 veces el análisis de literatura. En jurisprudencia, parte de la inteligencia artificial se hizo para ahorrarle trabajo a los abogados. Ustedes como abogados, métanse al ChatGPT y les hace toda un análisis y les hace toda una defensa de alguna persona. ¿Ok? Pero ¿cómo podemos hacerlo actualizado con nuestra propia información, teniendo una infraestructura propia? Bueno, y en cuanto a tecnología de Cisco, pues ahí están los UCSX series para cómputo intensivo, los pods de inteligencia artificial para datos especializados, seguridad integrada a nivel farmacéutico. Y es solamente un ejemplo. La diferenciación competitiva con inteligencia artificial es que tenemos nuevos productos inteligentes, optimización de costos, habilitador de confianza y transformación digital. Todo el mundo hoy en día confía en la inteligencia artificial. Si los resultados que nos dé el uso de esta solución dentro de nuestras empresas mejora nuestra productividad, nos hace ser más eficientes, es decir, entregar un resultado más rápido y correcto, entonces vamos a ganarnos esa confianza. ¿Con quién? Con el que la use, el que se beneficie de la inteligencia artificial, que generalmente va a ser toda la sociedad. ¿Cómo aprovechamos los datos? Bueno, tenemos una activación de valor oculto, que es la transformación de bases de datos históricas en insights accionables que revelan patrones, tendencias y oportunidades para el negocio. Una inteligencia artificial personalizada. ¿Cuántos no le pusieron nombre a su ChatGPT? ¿Cuántos no se dirigen a él como algo personal? ¿Quiénes no le consultan todo lo que van a hacer al ChatGPT? Pues hagámoslo enfocado a algo que beneficie al negocio dentro de nuestras empresas o de nuestros clientes. Tenemos flexibilidad total para adaptarnos a las necesidades específicas de cada industria y modelo de negocio particular. Tenemos los Cisco Variety Designs, tenemos las seguridades de la infraestructura. Recuerden, esto no podemos lanzarlo sin seguridad. La seguridad juega un factor muy importante y tenemos las soluciones que Cisco proporciona también para la implementación de inteligencia artificial. Con Cisco, la implementación de inteligencia artificial deja de ser un experimento riesgoso para convertirse en una estrategia empresarial sólida y predecible, y es lo que buscamos. Bueno, tenemos una infraestructura para crecer, arquitectura probada y validada, la seguridad sin compromiso de que nos ataquen, protección integral desde el diseño hasta la operación. Con un retorno de inversión acelerado y visible, vamos a tener mejoras. Ya no vamos a consumir tanto tiempo en lograr las expectativas que estamos buscando. Entonces, nosotros como Learning Partner también trabajamos de la mano con las empresas, con los clientes, para ayudarles a adoptar esta solución. Nos ponemos la gorra del partner, ayudamos a los clientes para poder hacer esta consultoría. Una cosa que diferencia también mucho a mí la telecomunicaciones del resto de Learning Partner es que todos nuestros instructores no son instructores de libro, absolutamente todos son consultores y trabajan en conjunto o con Cisco o con los partners que existen a diferentes niveles para el desarrollo de proyectos. O sea, se cuenta con la teoría para tratar de resolver el problema que se presenta lo más rápido que se puede, y también se cuenta con la experiencia. Yo me he encontrado gente en cursos que dice, oye, este curso lo pedí hace 2 años, me lo acaban de dar ahora. Primera pregunta, me pasó esto, ¿por qué me pasó? Segunda pregunta, ¿qué hace este comando que lo resuelve? Saben resolverlo, aprendieron a resolverlo, pero no entendieron qué fue lo que pasó, ni qué hace el comando que lo resuelve. Entonces tenemos que juntar esos dos mundos para poder abordar los problemas de forma correcta. Entonces, estos son los 3 cursos que les mencionaba. No existe ahora mismo, si ustedes buscan algún curso en la web oficial de Cisco, no existe ninguno relacionado a inteligencia artificial. Ninguno. Estos son los 3 que nosotros vamos a generar de aquí a diciembre con equipo práctico, donde les vamos a enseñar a poner en producción justamente estas soluciones de inteligencia artificial para que todo lo que han visto en todos los stands sea posible. Ustedes van con un Pure, tienen inteligencia artificial. Ustedes van con un Hitachi, tienen algo de inteligencia artificial. Van con la empresa de software, tienen inteligencia artificial. ¿Cómo ponemos en marcha todo esto? ¿En qué plataforma? Pues tenemos las soluciones de Cisco validadas que vamos a adquirir, y estos son los cursos técnicos, ya son 100% técnicos, donde van a aprender a hacer, por ejemplo, el ChatGPT en AWOX. O sea, van a tener equipo de cómputo, van a saber cómo hacer los contenedores, cómo configurar los Nexus. Hace 2 sesiones se hablaba de contenedores. La sesión anterior hablaba del Nexus Dashboard. ¿Cómo juntamos todo eso para poder poner algo en producción de la noche a la mañana? En una semana que nosotros sepamos cómo configurarlo y cómo ayudar a los clientes, a las empresas a adoptar esta tecnología para poder implementar rápidamente y ser de los primeros. Al rato todo el mundo va a ofrecer esto y todo el mundo va a saber. Es como la parte de ACI, cuando salió nadie sabía ACI. Es más, dentro de Cisco a veces ni se promocionaba. Decía, oye, no, ponlo en modo NXOS. Poco a poco todo el mundo fue aprendiendo a utilizar ACI o UCS y hoy todo el mundo lo controla perfectamente. Ahora, esto es nuevo, ¿ok? Y no me refiero a cómo manejar un servidor o cómo implementar la red, sino cómo juntar todos los aspectos para sacarle el mayor provecho a la inteligencia artificial que ofrece cada uno de los elementos que participan en la solución y realmente tener un resultado eficiente, óptimo. Entonces, nos ponemos a sus órdenes. Este es el correo de mira. Este es mi celular, mi correo personal, cualquier cosa que necesiten que les podamos hacer útiles. Nosotros solamente hacemos Cisco, no nos metemos con ningún otro fabricante. Solo Cisco, eso nos da cierta flexibilidad, apoyo, en que no les vamos a estar hablando de otros fabricantes, vamos. Siempre puro Cisco. Ahora, que tenemos que integrarnos con Nutanix. Ustedes pueden hacer un curso de Nutanix o pueden hacer un curso de estos donde aparte de aprender Cisco, aprenderán Nutanix. El licenciamiento de Nutanix, con todo el tema de VMware, que ha crecido mucho el tema de las licencias. Muchos clientes están cambiando a una solución alternativa de hipervisor. Entonces, ¿cuál es la solución perfecta? Nutanix. Entonces, Por eso se crea esa alianza Cisco Nutanix y por eso los tenemos aquí enfrente también al stand de Nutanix. Y nosotros hacemos este tipo de cursos precisamente para poder hacerlo. ¿Cómo implementar la parte de Hyperfabric? O sea, una solución de ACI con los nexus, con los enlaces de 400 megabits por segundo. Igual, eso se va a ver aquí en el tercer curso. Pero con todos los temas de inteligencia artificial que están implícitos dentro de los nexus. Oye, yo quiero que mi política de calidad de servicio, en base al tráfico que está funcionando en cierto momento, cambie. La calidad de servicio no es mago. Si la red está congestionada y va a perder paquetes. ¿Calidad de servicio qué es? Hacer que los paquetes que se pierdan no sean los más importantes para ustedes. Y lo que vamos a lograr es esa adaptabilidad dinámica mediante la inteligencia artificial que en base a lo que ustedes le digan, reacciona a ciertos flujos para que no tengan que estar ustedes ahí también teniendo que cambiar las cosas a cada rato. ¿Okay? Todo lo vamos a llevar, toda la parte de inteligencia artificial la vamos a llevar en términos de cómputo, con la parte de UCS, de los nexus y de las herramientas de seguridad que giran en torno a. ¿De acuerdo? No sé si tengan alguna pregunta. Espero que se hayan quedado con, al menos con una visión general. Les digo, esta no era un curso técnico, es una visión general de hacia dónde va y cómo esos pods y todo lo que se habla de inteligencia artificial podemos hacer una realidad en una semana a través de estos capacitaciones que vamos a ver.
El licenciamiento de ChatGPT es un costo adicional en la plataforma.
Su compañero hace una pregunta. Dice que si el costo del ChatGPT es un costo adicional. Son licencias de Nutanix. Nosotros lo que sabemos que es ChatGPT, pero nosotros no vamos a usar nada de la infraestructura de ChatGPT. ChatGPT está en los data centers de Microsoft, ahí con todos los servidores de cómputo, etcétera, ¿no? Nosotros vamos a crear mediante nuestros propios servidores de Cisco nuestra propia solución de ChatGPT, mediante nuestra propia programación de los LLMs, con lo que le queramos pedir. Vamos a crear nuestra propia infraestructura de inteligencia artificial al uso de nuestra empresa. Ese es el objetivo. Ya sea universidades, ya sea gobierno, medicina, lo que sea. Está al uso de todos los que, de todo el que quiera utilizar y tener su propia infraestructura. Pues muchísimas gracias por asistir. Gracias.
Yeah, yeah, we'll start in 1 minute here.
You can all hear me okay? Awesome. Thanks for joining. I know it's lunchtime, but appreciate you coming out. My name is Kyle Winters. I'm a technical advocate with the Learn with Cisco team, and I take a focus on security, cybersecurity, anything security related. So today I want to talk to you all about ways that you can better harden your IT environments, give you some tools and tips on how to do that. Just to kind of go over things, we'll talk about the cybersecurity landscape as a whole. And then I'll introduce to you the Center for Internet Security and the concept of CIS controls and CIS benchmarks. We'll then talk about a free open source tool that you can use to audit your systems and see how hardened they are against today's threats. And I'll give you some resources there. And we're also going to have a quiz at the end where you can have a chance to win one of these Cisco U water bottles. So if you're feeling lucky and you're paying good attention, you'll have a shot at winning one of those. So let's go ahead and jump in and talk about the security landscape today. And you know, things are different than they used to be. I mean, environments are very spread out. You don't have these kind of monolithic applications anymore. You have things that are distributed. They're auto-scaling. You're using containers and serverless functions. You've got separate services that are running, whether it's your front end on one, your database, or a billing component on another, and devices and apps, and all these things are communicating with these. I mean, the new application paradigm, it's all about these things right here. Developers want to be agile. They want to pivot to new ideas and create those new ideas quickly. They want to bring those features to market as fast as possible. That's that velocity. But they also want to be very specific. They want to have problems that solve specific, solutions that solve specific problems. They want to help you be more visible and have more visibility into how you're using the tools and the technologies across your infrastructure. But you also need to be able to scale and handle this new complexity as well too. So you have all of these components that are moving very, very quickly. Now for the attackers, things are getting more complex and moving more quickly for them as well. I mean, you used to have something where you would leverage just one or two different tactics or techniques, and now things are getting combined in a way where you're jumping across almost the entire MITRE attack framework here and leveraging lots of different techniques and tactics to ultimately achieve what you're trying to do as the malicious actor. So the threats themselves are becoming more complex, but they're also becoming more frequent. I mean, we go back to 1999, early on up until like 2015, the number of newly introduced CVEs was fairly low. But as we started accelerating the development life cycle, as things became more rapid, new threats emerged. More vulnerabilities became available. And we compare that to now, I'm sorry, just the screen. Last year, there were about 40,000 new CVEs that were introduced. That's 40,000 vulnerabilities that became public. Think about the ones that weren't public as well too, that we still don't know about to this day. So these threats are more frequent, they're more complex, and they're becoming more expensive. I mean, the average time for somebody to discover credentials once they compromise your system is about 21 minutes. The average global cost of a cybersecurity breach in 2023 is 4.4 million, and that number is going up. I mean, these numbers, it's incredibly costly, and as complexity increases, so does the cost as well. Complexity is high, that adds another $1.4 million to the average cost of a breach when it occurs. So how are these breaches happening? Well, a lot of the times, they're built on avoidable mistakes. That's the easiest way for an attacker to take advantage of something, is a mistake that can be easily avoided. And we take a look, for example, 70% of organizations have a Kubernetes API server that's publicly accessible. 72 have S3 buckets that allow public read access. Anybody can go read those S3 buckets right now. And 36% of organizations are keeping unencrypted secrets and PII available in these cloud services. So how serious is this problem of misconfigurations? 99% of cloud breaches will have a root cause of a preventable misconfiguration. That's a significant number. So it's things that we can avoid very easily. And there's, luckily for us, a framework in place to help us harden our systems to avoid these types of misconfigurations and make our systems and environments as secure as possible. And that's where the Center for Internet Security, or CIS, comes in. If you're not familiar with them, they are a community-driven nonprofit. They are responsible for what we call the CIS controls and the CIS benchmarks, which I'll talk about here in a little bit. But it's essentially a community-driven, consensus-based, internationally recognized group of security best practices and standards. Industry experts from all across the industry come together, government agencies, and they decide on what are the best practices. So you don't have to figure that out. You can go straight to this organization and you'll have that information available to you. I mean, their mission, it's clear. It's to make the connected world safer by developing, validating, and promoting timely best practice solutions that help people, businesses, and governments protect themselves against pervasive cyber threats. So very straightforward, but it's such a complex problem that it's something that gets overlooked, especially in the modern day and age where we're building things for convenience and security can be an afterthought. This puts things a little bit easier in the hands of the IT teams. So I talked about, and I briefly just mentioned, CIS controls and CIS benchmarks. So let's start with CIS controls. What are CIS controls? Really, it's a group of 18 overarching measures that are the best practices that you should take as an organization to protect your systems. These are kind of a common overarching theme, no matter what the technology is, no matter what the specific area of focus is. These are the 18 areas that you need to focus on. And I'll go into those in a second, but just to give you a quote here, this is from Harley Parks, Director of Integrated Adaptive Cyber Defense. He said, "The CIS controls take the background and knowledge of cybersecurity experts literally around the world and help focus efforts on things that are of most value, directly impacting the adversaries and challenges we face today on our networks." So hopefully that's an impactful quote. But really what it comes down to with these CIS controls, it's about simplifying your approach to threat protection. With each of these 18 controls, you got a list of safeguards, things that you can implement today to make yourself more secure. These oftentimes as well help you comply with industry regulations. So they're taking PCI and HIPAA and GDPR into account, all these different regulations from around the world, and building that into this list of guidelines. Really, it's about helping you achieve that essential cyber hygiene, help you translate this information into action, and in some cases, when you have regulations, help you abide by the law as well too. So just to give you an idea of some of those regulations, maybe some of these are of interest to you in your countries of origin, but there's a ton of stuff here. These are all built, all of these CIS controls and benchmarks are built with these types of regulations, whether it's industry or government in mind. So really, you know, these things are important because it takes a risk-based approach. It's about prioritizing what's most important for your organization and tackling those things first, helping you scale up depending how big your organization is, and ultimately having measurable outcomes that show how you progress towards there. So let's take a look at some CIS controls really quick. And the structure of them is very straightforward. It'll give you an overview of what that control is, why this control is important, what are the procedures and tools that you need to implement that control, what are the different safeguards in place there, and implementation groups. Now, what are implementation groups? That ultimately is the different level or tier of how mature or complex your organization is. So we have implementation group 1, which is basic. That's going to be for, you know, essential cybersecurity hygiene, typically targeted at small to medium organizations with limited resources. You have IG2, which is more that medium-sized one. Organizations that maybe are handling sensitive information or have moderate cybersecurity needs, that's IG2. And implementation group 3, these are the most advanced ones. And that's typically going to be for your large enterprise. You have high value assets. That's where you want to go all the way to level 3. And just so you know, let's say you're focused on IG2, that's also inclusive of the level below it as well. So you can kind of see it gets more and more complex depending on how mature and complex your organization is. But altogether, of those 18 controls, there's about 153 safeguards in place. Now, to give you an idea of some of those controls, there are things that hopefully you're already thinking about and practicing today. Things like data protection, audit log management, email and web browser protection, malware defenses. These are all things that hopefully your organization's already doing today, but it goes into a lot more detail, obviously, than just giving you this high-level category. We can take a look at access control management here as an example. It shows here, for example, with IG1, there's 5 different safeguards, all the way up to 8 for IG3. And you can see these are very prescriptive. Taking a look, for example, at 6.3 here, require multi-factor authentication for externally exposed apps. So it's very direct in a sense as you need to implement this if you want to have a more secure environment. But there'll be steps later on, which I'll show you. Those are those benchmarks that will take you through how to actually implement those. And just to show you a difference as well, too, of what IG1 versus IG2 versus IG3 looks like, that IG1 level for this one would be something like encrypt data on an end user device. Hopefully that's stuff you're already doing. Now, if you're going into IG2, encrypt sensitive data in transit. So now it's not just data at rest, it's data in motion. And if we go through the final level in IG3, it's a data loss prevention solution. So you can see how it becomes more complex, from encrypting data at rest to transit to making sure that if you lose it, you can prevent that from happening. So when it comes to different types of attacks, let's say the top 5 attacks that commonly are seen, 77% of malware attacks can be prevented just by implementing implementation group level 1. And if you go all the way through to all of them and do IG3, 94% of malware can be prevented by following these implementation groups. And you see those numbers are consistent across the board. If you take me to Las Vegas and you tell me I have a 94% shot of winning a bet, I'm going to take that bet, no problem. So as you can see, it can be very valuable to implement these. Give me 1 second to drink some water. And there's different ways that you can do it as well, too. So I recommend starting, if you're new to this, just assess where you're currently at and plan out from there. Make sure you've got the right resources in place to make these necessary changes, and start your implementation of it incrementally. Do it little by little. You don't need to do everything, all of these at once. Focus on one area first and go from there. So there's lots of documentation that's available. There's lots of tools, and I'll talk about one of these tools here in a little bit. And there's lots of training that's available. But these controls, they're very large concepts. We saw it, like implement multi-factor authentication, encrypt the end user device. But it doesn't really tell you those controls. How do you actually do that? That's where the CIS benchmarks come in. That's actually the prescription of how do you do this. So to put it simply, many of these systems are shipping with default configurations, and we design them that way so it can be easy to use. The problem with that, though, is that unless you change these, you're going to open yourself up to risk and vulnerabilities. So that's really the goal of the CIS benchmarks, is to give you that prescriptive list of these are the steps to follow for whatever system that you may have in order to be successful in defending your infrastructure. So when it comes to CIS benchmarks, we got a quote from Adam here, who works in the banking industry. He said, without this resource, the hardening of our devices would have taken a lot longer and required many meetings between IT and security to debate which configuration settings to change and the impact they could have. The CIS benchmarks provided the necessary information to alleviate many of the fears IT may have had with changing specific settings. So this is, if you're looking at hardening your infrastructure, this is what you need. I mean, again, this is a consensus-built process. So you have experts from companies, from government agencies, all across the board coming together for each of these systems and saying, these are the steps that you need to take to make these systems as secure as possible. each one of these, and I'm going to show you an example one here really quick, it's going to have a description. It's going to tell you why this benchmark is in place, why you should do this implementation, what the impact of it is. And then it's also going to tell you how you can check your system to see if this is already implemented or not, and what steps you can do, that's the remediation, to actually implement that. So it's very much telling you, this is what you need to do to check it, this is how you fix it. So there's some great resources on here on how to do this. There's PDFs, there's hardened images that are already ready to go, so you don't actually even have to do this. If you're a CIS member, you can just grab a hardened image of Ubuntu as an example, and this is all already implemented and ready to go for you. But I know a lot of us have different systems. Not all of them come pre-hardened, ready to go. You can see here, these are just some of the examples of over 100 different CIS benchmarks that exist. You might even recognize a company here that does networking devices too. So whether it's cloud services, server software operating systems, mobile devices, there are benchmarks in place for you. So let's take a look at some of these benchmarks here. I have, for example, this benchmark for Ubuntu Linux 24.04. And you can see it covers several different things. Initial setup, services, network. You got firewall on here, access control logging, all the things that you would expect to see. But for each one of these, it goes into a bit more detail. So let's take a look at SSH, configure SSH server, because that's something that everybody likes to do is SSH the stuff. There's 22 different recommendations here when it comes to how do you harden and how do you have the most secure SSH approach. So let's just go ahead and pick one. Let's say this one here, ensure SSHD permit root login is disabled. You don't want people to SSH in as root. So it'll start by giving you a description of what this is, and it'll tell you why this is important. In this case, it's not a good idea to allow people to log in as root from a remote site. But then it'll also tell you how do you check to see if this is implemented or not already. So all you have to do is run that command there on your system, and if you see that value there, that means you're set. But if you see something different, you have some work to do. And that's where the remediation steps come in. It'll tell you, for example, go to this sshd._config file and change that particular setting so that way it now says no. So for each one of these, it's going to tell you that. It's also going to tell you which of those CIS controls it maps to as well, and also where in the MITRE ATT&CK framework this maps as well. So very useful stuff. This does exist as well for Cisco devices. For example, Cisco firewall devices are on here, ASAs, things like that. They all have CIS benchmarks in place, so that way you can have secure systems. So definitely check it out. Similarly to how you do it before, you want to take an incremental approach to how do you do this. You want to make sure that you're picking the right things to do for your organization's needs, because there's a lot of customization that you can do based off of how your organization operates, but at least you have best practices and a framework in place for that. So there are some tools that exist. CIS makes one themselves, but I want to talk to you about a tool that you can use today. It's completely free and open source. It's called Linus. This is a great tool. It's put together by a group of CISOs, and it's a great way to check your system right now. So what is it? Again, it's free, completely free. It works for Unix-based systems like Linux or Mac OS, and it basically is doing automated system checks, and it compares it to the CIS benchmarks to see how compliant you are. So you can download this from the command line, run this today, and it'll look at all of these different things. It'll look at your USB device configurations that you have, users and groups, memories and process. It'll even go to the kernel level. It'll take a look at how your file permissions are configured, how your logging is set up. It'll look at all these different things, and in each side of one of these, it'll tell you whether or not you're okay, whether or not they have a suggestion for you, whether or not they found some kind of thing of importance, whether something's enabled, disabled, not enabled. All valuable stuff. And if we just take a look even closer, it'll actually give you recommendations. Hey, by the way, this is the base Ubuntu image. So this is what is on ubuntu.com. Right off the bat, you got 3 warnings. Make sure that you have IP table rules configured because you have it loaded, but there's no firewall rules in place right now. Hey, we found vulnerable packages as an example. Those are all things that are shipping with the base image of Ubuntu. And if you just go and deploy that as is, you're opening yourself up to risk. It'll also give you suggestions on how to better harden your environment as well too. So for example, installing fail to ban, which will ban a user if they try to make too many SSH connections that don't work. All of these types of things are helpful. And what it'll do as well too is it'll give you this score here. So on a scale of 0 to 100, the base Ubuntu image scores a 56, which means it's not great. It's got a lot of work that it needs to do to actually be a secure image. So that's where this tool can be very valuable in helping you out. You don't have to kind of poke around and guess. You can run a single command. It will audit your system based off of all these benchmarks and then give you a list of what you need to do next. So very valuable tool. Again, it's free, open source. I highly recommend it. So that's what I have for you today. Hopefully this was a valuable and interesting session. I definitely recommend, if you're interested in CIS, check out cisecurity.org. That's their website. You can get links there as well to the controls and the benchmarks. And if you're interested in Linus, you can go to cisofy.com/Linus and get access to it there. We also have a free tutorial that we're introducing, I believe, this week or next week on Linus as well. So you can play around with it. We'll give you instructions on how to do it and give you a workflow example of how do you go from that initial audit to hardening your system even further. So check it out at u.cisco.com. And if you're not familiar with Cisco U, you are at the Cisco U Theater right now. So hopefully you've heard of us by now. But it's our one-stop shop for learning at Cisco. So we have free tutorials, we have premium content, certification training, product training, tons of stuff on there. So I hope this was valuable to you. I have one more thing left, and as you recall, we do have a water bottle to give out, but you have to get 5 questions right, and you have to be the fastest one to get all 5 questions right too. So to make it easy for you, I have the questions in English and in Spanish. If the translation is not perfect, then I will give OpenAI a call and let them know that their AI needs to be better with translations. But let's go ahead and jump in here. Hopefully you folks are joining. Let's see here. Let's see. Doesn't look any, oh, there we go. We got Eric, Alan, German Lopez, Nelson. Anybody else? Going once, going twice. All right, everybody's having issues? Cool. Oh, there we go, Juan. All right, so you're gonna have 20 seconds to answer these questions. Again, it is in English and Spanish. So the Spanish will be the second half of it. If you wanna just read the second half of each answer, you can read it a little faster. So, first one, what is the primary purpose of the CIS controls? About 5 seconds left. All right, there we go. And that is the correct answer there. It's that prescriptive, prioritized, and simplified set of best practices. All right, number 2, how many overarching measures do the CIS controls consist of? There was a number I talked about, those controls. How many was it? Was it 56? Was it 10? Was it 18 or 25? No translation needed for the answers for this one, I hope. All right. Split it up a little bit there. It was 18. There were 18 CIS controls. Inside of those, there's different safeguards. But of the controls themselves, those high-level overarching ones, there are 18 of them. Next question. What are CIS benchmarks primarily designed to provide? Remember, there's the controls and then there's the benchmarks. All All right, let's see what we got here. Aha, looks like there's a consensus. Everybody voted for that last one there. Everybody is correct. It's those recommendations for hardening your environment. All right, the benchmarks are developed through what kind of process? Is it a Cisco internal team, government mandates, consensus development process, or is it an AI algorithm that also happens to do Spanish translations? All right, everybody's paying attention. It is that consensus development process. Last question, and then we'll see who gets this water bottle. Linus is described as a free security tool primarily for enhancing security on what type of systems? Remember, there's also all of the above as an option too. Whoa. All right. I guess I won't be drinking water anytime soon. Let's see here. So that is correct. The Unix-based systems only, unfortunately, that is not available for Windows or mobile devices. But let's see who our winner is. It's Juan. Juan, you got 5 out of 5 right in the quickest time. Congratulations. Yeah. Thank you all again so much. Congratulations to Juan. And enjoy the rest of your time here at Cisco Connect LATAM. Cheers, everybody. Thank you. All right, everybody. Thanks for joining. This is going to be an abbreviated session from something that I've done at Cisco Live several times around converting Splunk into a network management system. So taking it from the log ingestion source that you're used to and being able to make it do network things. So it should be, walk through the steps, and at the very end, there will be a repository with instructions of all the applications and the configurations of how I was able to do this, so you don't walk away empty-handed. My name is Quinn Snyder. I'm a senior technical advocate with Learn with Cisco, and I focus mostly on development, automation, and systems administration type stuff. So naturally, Splunk was kind of my next foray and focus. So I hope this is an informative session, and I'll be available for the rest of the conference if you have any questions about this.
So we'll talk about observability in modern distributed networks and kind of the challenge that it faces. And then we'll go through 3 key parts of data that we rely on as network engineers. So I'll talk about syslog and how we can actually ingest that and the benefits that ingesting syslogs with Splunk will have from a search and find and resource capabilities. And then I'll talk about 2 other very critical pieces of network information, SNMP, as well as NetFlow. So 2 things that we rely on very heavily to make business decisions for circuit upgrades and things like that. I'll wrap it up with a demo showing some of the configurations and how it's done. And then again, with the conclusion, you'll have a GitHub repository with all of the resources and readmes and how-tos in order to transform your Splunk instance into this as well. So looking at the modern enterprise, this is, may or may not be reflective of an enterprise that you work in today. So we have remote sites that sit at the edge where our business and our money is made. Those could be connected via Meraki, or it could be through a traditional Catalyst stack, whether that's through VPN tunnels or whether we're using something like SD-WAN. We have a variety of different ways that we connect those systems back to our data center or our corporate headquarters. We have our large edge routers sitting to connect to either our MPLS circuits, or maybe we have DIA or something along those lines. And then we'll have some kind of edge switching where we connect all of our services, our DMZ, passing through firewalls, IDS, IPS, and then finally our core network. So we have a lot of different systems, a lot of different components that are running in there. So like I said, we could have Meraki, we could have Catalyst SD-WAN, we could have Catalyst switching, we have firewalls in there, IDS, IPS, and they all run different operating systems, right? We could be running NXOS, we could be running XE, we could be running XR if we're large. So the network is no longer homogeneous. With those distributed networks, we create a lot of observability needs. So I've tried to color code the edges and what would be a normal response or a normal information we need to take out of those sites. So starting at the edge, we may be able to gather things like IP flow or NetFlow or IP fix at the edge. So we want to see what types of packets are flowing through. Are we getting, we have our QoS markings or something like that set appropriately for the types of traffic that we're running across there. We also have our table stakes. We may be looking at things like SNMP, whether we're trapping for ups, interface up downs, or we're polling those interfaces for statistics. That was good. Wow, that was close. I'm going to reset myself. That was good, wasn't it, Joe? We'll have to get the playback of that later. That was good. Resetting. So we may be monitoring our interface edge using SNMP. So we could pull SNMP interfaces and get the interface statistics out of there. We could be receiving traps for up-down status as well. Finally, syslog. Whether we have ports going up or down, usually we use syslog for that time of need data. We see the same thing at the edge for our enterprise. Again, we're looking at do we need to upgrade our edge circuits at our core, move from 10 gig to multi-10 gig or maybe 100 gig. SNMP and NetFlow as well. We can also throw in webhooks. So who's familiar with what a webhook is? Okay, if you're curious about webhooks and how they can enrich your visibility data, stick around for the next session with my colleague Kareem, who will dive deeper into webhooks and importing those into Splunk as well. So you can see we have a variety of different places in the network or pins that we need to monitor different pieces of information. As we talk about these different pieces of observability, right? That's the new, not going to give me this time. The observability being the new term, it's just things that we need to see from the network. So that observability needs creates tool sprawl. So starting with syslog, I came from a service provider environment where we use something like our syslog-D and piping that in and doing regex on the syslogs. You can use something like Elk, Elasticsearch, Logstash, and Kibana to ingest that. Your NMS, I know there's a variety of NMS systems that are out there that can also ingest syslog, or I've used this in the past as like a temporary fix where I need to gather some information. Kiwi syslog server on Windows is still a viable solution. I won't judge you if you use it. NetFlow, we have the same thing. The SPs are using NFDump and NFSend. However, Aquarado is an open source solution that was created by a service provider in France. You could use TIG, Telegraph, Influx, and Grafana to map your flow information. And again, you could also use your NMS. SNMP, NetSNMP is still a standard, although I love Cacti or RRD tool with those old school green and white graphs. Your NMS can do that as well. Webhooks, we can look at a bespoke webhook listener. Maybe your NMS handles it. But essentially, we've created the need of 4 different tools to monitor our network, right? And so with each tool comes updates, patches, configuration, management, and all the overhead that comes on top of that. Now, we could, if we wanted to, take all of the data gathered by each of these individual tools and send them to Splunk. So we could have each tool act as a forwarder, a collection engine that sends raw data either via JSON packets, or we have a stream that's piped to there, or we're just periodically sending logs via bash script. We can send all of that to Splunk if we choose to. But then we have 2 different tools that we have to manage. So we still have the updates within all of our existing tools, and then we have to manage Splunk and all of the ingestion systems to make sure that we have that single pane of glass for all of our data. But so we could use those tools, but why would we want to when we can turn Splunk into our NMS? So what if we could consolidate all of our tools to run inside of the Splunk ecosystem? Now, I will caveat this by saying all of my demonstrations are done on a single Splunk node. So the ingestion, the forwarding, the search head, all of the management pieces are all on one server. I'll touch on what a distributed Splunk architecture looks like if you want to scale it larger, but for the sake of argument, everything I'm doing is on a single Splunk instance. But we would use Splunk because it scales very big. So we can ingest hundreds of thousands of streams of data into a highly distributed Splunk architecture, and it's a very efficient, I don't want to say it's a database, but it's a very efficient way to log all of that information and search it very quickly and rapidly. And then the search capabilities that exist within Splunk are very intuitive, and I'll touch on that when we get to syslogs. Lots of documentation on search syntax. They have a great message board and technical assistance center for help with all that. And because it's an open app ecosystem, there's a lot of flexibility. And you'll see how we've used these Splunk technical add-ons or TAs in order to further our Splunk system as well. And finally, I won't touch on this, but my colleague will touch on the northbound Splunk API. So Splunk has APIs that are exposed northbound, so we can do programmatic things, but we can also attach that to things like MCP servers, so we can leverage generative AI to start getting some deeper insights without having to know the syntax. We can use AI to do that search for us, and then even build automated remediations using AI with that northbound API. So I'll touch on syslog first. Table stakes, everyone's been running syslog. It's like the bare bones monitoring that you can do within Splunk. So Splunk offers native syslog ingestion. It was actually built for logs. So in doing this, all we need to do is create a new syslog listener and set it up for, in this case, Cisco syslog. The reason that we set that up is it has a pre-built set of regular expressions that allow us to parse that syslog data. And by parsing that syslog data, we can get very granular search results with that syslog message that comes across. And I'll demonstrate that when we get to the demo piece of how we can very quickly add information to a search. And all you do at this point is point all Splunk devices towards the Splunk server. In my case, I'm pointing it towards my one instance, but you would point it towards your distributed systems if you have a larger Splunk setup. And this is kind of a little bit of an example here of when I talk about the search interface. Who here has played with Splunk at all, or opened it up or used the search interface at all? Brand new? You have? Okay. So if you've never used Splunk before, this is a sample syslog event that was sent into Splunk. So you can see up at the very top, this is a very standard syslog alert that we would receive. In this case, it's parsing by white space. But you can see down below, under those event actions, because I've set it up to listen to Cisco syslog, it's going to parse all of the appropriate information in there so that I can quickly search by those fields, I can add those to searches, and I can create events and alerts based on what it's finding there. So I don't have to do any complex regex like I did with R syslog-D or write my own scripts. Splunk is parsing this information automatically for me so I can quickly search and find what I need to find inside of my environment. Next, I'll talk about SNMP. So SNMP by default is not natively supported inside of Splunk. However, there is a tool called SC for SNMP, Splunk Connect for SNMP. That creates a distributed listener that will allow me to listen to SNMP traps and do SNMP polling in my local enclave. It will then take that information that it gathers and forward it via secure web, HTTPS, to my Splunk server. So in this case, I would run that application either inside of a Docker compose file, so I'd be running multiple containers, or I would run that inside of a small Kubernetes cluster. In this case, I use microkates in order to gather that information and forward that along to Splunk. Now, the nice thing about using SC4SNMP is that it is built on top of NetSNMP. So all of we've all done like an SNMP walk or you know, SNMP walk dash whatever, and we have that long string of OIDs to get to the right element. We can use whatever is built into SNMP and do it natively. So I'm not calling a long OID. I'm just calling you know, IF status or whatever like that inside of my configuration file to collect all of my Splunk, or sorry, collect all of my SNMP information, collect it inside of the SC4 SNMP app, and then forward it through either a firewall, or we could have a distributed enclave or something like that. Now, you may say, how does it scale? So because I'm using something like microkates, the throughput testing that has been done on SC4 SNMP in I think it's a 4-core, 16 gig Kubernetes cluster. It was about 20,000 events per second that it could scale to. So we're not talking about a resource heavy environment. We can run that at the edge where we need to, and then again, securely forward that to the Splunk server. And the link to all of the information for SC4SNMP is down below. And I also have that inside of my repository. Now, both SNMP traps and polling are supported. And this is kind of the internal architecture of how that all works. That's available on the SC4SNMP website. And like I said, all of those MIBs are by default included because it's all running in Python. All of those, you can get a full list of all of the MIBs that are supported for SC4SNMP at this index right here. It's all been converted from PySNMP. And because it exports to Splunk using HEC, if we wanted to, we could also export OTel, or Open Telemetry, for the status of the Kubernetes cluster itself. So we're not just gathering the information from all of our SNMP sources, but we can monitor the health of that Kubernetes cluster using OTel and import that into Splunk as well. So we can get the best of both worlds. The other nice thing is SC4SNMP maintains the full field visibility. So even though I have this application that's collecting that information and sending it along, I still get all of the rich SNMP information that I'm used to when I do SNMP polling. So it's not obscuring IP addresses or interfaces or anything like that. It's just taking that packet and forwarding along. And it supports a lightweight installation for lab exploration. I'm running this demo on a single server. So I've got Splunk, and I have the SC4SNMP app, and I have the streaming telemetry for NetFlow, all on a single server that's like 8 cores and I think it's 16 gigs of RAM. So it's running on a single box just for the demonstration purposes to explore. So we're not talking about a lot of resources in order to just lab this up. Then I'll talk about NetFlow. So by default, when we think of things like NetFlow, we generally associate it with Telegraph, Influx, and Kibana, because those are time series databases. Whereas something like SQL or NoSQL are more relationship or kind of object databases. Telegraph and InfluxDB are time series. So it's very precise in the timestamp measurement, because with NetFlow, we care about the timestamps that these packets come in so we can organize that entire flow. So whether we're looking at monitoring at the edge or using something like a Catalyst 9K with encrypted threat analytics or ETA, we want to make sure that we capture that entire flow length as well as the associated metadata along with that. Splunk is not natively a TSDB. However, using this stream forwarder application that gets installed on top of Splunk it allows me to collect all of that NetFlow data and send it along, again, via HTTP event collector, so secure web, to my indexer. We can get that very tightly correlated timestamp information as well. Now, the stream app that I'm going to mention here, there's 3 apps that are required for the streaming data. There's the Splunk app stream, the TA stream, and the TA stream wire data. And they all perform very important functions in this. So the Splunk app stream is the TA that gives me the front end dashboard and data visualization of my NetFlow data. So that's kind of like the application that gets installed on top of Splunk. Now, I'm only using this for NetFlow, but we can ingest all kinds of real-time data using this. So it's not NetFlow specific, but it does support NetFlow. And there's about, I think, 35 or 40 different data types and applications that you can stream into this app that will do that same thing, where it requires that TSDB, you point it to the Splunk app stream, and it will correlate that in a TSDB way. The Splunk TA stream, that second app there, is what is there to kind of collect all of that information in the first place. So that's kind of my NetFlow collector in this instance. So that allows me to collect, you point your NetFlow, on your routers and switches, you point them towards the devices running the Splunk TA stream, and it will collect all of that NetFlow data and then forward it along to my search head. So we would install that on universal or heavy forwarders inside of this architecture, or wherever network collection is required. And I mentioned PCAPs there, that TA stream will also support. If we're going to do a span session, we can span it right into that TA stream as well. Finally, the TA stream wire data. That's the third piece of this, and it contains all of the knowledge for the objects that I'm going to be streaming. So that 35 or 40 apps that's supported by the front end, the wire data is what allows me to decode all of that. So it's not natively, like in the case of NetFlow, it's not natively listening to the NetFlow template frames that are, or packets that are being sent. It is all included inside of that wire data package. And the documentation to deploy that is given there at the bottom. So similar to, like I said, with SNMP, on a single server installation, we would be having each of these routers or switches send the NetFlow data to the Splunk TA stream application. It's collecting that information and then sending it along via secure web, HTTPS, to my indexers. The nice thing about that is, again, because we could be exposing some kind of metadata if we wanted to with our NetFlow packets, we can isolate that to our different enclaves. So if we have a highly secure network or an OT network, we can still collect all that NetFlow data and forward it through the firewall without having to open up a variety of different port exceptions for these hosts to reach the NetFlow server there. And we configure that. It's a flat text file that we will configure inside of the TA stream app. And then we pair that with an HTTP event collector, which Kareem will dive in more because that's the foundation of webhook listening inside of Splunk. So once we have all of that data that is being sent into the indexers, we can parse it using the search app inside of Splunk. And we're able to get all of the different events there. You can see a sample of information with that. Now, the reason that we also want to put all this data into Splunk is not just for searching. We can build very important dashboards or dashboards that give us a very good pane of view into our network and how it's performing. And I'll demonstrate some of those in a second. So before I get into the actual demo here, we got about 10 minutes. Any questions so far? Okay. Let me slide over here. Okay, so this is, like I said, this is the Splunk search window for any search that we want to do here. So in this case, I have a Cisco Modeling Labs topology that's running here in the background, and I've pointed all of my routers to the Splunk instance that sits outside of that external connector there. So I'm logging SNMP. So if I do a show run, ooh, that's slow. Pipe I logging. Make this a little bit bigger. You can see that I'm just sending. I have my Splunk server set up. I'm using my management VRF, and I'm exporting all of my syslog data to 5514 on UDP. Within Splunk itself, and I will, let's see here, data inputs. I have a collector set up for 5514. parsing Cisco syslog. And so we can set some source types or we can change that around. It's very simple to set up. Once I have that listener set up on that port, it's just going to collect and ingest whatever I send to it. If I go back to my search history here, the other nice thing about Splunk is it will save my search history. And if I want to add something, I can just do add to search, and it moves that up to the top box. And I will just do 24 hours, so we should be able to get that. So you can see these SNMP traps that are being sent by that host. Now, I'm only querying based on the host IP address here. But if I wanted to highlight, like I said, if I go down here and I look at these event actions, here is all of the different information that's being parsed by Splunk using that regex that's built into that Cisco syslog. So it knows about all these different things. So if I wanted to say, I want to look at information from that host, but I only want to look at a source port of UDP 514, all I do is click on it and say add to search. So I can quickly build searches just by the information that I'm receiving very quickly. Now, once I have all of that information saved, if I wanted to create a table or a dashboard, I would take my search query and then I can do save as, and I can save it as a report. Maybe we're doing a root cause analysis. We want to do the timestamp chain of that. We can save that as a report. We can save it as an alert. That alerting allows me to do a couple of different things. I can, if it sees something here, I can fire off a webhook externally. I can launch an app that's running on Splunk. I can do API calls. I can run the Python applications running on Splunk. I can fire webhooks, or I can do some API calls to something like PagerDuty or something like that. That can be my alerting mechanism. All of that can be done through alerts, or I can add this search result to a new or existing dashboard. So the foundational pieces of Splunk is I ingest data, I build a search query, and that search query will then determine what I do with it. I can build, that's how I build dashboards. Dashboards are just searches that we then add visualizations to. Make sense so far? And this is the basic stuff. This is really easy. You can download Splunk for free, and you get I think it's a 30-day or 60-day enterprise license that allows you to ingest a lot of data. You get the full feature set, and then after that license expires, you can run it perpetually with like 200 megs of data ingestion per day. So it's a very easy thing to set up and log in and demo and test out in your environment. Okay, so the next thing I want to touch on is the SNMP portion. So let me go back here. Oh, of course it timed out. Okay, so in this case, I'm running microcates. And I can deploy, for those who are familiar with Kubernetes, I can deploy this entire application stack using a Helm chart. So it's a very easy, it's almost like an apt-get if you're familiar with Ubuntu Linux or doing some kind of homebrew updates. I just add the Helm repo and then deploy it. It will automatically deploy everything that's in this SC4 SNMP namespace. So it's giving me my MIBs, it's doing some database and Redis, it's allowing some scheduling for it's allowing a schedule for polling. I'm running some traps. So it's running that completely distributed architecture there. In order to make this all work, all I have to do is write a simple YAML file here that says a couple of different things. So I'm giving it the information for my Splunk instance, where the IP address is and the token for my collector, and what port. From there, I set up my information for my traps and for my polling. So I say, here's the MIBs that I want to query with polling. If I listen to traps, it's going to give me the community that I want to listen to. In this case, I used it for Cisco Live US. So I just have a community as clus 25 in SNMP2C. And then I give it the inventory of the devices that I want it to poll on a regular basis. So in this case, it's just those 3 routers that I have set up previously. So once all of that YAML file is written, I apply that to my Kubernetes configuration, and I am now ingesting all of that data into Splunk. So with that, we can build really neat dashboards. Let me refresh it so it looks a little bit better. Come on. Come on. In this case, all I'm doing, just to show you what the data that you'll be seeing, is between these two hosts, I'm just passing a file back and forth. So I'm just doing an SCP of a large file between the two to give me some data. You can see I started that right before the session. It is in Mountain Standard Time, so it's 2 hours behind. So don't worry about the timestamps. It actually is the right time. And so I'm able to graph each of those interfaces for each of the individual devices. So this is 101, I have 102, and I have 103. And you can see that that throughput is correlated directly with when I started that transfer. So for those of you who are used to Cacti or RRD tool to graph all these things, I tried to create something that looked a little similar to that. And you can see I've got a couple of different interfaces here with packets per second, input and output. And you can see that the two interfaces that are connecting in that row are passing packets, whereas the management, the gig 00, I have as my management interface in a VRF, I'm not passing any traffic. So that's why it's flatline there, except when I SSH in those devices. Now, what I talked about earlier was how we build these dashboards. And so if within Splunk, if you have any pre-built dashboard, you can click that little magnifying glass over there in the corner and add to search, and it will take you right to the query that you use to build that search. Now, in this case, SNMP, I have to use a stats, statistical analysis kind of thing. It's called MStats. It's different than the events. But all I've done is I've said, look at the chart it, give me the average rate of the inbound unicast packets for this device as the title, and give me the host and the span time. So I've just created this search query. Once I have that data raw, then I can visualize it. So again, everything within Splunk is built on a search query that we then visualize later on down the road. And finally, I will go here. And of course it broke, but I think I can cover this. All right, so the last piece here is the NetFlow piece. So what I've done with the NetFlow, this is a flat text file that we edit. So it's located here by default inside of the Splunk system. So it's etc apps, Splunk TA stream local, and it's called inputs.conf. Inside of that, I have my stream forwarder configuration. So in this case, point it to itself. And here's an HTTP event collector token, which again, Kareem will talk about in his session for web alerts. Define a receiver. So in this case, it's my local server, and I'm using 9996 for the port, and decode NetFlow. So I can do SFlow, or I can do a variety of other different capture methods there. In this case, I'm exporting raw NetFlow. So decode that as NetFlow, and then forward it along to the HTTP event collector that you've defined above. Once I have that all up and running, I can build other dashboards. So this is something that is a demo that I found online that somebody created. But again, you can just look at the source by adding to search. So in this case, I have traffic sources, destinations, packets per source, and I can get that same kind of RRD tool style information available through that, as well as my top talkers, something I would normally see on my router, or I want to see who's talking the most, or what do my flows look like. And then with some other add-ons, I can also build things like Sankey diagrams, which is sources to receivers. So in this case, you can see that most of my traffic is between my two hosts, 10.0.1.100 and 10.0.2.100. That's that file that's going back and forth between those two routers. But you can also see that it's picking up not only my unicast traffic, but my multicast traffic as well. So that 224.0.0.5, I'm running OSPF inside of that network, so it's gathering that information as well. So we can see not only our unicast, but our multicast packets as well. So we get a variety of aggregated information through there. Again, we can look at ports. Anything that is visible through that NetFlow packet, we can search for it and then visualize it inside of Splunk. Putting it all together, so because we can use Splunk as a single source of logging information, we can take it from a single node to a largely distributed system. We get that data correlation, so we can look at multiple sources of information very quickly just by the search query that we want to do. We can build some really nice dashboards. And again, because we can have that northbound API, there's things like MCP servers, which Kareem will touch on. We can do things like Agentic AI on top of Splunk for self-healing networks. Let's see here. This is probably what you're the most interested in. It's on the Cisco Learning GitHub, Breakops 2418. That QR code will take you there. This is an ongoing work that I've been doing to document all of the things that I did to make this, to make Splunk my NMS. So you'll have README files, installation guides, links, sample configuration files, pitfalls or things that I ran into. So using this repository will give you a good jumpstart in turning Splunk into your NMS system for your enterprise environment. And I'll leave that up. I think we're all good for pictures, but I'll leave it up. Any questions, you can come up to me after the session or I'll be around a little bit. Thank you so much for attending. I really appreciate it.
You good? All right, thank you both for joining me today. I saw you sitting in Quinn's session, and I'm not sure how much you know about Splunk, but this session is going to talk to you about a continuation of building on, how to connect your data into Splunk, but also towards the end, I'm going to show you how you can incorporate everything that we're talking about today with AI. Okay, and so with that, we're going to dive into the event-driven architectural. We're going to see what that means. Then we're going to look at the different components that you can drive around a use case from an event-driven architectural perspective, connecting your source of truth with NetBox, making and implementing changes in Meraki, and configuring alerts to be sent out when changes happen in Splunk, and then looking at Splunk and how basically all of that connects with the Splunk HEC, and I'll explain what Splunk HEC is, which builds on top of what Quinn was talking about from the different connectors that you have inside of Splunk. Then we're going to look at how this automation can, layering AI on top of it can be very, very useful and can make your life so much easier. And then from there, I'm going to show you how all of it is put together. I'm going to log into the different pieces, show you what's done and how to do it. And then I'm going to show you how we connect all of that with MCP, and we'll do a really fun demo towards the end. Okay, we're a small group, so feel free to interrupt me and ask questions if you need it. I want to make sure that you walk away learning something new that you can implement on your side. Okay, so when we get started, just real quick here, what is an event-driven architectural? So it, by definition, is EDA is a software design pattern where you essentially decouple communication through events, which means everything, any action that's taken at any specific moment, an event gets driven. So think of it as the opposite of APIs, where for APIs, you have to go and say, give me data, or for APIs, you have to go and say, here are the change I want you to make, right? With event-driven architectural, the software itself allows for the alerts to be sent out, and you basically act as traffic controller, and you decide where those events get sent out to and what action to take on. So if we look at the different pieces from an event-driven architectural, you have your producers, which are essentially the entity that generates these events, and then you have the broker. And if we look at a producer, for instance, could be anything. Could be NetBox, which support events, webhooks essentially. Meraki also supports webhooks. Splunk supports webhooks. And then you have the broker, the transport layer essentially, and it could be over anything. If you're configuring webhook, it would be over HTTP or HTTPS. A broker for events could be MQTT. If you're firing off events between IoT devices, for instance, it will be over MQTT, where you have a channel that you subscribe to, and then you basically create a publisher, and that will publish all that data out to that channel. Or it could be a Kafka bus, which is basically a giant pipeline that you pump data into. So that's your transport layer from an EDA perspective. And then if you look at a consumer, something that's going to take that data and do something with it. This typically is a middleware that you write. We've been talking about automation in general. So it could be your a Python script that you've custom written to take some action, receive that event, do some logic, and then produce it and take action on it. In our case too, it could be AI itself. So AI could receive all that data, and I'll show you how we're going to hook all of that up. And AI can take the action against all that data that we have, right? And so the combination of EDA or event-driven architectural plus AI becomes really, really powerful when we work with network automation. So this is something that if you're automating and you're an automation engineer, you're very familiar with. So you basically, let's take this use case. You have some type of network automation layer. You're talking to different controllers on your network, Catalyst Center, Meraki. Maybe you're sending out some alerts out to WebEx. Maybe you have some Grafana dashboard out there that you're pulling data from your devices and monitoring the temperature of your devices. Or maybe you have some type of database sitting somewhere that you push out updates into. As a developer, and when you're automating without event-driven architectural, what you end up doing is you end up basically accessing all these services via APIs. So you have to do the CRUD of it. You have to go and say, hey, I want to know what devices you're managing. I want to understand where they stand, pull the information I need, and then go out, do something with it, and then you have a middleware somewhere built. And if you have multiple API services in the mix, you have to handle every single one. If we flip it on the other side, and we bring in that event-driven architectural for that same automation example that we're using, which is essentially building out a single source of truth for our network, you actually have NetBox sitting there as a producer. NetBox goes out and fires off some event, and you have over the event broker that we talked about, in this case, webhooks, right? So it would be over HTTPS. The event goes out, and you have some traffic controller somewhere in the middle here that decides what to do with the event and where to send it to, whether it's going to posting a message on WebEx, updating changes to Meraki, updating changes to Catalyst Center, and all of these would actually also act as a producer. So when a change occurs on any of these controllers, they will also fire off more events into Splunk, which means that becomes also a producer. So now you have a single source of truth log truth on the Splunk side itself. Does this make sense? Any questions so far? Okay. So let's look at our use case that we're going to be building around. Carl here has been asked, Carl is our network automation engineer. He's been asked to build a solution in-house, and Carl is asked to essentially have a single source of truth for documenting the network. Also, to prevent configuration drift, Carl has been asked to automate this configuration changes. So any changes that happen in NetBox or whatever your source of truth can be, you could choose to use Excel sheets as far as I'm concerned. Those changes would go out and get pushed out to the different pieces, so to prevent configuration drift. And also he's been tasked to keep a single source of log truth for their network. So Carl here, is in a bit of a dilemma. There's a couple of options to go, but the best way to go about this is to start leveraging webhooks for all of this. So Carl doesn't have to do very minimum changes and handling of all these events that get fired. So if we look at the components, we have NetBox as a source of truth. We have as our network controller for this use case, we're using Meraki. And then there's a middleware somewhere that's hosted in, as a Lambda function that's handling all the changes. And then finally, we're using Splunk as our observability. If we look at the overall architectural design here, we have, you go in and you configure NetBox for webhooks. You say, for NetBox, whenever I see a configuration change or a configuration update, I want you to fire off an event. And within NetBox, and I'll show you how to do that, within NetBox, you basically have to tell it what's the endpoint that webhook is gonna get fired off to. In this case, whenever we want to be able to receive that, in this case, it would be a middleware, would be Python, that needs to process the JSON payload coming via that webhook. We process that payload, and then based on the information provided, we go out to our Meraki dashboard via the APIs and say, okay, make those changes to my Meraki dashboard. And then Meraki itself, whenever there is an event, whenever there's a configuration change, it's going to trigger out an alert that's going to basically say, save that alert into my Meraki index, and it's going to use heck, and I'm going to talk to you about what heck is. And that's where we have a log of all the changes. When we design this, and if we build this, this is going to essentially prevent our network from basically going into a configuration drift, because we're always starting with NetBox for our source of truth. And because it's event driven, there's very little human intervention in the middle. And so your configuration that from NetBox to Meraki is always one-to-one. And in order to see that it's one-to-one, you have that log server sitting there for you to monitor. So let's get into the different pieces here. Who's familiar with NetBox? So NetBox has a couple of ways to basically get events out of it. You have event streams, and this is if you have a deployment out in the cloud for NetBox, you can get event streams out of it, and you have to actually enable it if you're using AWS or Azure. But for our sake, for the sake of our conversation, we're using webhooks. Are you guys familiar with what the concept of webhooks? So think of webhooks as the opposite of APIs, right? So when we leverage APIs, you go out and you say, I want to get data, I want to post data, I want to put data, right? So you are doing all of this. With webhooks, the service itself is sending you, whenever an action is happening to that API or to that service itself, it's sending a data out. So you're receiving that data. And so for NetBox, we go in and say, it's going to trigger, upon update of the records, trigger out a post request via webhooks. And that's going to basically go out and go into a Python middleware that we're going to receive the JSON event from and do something with it. In our case, update our Meraki configuration. And this is what it looks like, and I'll show it to you live in our demo. But if you go out to NetBox, you basically go into event rules. There are two pieces that you need to configure. You got to configure the event rule. You got to tell NetBox, I want you to send events whenever something happens. So a record updated, a new record been added, a record deleted. So you have to specify the event type, and then you have to specify where that event is going to be sent out to. So think of it as kind of the destination of where that that webhook is going to get sent to. In our case, if you remember our design, our architectural design, in our case, we want to be able to process that somewhere. So we have a Python script Flask app sitting, or a Lambda function, if you're familiar with the cloud architectural. We have a Lambda function that's sitting there and it's listening to on the receiver that we've hard-coded here as part of NetBox that says, I'm expecting a JSON, and that JSON payload is going to look like this. I know it because it's a template, and I'm going to process it and do something with it. So that handles a configuration change. My middleware is going to use, which is my Python script that I'm sending this out to, is going to basically use basic APIs with Meraki to say, okay, now that I have the changes, I know what the intentions are, I can go and do an update, do a put on the devices based on the organization and the serial number and. When we make any changes as part of our use case that we were talking about, we need a source of truth. We want to save that as part of a single source of log truth. And this is where Splunk comes in and plays really nicely. So Splunk, Quinn here in previous sessions shared all the different ways you can ingest data into Splunk. There's one more option on the menu to do so via HEC. So HEC stands for HTTP Event Collector, and think of it as essentially a webhook receiver within Splunk. What HEC does is it allows you to send payload or data out into Splunk via that HEC. So you go in and you say, hey, I want to create a new receiver in Splunk. Splunk is going to give you a URL, and it's as part of your configuration, and I'll show you this live. As part of the configuration, you configure where you want to save that data that's coming in. So you configure the index. And anytime anything gets sent out over to that HTTP event collector, it's going to get saved into that index itself, which will make it available in the search head. And so now your data is searchable in Splunk. HEC plays really nicely in our event-driven architectural because it basically opens up an endpoint into Splunk for you to push data to. So when we configure this, we can just simply go say, I'm in Splunk. I'm going to go to HTTP event collectors. I'm going to generate a new token. It's going to give it some information, and don't worry, I'll show you this live. You're going to give it a name, where do you want to save the data into, which index you want to create, and then it's going to generate two things. It's going to generate an HTTP URL, and this is standard. So this is something, if you're trying to implement this, you got to be aware of this. It's always the HEC URL is always going to be this. It's going to be your Splunk address, followed by port 8088. That's the port that's HEC is listening to, or Splunk is listening to for events to be sent out into, /services/collector/event. If you're looking to get the exact JSON payload that's being sent from your service into Splunk, you append /raw into here, and it's going to give you access to the raw data. And the other piece of information that you need to know that gets generated by Splunk here in order to incorporate HEC into your process is the token. So just like anything, it's secure. So it's going to give you a unique token that you need to make sure that it's part of your webhook header for it to authenticate against that HEC service itself in Splunk. Does this make sense? Any questions? Okay. Now, a couple of things that I want you to do, I want you to know about HEC. If there is if SSL is not used on that's not going to work. You could send. Let me rephrase. You can send data over HTTP to a HEC service into Splunk. Most of Cisco's products will not allow you to do so. it has to be secure. But if you choose to do that for whatever service you have, just keep in mind that the data sent is going to be in plain text if there's no SSL. It's also, Heck is reliant on custom clients. You can't just have, you saw the options that Quinn talked about, some of you have the universal adapters that you have into Splunk. With Heck itself, it's reliant on custom clients. And then there's limit retry logic with acknowledgement, which means what? If it fails, you're just not going to receive the event, and you have to figure out why it failed, and you have to go back and trigger that event again. There is no auto retry on Heck. And then this is really important, the port firewall dependencies. So when you spin up a Splunk instance, Splunk enterprise instance, or if you're using a Splunk cloud instance, you have to make sure that port 8088 is open on that Splunk instance. Otherwise, all the events are going to get blocked by the firewall. So those are things that to keep in mind while trying to understand or trying to build on top of Heck. And then finally, the final piece is Meraki. So we've configured NetBox for events. We've configured Splunk to receive logs via HTTP event collectors. Now, our network controller in this use case is Meraki, and Meraki itself allows for the alerts to be sent out. So whenever any configuration changes happen in our Meraki, there are a couple of options, there are a couple of ways to get data into Splunk itself. You can use basic syslog with universal forwarders in Splunk. Quinn covered that, where you essentially create a universal forwarder in Splunk. It will give you an IP address and a port and some authentication. You go into Meraki itself. You say, whenever anything happens in my Meraki dashboard, send data into that universal forwarder, to that universal forwarder. The problem with that is you don't have the ability to control what kind of data gets sent out into Splunk. And the way that you pay for Splunk is how big of a database you have in Splunk itself. So sometimes you actually need to have some control of the logs that you push into Splunk. And this is why the ability for Meraki to have webhooks or to configure webhooks is really useful, because you can go in and you say, just like how we did in NetBox, here's the destination, in this case, the Splunk hack that we configured. Here's the destination where your webhooks need to be fired off to. And I want you to go in and you get to pick which push alerts to send out. So you can choose, okay, maybe I only care about my switches when a configuration happens to my switches. Or maybe I care about when a new admin gets added to my dashboard. I want logs of that. So you get to pick and choose which alerts in Meraki get sent out to Splunk. It's all included. The question is, do you need any special hardware to be able to manage this? Or is that included in Meraki? And it's actually a configuration in Meraki that you just simply go add and create in Meraki and pick and choose the alerts, and Meraki will ship all that out. I'll show you how that's done. Okay, so in a perfect world, this is how it would work. You make a change in NetBox, a payload gets fired off to your middleware. The middleware handles the update to the configuration in Meraki. Meraki notices that there's a configuration changes. It pushes alerts and change logs to Splunk. And anytime you can also configure NetBox for any changes to happen to also push alerts into there. So this is where it becomes really cool. Now that we have all these pieces, we can actually make those as a data source for our AI model via MCP. Are you guys familiar with MCP? Okay, so really quick, because I have about 5 minutes. I want to make sure that I get to the end-to-end configuration and live demo with you. But I want you to think of MCP as the USB-C for models. So you basically hook in like a USB, all the different data sources that you have access to that large language model, and it makes these tools available for the model to be able to access your data, and then you can start having conversation with the AI about your data and your model, asking it what's on my Meraki network, or what changes happen to my MX, or why is it showing in Splunk that change log. So via MCP, we can start actually embedding or adding AI into that workflow that use case we just discussed. So a couple of things for you to learn. I just did a session earlier today around MCP. So if you want a deeper dive, check it out. It's being published on our YouTube channel after the event. But for now, just quick, MCP is an open standard by Anthropic. It allows you to basically hook in your world, contextualize your data to the LLM. It has three different pieces that you should be aware of. An MCP, it's a client-server protocol. So one-to-one relation, you have a client, it connects to a server, you build that server. This server exposes tools. These tools are what are available for your model to be able to basically access your data. And then to manage multiple MCP clients, you have an MCP host that houses all these clients that allows you to basically chat with your data, okay? So this is MCP in a really quick nutshell. With that, let's go look at this entire use case end to end, and then let's look at the hook-in of the MCP as well with it. So first, I'm gonna show you we'll start with NetBox. So this is my instance of NetBox. This is my source of truth for my network. If I go to operation here, and I go to two pieces that I need to create a webhook. This is the destination URL. And if you see here, I have a destination of Splunk and a destination for my middleware. That's my Python script that's going to process the changes, right? And then from there, on top of that destination, I need to specify the event rules. For me, I want to ship out an event whenever a device in NetBox has been updated. I want an event to be pushed out to my middleware. I also want, whenever anything happens in NetBox, to send a log out to my Splunk instance, just to keep track of the changes, okay? So that's my NetBox piece. My Meraki, my middleware is sitting there in an AWS. It's a simple Flask application, receives a JSON, and then pushes via the Meraki APIs. I don't need to get into that. But the next piece to this is my Splunk that we talked about. So this is my Splunk instance. If I go to activities, if I go to settings, and I go to data inputs, here where I can configure HTTP event collectors to make it available for my Meraki to be able to push events out into my Splunk instance. So I can go here and say new token. I give it a name. I want to save everything that comes into a specific index. So, and if you're not familiar with the index concept, is basically what houses the data. Think of it as the database. It makes your data available to the search head so you can start searching it. In this case, I have a Meraki index. And then submit, it's going to generate a token for me. I need the URL that we talked about. I already know what it is because it's on port 8088, like we said. And I have the token. So I can take those two, go back to my Meraki dashboard now. And I go to APIs and webhooks. And I can say, under webhooks, whenever a configuration change happens, I want you to send it out to my Splunk service, which is what we just created together, using the token that was given to me by Splunk. And Meraki has that now configured. This is where we become picky on what gets sent out into Splunk by going to network-wide alerts. I specify I want webhook Splunk, you have access to that because we created it in the webhooks. And I can specify, I want network-wide events to be sent out. I want when application, something happens to my MX, switches, a port went down for more than 5 minutes. Meraki is going to automatically, without any special hardware, right, is going to automatically push all that data out into Splunk to make it available. And if I go to Splunk here, for instance, and I do a quick search, so I know my index equal to Meraki index. You can see here, I just triggered an event here prior to our session, and you can see the events that gets, the data that gets sent out from my Meraki. So now Splunk houses all my changes and everything that happened in my configuration. This is where MCP becomes really, the AI comes in super handy. Because I have 3 different MCP servers, so if I go to my Claude here real quick, I'll show you this. Let's go, let's do a new one. So Claude has access, I built 3 MCP servers around this use case. There's a Meraki MCP service that exposes the APIs, the dashboard APIs. There's a NetBox MCP server that exposes a read-only access to my single source of truth. And there's a Splunk that allows, MCP server that allows me to search my logs into Splunk. Now, I don't have to worry about cross-examining this data set myself whenever something happens. I can simply go and say, hey, can you show me the diffs in configuration between what's in my Cisco U organization, that's my Meraki org that I'm managing, and what's documented in NetBox? I want you to pull the configuration from NetBox so it knows exactly what IP addresses and configurations it has. I only want you to focus on my Cisco U org because I have 10 different organizations I'm managing, and I want you to make the report concise. I didn't have to instruct the AI what to do. There's no logic there. All I did is expose the different endpoints to my model, and it's going to inference all that information from its knowledge of the APIs. So if I process this, it's going to go out and it's going to say, I'm going to go get Meraki organizations because it knows you need to pull an org. From an org, you need to pull the network, and you need to pull the list of devices in that network. I did not tell the AI any of this. All I did was expose get org, get network, and get networks and get devices. And it came back with, it's going to get switch management. Now, it has the switch management from Meraki. It's going to go out to NetBox. It's also going to pull in the configuration, and it cross-examined everything for me. So now you can see the report that it was built. It says, here's what I found from Meraki, and here's what's documented in NetBox. For these devices, you have, the name is mismatch. So in Meraki, it's called main switch. It's called campus switch. This is the IP address that's been configured in Meraki. This is the IP address that's in NetBox. And it's telling you that these are wrong. There's a configuration drift here. I can also go further because I don't know who made these changes. I can say, I want to get more information from Splunk on who made the changes and when. Because we have also logs being pushed into Splunk, and it knows it has access to the Splunk MCP, it's going to go and search the indices that's in Splunk. It knows that there is a Meraki index there. I didn't tell it this. It's just an inference, right? And now it's creating searches queries for us to query the index in Splunk to pull the logs that I showed you. So it pulled the logs. It's a massive JSON payload, and it's updating my draft. So here are the changes. It told me that I made those changes at what time. And it gave me a log of all of this. Now, I can go even further. I'm a little bit over, and Hank here is presenting next, so I don't want to take his time. But I can go further and say, hey, this is not okay. Go and update, match my source of truth to my network to the source of truth. And because it knows, this is not okay. Kareem shouldn't have made changes. Go revert them. It's gonna go back out. It's gonna go back out and actually update the Meraki device settings without me having to make any of these API calls. The Meraki, the AI itself fixed the issue for me. So I put this on a timer, or if I put this, I build an actual agentic workflow around this, you don't have to manage that anymore. Basically, you have an agent sitting there listening. Whenever a change happens, it could go out, pick up the different pieces, and make a decision for you, and you pretty much prevent any configuration drift. So you can see how powerful this is, how you can see how easy it is to configure webhooks and event-driven architectural in your network. Everything that I talked to you about here is available for you as a resource. So let me put that up on the screen real quick for us. Oh, I didn't add the resource slide. I'm so sorry. So see me after the session. I have all the write-ups for this session as tutorials on our Cisco U, as well as I've written a bunch of blogs around MCP and how to get started. Every single MCP server here is on my GitHub, so you can just go clone that repo and get started with it. Hopefully this was informative. Thank you for your time, and apologize for going over it. Thank you.
Excellent. All right. How's everybody doing? Can you hear me okay? Excellent. All right. Well, welcome here to the Cisco U Theater at Cisco Connect LATAM. I'm excited to be here. My name is Hank Preston. I'm a distinguished architect here in Learn with Cisco, and I'm going to talk to you about one of the topics that is really flying under the radar. It's probably the first time you're going to hear about this all day, right? It's this little thing called AI. Are you familiar with this? I'm not the first person to mention it today. Oh, man. No, of course not, right? Artificial intelligence has really been changing the game all over the place, right? I'd be surprised if you can attend any sessions here at Cisco Connect where AI doesn't come up, with the exception of maybe Patrick's session, because he loves to talk about how he doesn't acknowledge AI's existence when he's talking about how to troubleshoot as a CCNP. But in this session, it's all about AI, because we need to learn some new skills, but at the end of the day, it is still packets, right? We are still network engineers that have to design secure, reliable, well-architected networks. And I want to show you how we can do that as a better network engineer by using AI rather than looking at AI as something that's just going to replace us. And that's the goal for this session. We're going to start out with introduction, which I've already started. I told you who I am. And now we're going to dive into some fundamentals and basics. I only have about 30 minutes total before you're all going to kind of start to disappear and go off for cervezas and tacos and quesadillas. And so I can't go through all of the fundamentals of AI, but we'll hit some of the key aspects. We're then going to talk about how we as network engineers will have slightly different hats, roles that we use, how AI will fit into our jobs. And we'll go into the details on that in a minute. And then part of my favorite part of this session is I've put together a handful of use cases that I think every network engineer can take advantage of AI today. And we'll look at some examples on those. And I'll get through as many as I can before we get to the end of the session. And then at the very end, we're gonna dive into some of the specifics around the skills that you should be trying to learn and earn and build, as well as how Cisco U and Learn with Cisco can help you kind of build those skills on that side. And then we'll end a little bit at the end. So AI and the adoption of artificial intelligence is not the first time we've had to change our role as network engineers, where we've had to adopt and become to understand new technologies. Right? I've been talking about the evolution of network engineering for years now. You may have heard me talk about the evolution of network engineering before. Right? Back in the day, the early days of networking, right? Networks were not the fundamental aspect of every day in an organization that it is today. Right? Networks were kind of this esoteric thing that we might use because someone bought a network printer, right? And we wanted to be able to plug it in, or maybe we wanted to, I don't know, share files from one computer to another. And so as network engineers, we dealt with kind of spanning tree and VLANs. Like that was the basics. That's all we had to deal with. And if we had a problem, nobody really cared because the network was just early and it was new. But fairly quickly, right, the .com era and the internet started to explode. Not in a real explosion, but like in an excitement explosion. Every company wanted to get on the internet, to be able to access information from the internet, to be able to share information about your company on the internet. And the network started to become part and parcel and fundamental to having a solidly built organization. And so as network engineers, we had to partner with service providers to design WANs. We had to learn about routing protocols and be able to go from one network to another. We had to deal with things like IPv6 as the growth of the internet got so big that the fundamentals of just IPv4 weren't enough anymore. And I'm thankful that we've never had to deal with another IPv4 address since then. And we've just kind of decommissioned all of those and fully adopted IPv6. I mean, you guys have done that, right? No more IPv4, right? Maybe Joe has. Now, another one of my favorite network technologies is how did we solve the IPv6 problem? With NAT, right? We just NAT behind one IPv6 address and everything's fine. The evolution of networking continued. We hit the architectural renaissance where we had to rethink some of the fundamentals of how we design network engineering. This is when the concepts around like software-defined networking started to percolate a little bit, and we anticipated like what's the future going to look like with this with controllers and white box switches, and really started to change the game. Back in the day of some of the early architectural renaissance, we thought that maybe network engineers were going to become C++ programmers. I left that behind in college. I'm really glad that wasn't one of the things that stuck around, and we adopted Python instead as we moved into the network automation era. I loved the network automation era, right? That was my time to shine. I really enjoyed learning how to deal with APIs and use Python and build Ansible playbooks and all of these things that were there. And I really thought I was going to be able to retire during the network automation era. But unfortunately, right around the corner came artificial intelligence, right? It really exploded again in the exciting way, not the scary way, in around 2020 when ChatGPT kind of publicly launched. And in the 5 years since then, can we believe it's been 5 years, right? In the 5 years since then, we're starting to find artificial intelligence show up in every aspect of our lives. And as network engineers, that means that we have to learn how to effectively use generative AI. If you don't know what that is, give me a couple of slides and we'll talk about it. We need to learn the definitions of what an LLM is and how do we run them and where do we run them. And then what's the impact on the network? For organizations that are bringing AI in-house and they're wanting to build infrastructure to support it, right? These are some really big applications. So how does that affect the network? Quality of service comes back with new approaches to it. Bandwidth has continued to just grow exponentially at this point, right? So we've got these new things that we're having to deal with. But remember, all of the stuff that artificial intelligence is bringing us today is not new. We've had to deal with this not that long ago as we brought into automation and the architectural renaissance. So don't let this AI stuff scare you, right? Dive in, both feet, both hands, because I will let you in on a secret. Nobody or almost nobody knows what they're doing with AI today, right? We are all at the very early stages of this. So experiment, talk to other people, and we will find how to use this as effectively as possible. Now, a question that I get a lot, right, is does the human network engineer even matter anymore? Right? Has anybody heard the fear, the uncertainty, and the doubt that AI is going to take everybody's jobs? We don't need network engineers anymore, right? I'm seeing some heads nod out there. I will tell you that it's not the case, right? The human network engineer still has a ton to offer your organizations and your networks that are there, because AI is just a program. It's an algorithm. It's math. AI doesn't have the years of experience that you all have as network engineers. It doesn't have the innovation that you can bring to new challenging problems. AI lacks the ability, as impressive as the AI models are today and how large these context windows and how much data you can send them, AI lacks the ability to consume and understand all of the context about your organizations and your businesses and the unique challenges your infrastructure has and the tech debt that's in the back corner that nobody wants to talk about. Like all of that stuff that you understand. AI doesn't know all of those pieces, so you have to bring that to the game. AI is also reactive, or it's retrospective. When we build these AI models, they're trained on a corpus of data that's there. And they're really good at sounding creative and innovative with the things that it knows. But as of today, AI isn't an inventor on its own, right? It doesn't legitimately create new ideas. That's where the human engineers will come from. When you need to design a network for the latest thing that's out there that is brand new, none of the AI models have any of the context, the experience, the examples that are there. And so it requires the human engineer using AI to be effective at that. Like that's really important and powerful to remember. AI is a tool for us to be more effective, but it's not going to replace us as people. Will it replace some of the jobs we do? Heck yeah. And I can't believe I'm the only person here in the room that has parts of my job that I don't want to do, right? That's the advice I give people, is find the things in your job you don't want to do and let AI do that for you so you can focus more on the stuff that you want. Another question I get a ton is, do I still need to learn networking? I can just ask ChatGPT, how do I configure spanning tree correctly? And it will probably go after me. So what is the purpose of even learning networking anymore? Well, there's a ton of really good reasons. Study after study has shown that the effectiveness of AI is directly dependent on the expertise and the knowledge of the person using it, right? You can pretend, or you can look like you might know what you're talking about if you're a novice using AI to pretend to be an expert, but that is very quickly identified. When problems happen, you have to debug or troubleshoot, things don't work exactly as expected. I was talking with Joe, one of my colleagues here. He was working with some AI to build some code, and he was able to use AI to build this code very quickly because he knew the code that AI first generated was wrong. But he knew that because of his expertise, because of his knowledge. We need to be able to look at the configurations that come out of the AI and say, okay, that's close, but it's not quite right. So let's tweak and let's adjust. We can't do that if we don't understand networking still. So please don't think that you don't need to know networking anymore. We absolutely need to in order for us to effectively use AI. And something else that's really important that I want to hone in on is this: expertise takes practice, not shortcuts. One of the things that is just true, and I don't see this going away, is that the only way to truly become an expert is through hard work, right? Would you all agree with me on that, right? There are no shortcuts to becoming an expert. And so AI can help us leverage our expertise, but AI will not enable us to like just not have the expertise. And so learning this knowledge truly is like critically important. All right, so hopefully I've convinced you all to that. So let's talk about some of the basics and the fundamentals. So I've gone into this so far and said AI a ton of times. The assumption I made is that you all knew what that was, but let's make sure we're all on the same page. What is artificial intelligence? Artificial intelligence is this technology or this science around trying to design applications and systems that can simulate human intelligence, the approach that we take to solving problems, answering questions, things that humans do. Some example things that humans do would be maybe kind of predicting what might come next, or finishing a limerick, or writing a haiku. Like these are things that people do. So artificial intelligence is this science of trying to build applications and software and systems to simulate human intelligence. So what is machine learning? Machine learning is part of this kind of area of artificial intelligence designed around how to build the actual learning aspects of these algorithms that are there, to actually take a set of data and find the patterns that are in those and train and become knowledgeable about what's going on. So machine learning is just part of the artificial intelligence area. Now, there are lots of different types of artificial intelligence, but the one that is kind of in the forefront for most of us today is something referred to as generative AI or Gen AI. So Gen AI is not the first type of AI that we've had. It's just the one that's been the most transformational recently. And generative is the key word. It generates content. It generates the simulation of new and novel things. And it does that because these Gen AI systems have been kind of consumed all of this just corpus of knowledge from the internet, public books that are out there. They've scoured all of the pictures we've all posted on Instagram and Snapchat. That's a little worrisome on its own side, but it's looked at all of this stuff that's there, so it can begin to kind of make predictions to say, this sounds like it might be a good answer to a question that I had. And it's amazing how much that generative AI process really can feel like intelligence. It's exciting to me what we can actually see from what really is just a mathematical prediction algorithm based on patterns and matching and systems that are there. Generative AI generates things. What does it generate? A lot of the time it's text. That text might be, as I said, poems or stories. It might be the answer to a question. It might be a network configuration for QoS, right? It's generating some text. It might generate images, right? You want to go through and say, hey, generate me an image to represent a star network topology for a hospital. And it could probably generate an image for that. Audio, video, like generation of new things. That's what generative AI does. Now, if there's anything that's could compete with Gen AI as the theme or the big thing that people are talking about, it would be agentic AI. Have anybody heard of agentic AI? Right? We've seen this a little bit. So what is that? Agentic AI is this concept that says, okay, I want to start providing a little bit of autonomy, agency to aspects of my AI. We've probably also heard the term human in the loop, which means I'm going to ask AI to do something, but I still have to hit the button, right? The vision, the real future and vision for agentic AI is that we can with conscious start to take the human out of the loop a little bit and allow these AI systems to do things on their own without the human interface. That sounds scary, and it can be if done poorly. But true agentic AI is based on kind of a slowly opening of the gates of allowing, once you've built trust in these systems, to say, okay, I trust that this system knows what I'm after, and I'm going to go ahead and open it up and allow that to happen. And the agentic AI can start to take action much more rapidly than we can, even if we're just hitting the approve button, by doing these things that are there. So that's the real vision of what agentic AI is. Today, agentic AI seems to start to mean that we've got these things called agents that can talk to aspects of my infrastructure. Kareem was just in here talking about it, and he was demonstrating an agent that could talk to Netbox to pull data out of there. I've built an agent that can talk to my switches using CLI and like run show commands and gather info. So that's the other side of the agentic AI, or these agents that can do more than just kind of generate text, is that they can actually kind of reach out into the real world and gather information or do things. So that's kind of the evolving definition of agentic AI. Now, every AI system at the underneath is using an AI model. And this is an area where understanding the difference between a use case or an AI tool like ChatGPT or Claude and the actual model is important because they are two distinct things. The AI model itself is like the Word document, right? You can open up a Word document or you've got the docx file that's there and it just does nothing when it's sitting on your computer. That's all a model is it's the AI algorithm. It's what's been trained and built. And until you load that up in an application that can run the model and then take input and generate output, that's where the real magic happens. And so models are things like Llama 3, right? It's a file that's been released as an open weights model, kind of like open source by the folks at Facebook, and say, here's an AI model that anybody can use, but you need an application and hardware to run it on, and you can send data in. And the models have things like how many parameters, what data was it trained on, right? Is it really good at kind of doing translation, or is it really, really good at answering network-related questions? Like the model itself is just kind of this bit of an algorithm that you're going to run someplace that's there. And when you run that, what are you going to do? You're going to send it what we refer to as a prompt. A prompt is the input that you're going to put into the AI system. And the prompt might be, write me a limerick describing how spanning tree works. Like that is a prompt. And then it will generate a response that is likely a limerick about how spanning tree works. Now there's the other side of it is prompt engineering. And this is what I like to refer to as the art form of creating really good prompts. Because one of the things that I imagine many of us have all seen in our personal experimentation with AI is that the quality of the response you get from the AI tool is directly correlated to how good you wrote the prompt. If you're vague, you're not necessarily going to get what you're after. If you provide examples, if you use certain flags and patterns in how you ask your question, it will be a more effective question or response as it comes in. And that's what prompt engineering is. It's this art form of learning how to effectively ask a question of AI. And that is a key skill that I think we do need to understand. Okay. Hallucinations. These are one of the dangers of AI. A hallucination is the idea because these LLMs, these models, were designed as a predictive engine. No matter what you do, when you ask any prompt, the AI model is going to generate something. A lot of the time, that something could be accurate. But sometimes it may have been like the model laid down on a field someplace and looked up at the clouds and just invented something completely new. And the difficult part is AI is so good at sounding intelligent that unless you know the context enough, unless you have a bit of domain knowledge about whatever you're asking, is you may not recognize that it is just completely wrong. Completely wrong. And I have no doubt that you've all seen stories of folks that have just put questions into AI and just took the answer and just assumed it was right. And then they end up like usually quite embarrassed when somebody calls them out and says, well, that was completely wrong and you clearly just used AI for it. And so another skill we have to have is being able to critically think about what we do when we use AI to identify and react to the hallucinations that are in place. And then lastly in this section, like why is the network important? Why did Cisco have such a really good year last year, driven heavily by the AI explosion in data centers? And it's because the applications that run these AI models inside of the data centers of OpenAI and Facebook and Google and Microsoft and everything, right? Those applications don't run on one system, one server in a rack someplace. They run in hundreds of servers across entire data centers. And there's so much data that has to go back and forth that we need to have a very effectively built highway of pipes, highway of network inside of the data centers to allow these compute nodes to talk to each other. And that's why a well-designed, high-performing network is so important to the people building and running these AI systems that are there. Now, I mentioned there's different ways we're going to interact with AI as network engineers, and I call these hats, right? A lot of the times, the primary way that many of you have probably interacted with AI so far is simply as a user of AI tools, right? Has anybody ever opened up any of these AI tools and sent a prompt? I don't care what it is. Have you done that before? Yeah, you've all been a user of an AI tool. Another thing that we will have to do is we will have to become supervisors of AI tools. Because like it or not, these AI agents, these systems are going to come into our organizations and our network operations teams. And part of our job as network engineers in the future will be supervising those AI tools and making sure they're doing things correctly. And then lastly, some of us, maybe most of us, will also be builders of AI infrastructure, making sure that our infrastructure is designed in a way that it can handle these AI applications. Now that's no different than we had to become builders of collaboration infrastructure, right? Has anybody had to build a network that had an IP phone plugged into it? I'm sure we have, right? We're going to be doing the same things. And we just have to know that there are aspects of designing and building AI networks that have to be done correctly on that side. So a couple of examples we'll kind of go in. What do I mean by user of AI tools? We're going to use AI as part of routine tasks and data analysis. This is an area that I use AI almost daily for, is to help me kind of do just my day job, right? I'm doing research on some topic. I'll use AI as part of that. I've got this 100-page white paper that I've got to figure out what's going on. I'm going to analyze the data with that. Maybe I'm working on some configurations or slides for a presentation, and I want to create some nice eye-catching imagery, like that one of the guy laying on the field looking at the clouds, right? We can use AI to generate content. We can do traffic forecasting. All of these things we do as network engineers, many of them can be bolstered by using AI effectively. When we move into supervising AI, we need to become strategically orchestrate and troubleshoot these AI interactions. So as agentic AI truly takes off, one of the things we're going to have to do is to actually monitor, like, how are these agents taking and sending data between each other? And that is something that we're going to have to supervise. We're also going to, as much as I hate the concept of human in the loop, it's a kind of a personal thing that I have, is I don't like that idea, but a part of what we're going to have to do as supervisors is validating AI-driven decisions. Because today, we can't actually fire the AI when it makes a bad call, right? There has to be somebody that is on the hook for approving that. And so a part of our job is going to be verifying and validating those details. We're going to have governance and accountability, right? I talk about this a ton. If we're going to use AI, can we trust that AI? If I send data to it, is it going to be maintained private, right? How do we choose which AI tools make the most sense? That's an aspect we have to handle. And then when we're building the AI infrastructure, right, we're going to build the networks to run these applications. We're going to want to be able to enable agentic AI for our network, right? What does it take for an agent to actually talk to my network systems? And God, it'd be great if we only had one network system, but we've got dozens of network systems that are there. So we have to be truly effective at knowing what's there. So there's so many things that are going to be involved in building out these AI infrastructure we have to be after. All right. Boy, time really goes fast. So I'm going to go through a couple of AI use cases before we close this down. So one of the easiest ones to go after is just using AI as part of our kind of research of information. So here's an example where I'm using AI to help me prepare for a network change. Right? I could go to Cisco.com, I could grab the release notes, I could read through those hundreds of pages, or I could just ask an AI system, right? I'm trying to do an upgrade for Catalyst Center, right? And I can natural language ask questions about what that system is like and use the AI tools to help me consume the info. Now, this is an area, again, where my domain knowledge has to factor in, because every now and then a hallucination will squeeze in, and you might want to verify with where the source material came from. But using AI as part of your research process and processing the data is an easy way to get started with AI. Now, hallucinations come for a variety of reasons, but a big one is because the source data used to train the models almost invariably has really good information, correct information, but the source data also has really bad information, wrong info. And so we can also use AI with and extend it with something called RAG, Retrieval Augmented Generation, which is where we say, okay, AI, I want to ask you a question, but please limit your answers to the things that come from this set of documents. And in this case, I've uploaded a whole bunch of Cisco configuration guides. And so now when I ask a question, I can be more confident in the answers that come out because it should have been generated just by the information that came out. And so here I've uploaded those. I ask a question about use the Cisco library. How do I check the status of my IPsec tunnel? It can give me this type of information that's out there. Really good ways to kind of dive in on those. And then I think one of the second to last ones I'm going to go after here from an example as I look at the time is one of my favorite use cases. Now, I'm real cautious about recommending people to use AI to generate network configurations today. We'll get to that more and more in the future. But what you can use AI today is to help like a fellow network engineer working with you. And so in this example, I've got a configuration template that I've created, and I'm going to use AI to take a look at it and provide me feedback, like I might do with a coworker or a Cisco partner or TAC, and say, I want to apply this config. Can you take a look at that and give me your feedback and your thoughts? This is an excellent way to use AI today, right? I can go ahead and it can look at it. And in this case, it's gone through and found a couple of mistakes I had in that configuration. It's analyzed it. It's given me some good recommendations. There's so many high potential ways. And this is an area where I'm still using my expertise to create the configurations, the standards, but I'm getting feedback from the AI tools that have the training data plus potentially those documents that I've uploaded as part of that RAG upload. So we can combine some of these use cases together. All right, so I'm going to jump ahead just a touch to here. So what are the skills we need to be effective as an AI-enabled network engineer? And I threw some stats in here. 184% growth for AI-related skills and jobs. These are demanded by organizations and employers today. So this isn't one of those cases where I'm just going to talk about a few things that maybe you might want to learn. No, you absolutely want to learn these because you will get a higher salary if you can prove that you've got some of these AI skills, that you're comfortable on that side. And so what are we going to learn? Right, I break these down into a couple of buckets. The first one is general AI proficiency. These are not specific to network engineers. This is stuff that just to be a person working in the world with AI, we need to have, right? We need to have critical thinking skills. AI is not the reason we need critical thinking skills. We've always needed them, but we really need them when we're using AI to be able to effectively understand and kind of process through it. Fundamentals like prompt engineering, right? And for years, I've been talking about learning Python as a network engineer. And I'm not saying that with AI now, everybody has to learn Python. But there is some value if you have some fundamental programming skills, at least right now, because of how AI is being integrated in places. On the networking side, there are some specialized AI skills related to networking that are worth diving into once you have some of the fundamentals in. So how AI is going to fit in with AI ops and NetDevOps. What is AI's impact going to be around kind of hardware choices and acceleration? Cisco is now selling switches that have AI chips in them. Why are we doing that? You might want to know. So you're going to have to learn some of these fundamental details that are out there. And if you happen to be an automation engineer, right? If you do write network automation code, there's some additional automation specific skills you're after, right? You need to learn how to take advantage of LLMs inside of your code for natural language processing. You need to understand maybe how to build an agent, how to use protocols like MCP that are there. Tons of things that are needed. And then on the security side, there are some security specific skills we need as well, right? So these are things that we can start to build. You're not going to learn all of these things all at once, right? You're going to evolve. You're going to start with the fundamentals. You're going to build up on that. But this kind of gives you an idea of where your journey might go after. And speaking of the journey, right, you may be asking yourself, okay, Hank, this sounds really good, but how am I going to learn it, right? How am I going to learn all this information? Well, thankfully, you can learn AI with Cisco, right? We will help you learn the AI skills that are there. Our entire team practically these days feels like is doing nothing other than helping people understand how AI works. We have a robust roadmap of products and training materials that will hone in and allow you to learn what's out there. And just recently, within the last couple of weeks, we released this one here, the first version of it, AI Business Professional, to help you with some of those just fundamental AI skills that I talked about. Learning how to effectively do some of the critical thinking. What are the AI tools that are there? How does bias factor in? Like all of these things are really, really important to become effective at AI. Now, I've been told that eventually these slides will be made available for all of you to download. So I don't know exactly the mechanism of how you're going to get the slides, but when you do get them, I've buried links for a whole bunch of ways you can start right now with free resources from Learn with Cisco, both what we have on Cisco U as well as what we have in our Network Academy program, to help you start today learning how to use AI, supervise AI, and build AI infrastructure. So we really are helping you make sure that you're ready for this next transition that's in place. All right. So and again, I'm not exactly sure. Somehow these slides are going to make their way to you, either through an app someplace or a post-event email. So be on the lookout. If they don't come to you, my email is going to be in a second. Just email me and I will send you the slides directly, because I want you to have them. Because in kind of the takeaways here, right? AI is here to empower us as network engineers. It's not here to replace us, right? Now, I'll be honest, if we don't do this, if we can't handle these transitions effectively as engineers, it can be challenging, right? I've seen the headlines of people having troubles and organizations figuring out how AI factors in. But used effectively, if you upskill yourself, it will absolutely empower you. But you do have to make yourself valuable by learning these skills that are there. From Cisco U, from Network Academy, we will continue to put new material out there to help you upskill yourselves that are in place. So just stick with us on this. We've done this through all of these other evolutions: automation, the SDN changes, the collaboration back in the day when voice over IP happened. Cisco learning and certifications and training have helped you make those transitions, and we will continue to do that for you here. And so I promised my contact information. There it is. If you have any questions on this, right, I'm excited to help network engineers continue to be really good network engineers. And that's not just me, it's our entire team at Learn with Cisco. But if you do get stuck, feel free to reach out to me. My contact info is there. I'm also pretty easy to find. And I've been more actively blogging up on our blog site related to my own journey learning about AI. Because, as I mentioned, right, nobody knows about AI everything yet, right? We're all learning this together. Right, the stuff that I thought I knew and I thought I understood 2 years ago has changed dramatically from what I know and understand today. And it will do the same for all of you, right? The whole journey of learning something new is being like, you learn a little bit and you think you know everything, right? Because there's all the stuff you haven't learned yet. And so we're all on this journey together. So stick with us on that. Enjoy the rest of your time. The Cisco Connect event continues tomorrow, and I have no doubt that there's plenty of other sessions everywhere. But I can guarantee there's more sessions tomorrow on AI in the Cisco U Theater, because I'll be here tomorrow afternoon talking about how we can actually use AI locally on your laptops, and you can restrict or remove some of the security, the risks that are involved. So if you're really excited about that, check out our schedule on the board back there. It should be in the app as well. Come and join us in the Cisco U Theater tomorrow. And with that, thank you so much for joining me for a little bit of time here at the end of the day. I hope this has helped kind of you get excited about AI, because I certainly am, and there's a ton we can do with this. All right, I think it's Cerveza time, folks. Thanks.